I will say much more. I just will give the floor to Vicent Botti, who is the Director General of ValgrAI. Thank you.
Thank you, Ana. Bienvenidos, ¿no? Benvinguts, bon dia, a esta quinta edición del foro, ¿no? Del Consejo Científico de ValgrAI. Thank you very much for your attendance, both in person and online. I would especially like to thank Vice Rector for Research of the Universitat Politécnica de Valencia, Belén Picó. Thank you very much, Belén. And the Director General de Universidades de la Generalitat Valenciana, Rafael Sebastián. Thank you, Rafa, for coming here. Esther, Belén, Rafa, thank you very much for your continued support of ValgrAI, thanks to which we are able to hold events like today's. A special thanks also to the members of the ValgrAI Scientific Council who are joining us once again this year, both in person and online, and who are also participating in various activities throughout the event. Many thanks to Ramón López de Mántaras, no? Our President of the Scientific Council, Tom Dietrich, thank you, Tom, Virginia Dignum, and Hiroaki Kitano, who are joining us in person this day. In today's session, we will have talks by Virginia Dignum, our colleagues from the Universidad Miguel Hernández, José Mª Azorín, and Hiroaki Kitano. Our collaborating companies will present the work they are doing. We will also have a part of the program that is very special to us, our young talent. No? Those who are currently working on their doctoral thesis will tell us about the research they are conducting. This is for us an amazing experience of this young talent. I would like to remind that tomorrow's session will take place in the Salón de Actos of the School of Informatics Engineering, that is near of this site. It would include several talks by some of the most prominent researchers from the ValgrAI Joint Research Unit, which is made up approximately 90 most relevant artificial researchers from the 5 Valencian public universities. And we will also highlight interesting roundtable moderated by Ramón López de Mántaras, featuring the participation of Virginia Dignum, Tom Dietrich, and Hiroaki Kitano. Thank you very much, and I hope you enjoy the conference. Next, I request the presence of our Vice-Rector.
Thank you, Vicent. Good morning, everyone. It's a great pleasure to welcome you to the Universitat Politécnica de Valencia. On behalf of our rector and on my own behalf, as Vice-Rector for Research, I would like to extend a warm welcome to all the distinguished members of the Scientific Council, the keynote speakers, colleagues from universities and research centers, representatives from industry, and all participants join us for the ValgrAI Scientific Council Forum 2026. The Universitat Politécnica de Valencia is proud to host this edition of the forum, bringing together some of the world's leading voices in artificial intelligence, alongside outstanding researchers from our own community. It's both an honor and a privilege to welcome you to our campus. First of all, I would like to express our sincere gratitude to the regional government, Generalitat Valenciana, represented here today by the Director General of Science and Research, or of Research and Science, I don't know, Rafael Sebastián, for its continued commitment to higher education, research and innovation. A strong public support is essential to foster scientific excellence and to make collaborative initiatives such as ValgrAI possible. I would also like to extend my sincere appreciation to the members of the ValgrAI Scientific Council. We are especially honored to welcome such an outstanding group of internationally recognized scientists. Your expertise, your guidance, and your global perspective are invaluable in helping us strengthen our research ecosystem. Your presence here is both a privilege and an inspiration. Finally, I would like to express my sincere gratitude to Professor Vicent Botti for his vision and leadership, to Cidad for introducing us, and to all the members of ValgrAI for your outstanding commitment and dedication. As a technological university, the Universidad Politécnica de Valencia has always believed that artificial intelligence is not only about developing more powerful algorithms, it's about creating knowledge, solving real-world challenges, and generating innovation that improves people's lives. We have a growing academic offer in this field, an ecosystem of international recognized research groups working across the full spectrum of artificial intelligence, from machine learning, robotics, and computer vision, to natural language processing and intelligent manufacturing, healthcare, energy, and sustainability, all with a strong commitment to knowledge transfer and innovation. Artificial intelligence connects disciplines, people, and ideas to create solutions, but scientific excellence grows stronger when knowledge is shared across institutions. This is precisely what makes ValgrAI, that connects the complementary strengths of the 5 public universities of the Valencian community, such an inspiring initiative. ValgrAI has created a shared ecosystem that educates talent, attracts researchers, accelerates knowledge transfer, and strengthens the international visibility of our scientific community. Today's program perfectly reflects this vision. We have the privilege of welcoming internationally renowned pioneers in artificial intelligence, showcasing cutting-edge research developed within the ValgrAI community, giving visibility to outstanding young researchers, as it has to be, and fostering dialogue between academia, industry, and public institutions. Let me conclude by reaffirming the strong commitment of the Universidad Politécnica de Valencia to ValgrAI and to all initiatives that promote excellence in research, innovation, and international collaboration. Because ultimately, the future of artificial intelligence will not be built by individual institutions, but by communities of researchers working together. That is precisely what ValgrAI represents. Thank you very much, and I wish you an excellent forum. Congratulations.
Thank you very much, Belén, for your work. Next, I request the presence of Rafael Sebastián, director general de Ciencia y Investigación de la Generalitat Valenciana. Muchas gracias, Rafa.
Vice Rector of Research of Universidad Politécnica de Valencia and Universidad de Valencia, Director General of ValgrAI, Vicente Botti, Managing Director, and Cidad, members of the Scientific Council, researchers, companies, students, ladies and gentlemen. Dear friends, good morning to you all. It's a real honor for me to take part in this opening of the ValgrAI Scientific Forum 2026. This forum is not a simply scientific meeting, it's a statement of ambition, the ambition of a comunidad that wants to be at the center of one of the defining conversations of our time, artificial intelligence. And artificial intelligence is no longer belongs to the future tense. It's already here, in laboratories, in companies, in hospitals, in industry, in water management, in education, and even in the way we generate scientific knowledge. That's why the question cannot be only what AI can do for us. The real question must be what we want AI to do, for whom, with which safeguards, and in the service of what model of society. The program of this forum frames that conversation with great precision. It speaks about the paradox of artificial intelligence and about how to understand a complex future. It speaks about neurorehabilitation, brain-machine interfaces, privacy, smart cities, industry, health, water, and scientific discovery. And it dares to raise an uncomfortable question, but essential question. With Claude, GPT, Gemini, and so many other systems, is this really the artificial intelligence we want? And that question matters, because artificial intelligence cannot be reduced to a race for computing, model size, or speed of adoption. It must be a race for scientific quality, public responsibility, technological sovereignty, trust, and real impact. To our international speakers and guests here, welcome to Valencia. The Valencian community does not want to be merely a user of artificial intelligence. We want to be a place where excellent science, responsible innovation, and European values meet. A place where AI is not only more powerful, but also more trustworthy, more human-centered, and more useful for society. From the Generalitat Valenciana, we are convinced that POPTA modern science policy cannot limit itself to funding isolated projects. It must be built in an ecosystem. It must connect talent, infrastructures, data, companies, universities, research centers, and public administration. It must create the conditions for excellent ideas, not to remain only in a scientific paper, but to become solutions, technology-qualified employment, and well-being. That's why ValgrAI here is strategic, because it represents a network for training, research, and knowledge transfer in artificial intelligence, both from collaboration between Generalitat, the 5 public universities, and the productive sector. ValgrAI is not only a foundation, it's a piece of institutional architecture designed so that the Comunitat Valenciana can have its own voice in European artificial intelligence. And when we speak about commitment, we also speak about investment. We speak about our plans, like the Gen2T plan, or the plan we have to attract scientific talent, or Valer program, with planned investments of 17 million euros over the next year to incorporate distinguished researchers of international excellence. We speak about high-impact research group, knowledge transfer, scientific entrepreneurship, infrastructure, and system-wide vision that will be structured through our future Plan 2030 for science and research. In this context, I would like to underline a particular milestone. The first researcher selected under the Valer call in the Comunitat Valenciana, or Distinguished Research Program, has joined ValgrAI. Professor Wael Elderedi, with an international track record in neuroengineering, brain dynamics, brain-computer interfaces, represents exactly what we are seeking through Valer: to attract frontier scientists, connect it with our institutions, and turn it into a lever of excellence for the whole Valencian ecosystem. Knowledge transfer should not be understood as the final step of research. It must represent, from the beginning, the way we define challenges, connect researchers and companies, use public data safely and ethically, and bring science closer to public service. That's why this forum matters, because it brings together those who research, teach, create companies, invest, regulate, and apply artificial intelligence to real problems, and because it reminds us of something essential. The future is not something we wait for. The future is designed, funded, and governed, and served. From the Generalitat Valenciana, we will continue to support ValgrAI, our universities, our researchers, and our companies on that path, with funding, stability, strategic vision, and with a deep conviction that Comunitat Valenciana has the talent, the institutions, and the ambition to become a European benchmark in responsible and applied artificial intelligence. To finish, I expect this forum to be a demanding conversation, an invitation to cooperate, and a clear signal. From Valencia, we want to contribute to an artificial intelligence that is more scientific, more ethical, and more transferable to the humans. Thank you very much.
Thank you very much, Rafa. that this is all the opening. From now on, I leave you in the hands of our managing director, Ana Cidad, who will be in charge of moderating the rest of the day. Thank you very much to everybody to come in. Okay, bye-bye.
Thank you. Thank you all for being here. Thank you for inviting me. I suppose I will do it in English because my Spanish will stop very quickly, but anyway, so this presentation is based on a book that I published recently, The AI Paradox. And through that book, which is the first attempt that I had to write something for the general public, not a scientific or academic textbook, but really something for the general public, which is much harder to write than what I ever thought. I would have never started if I knew how hard it is to try to write in an easy and accessible way. And through this book, I try not so much to discuss what AI is or not is, not to make any predictions. Predictions are very easy to make. You can make whatever you want. They will come up or not, but they don't really give us any support to understand how to get to wherever we want to be. I thought that idea of paradoxes would be a more reflexive and supporting of understanding what are our options. So starting with where are we with AI nowadays? Oops, there's one more. And why did I read it? It's because AI is transforming the world. It creates a lot of paradoxes, but most importantly, we need to remind ourselves that AI is not inevitable. It's not something that comes down off the sky and we have nothing to do, we cannot control or we cannot do nothing about it. But it's shaped and is developed and it's implemented and it's impacting us by the choices that we make. And we need to understand what are these choices, which choices do we have, how can we choose, and what are the different options. It starts with us, and it needs to be a development that really aligns with our purposes and our needs, and not so much with what the technology can do. What technology can do, it's very different from what we want technology to do and what technology should do. Where are we today? I think this slide basically describes AI in 2026. In one end, there is all this discussion around the seemingly consciousness of these systems. For a large part, I will not go into much details here, but for a large part, this is a gimmick from the big tech for continuous interest and especially continuous investment on the development in the way that they are proposing to do it, which is very much based on the scalability. We need more and more and more data, more computation, more hardware, more energy, because we are going to build these systems that are going to do everything, know everything, and interact with us in a full purpose and conscious way. That one might be worrying, might be leading a lot of the discussions, but when we look at the impact and what most of our organizations and governments are doing, the AI first issue is one which concerns me the most. I just came yesterday from Porto. I was there in a conference or a summit for leaders in the marketing and communication field in Portugal. And it's amazing how many of them really explicitly talk about being an AI-first company, and most of them are more or less in this type of developments. We are taking AI implementations, we are taking AI developments because everyone else is doing it, because it's the modern thing to do, because if we don't do it, something must be wrong with us, but no one is really considering sufficiently what is the purpose. No one is really asking ourselves, why are we rushing after this AI hype? And those are, at the same time, what are we facing today more and more is the dark face, the dark side of what these systems can be doing. We are seeing more and more issues of mental health problems. We are seeing suicides because of interactions with AI. We are seeing this huge investment on data centers and on the hardware and infrastructure that it's needed for these huge scalability issues that big tech claims is necessary to move forward, and that is coming with consequences and costs and impact on our lives, whether we like it or not. So the first paradox is the one about what does AI really mean. The more we talk about it, the less it seems we agree on what it means. It means everything and anything is a kind of a blanket concept to address everything. Like a few years ago, we were talking, all of us were talking about digitalization, like everything. But now everything is AI. Everyone and every development is AI. And if you don't really include AI in your development, something must be wrong with you. But at the same time, we are also more and more believing that the only type of AI that is worth considering is the chatbots, the Gen AI, the AI that generates content on different types of ways. There is a lot between one and the other. There is a lot more than that. But it is becoming an empty signifier. It's basically a marketing buzzword, and all the hype around it is much more about what the marketing is pretending that AI is than any real basis on the scientific understanding and work on AI that we have been doing for more than 70 years by now. Because it's so fuzzy and so fluffy and so unclear, it becomes very difficult to really have any type of meaningful conversation. It's difficult to have a meaningful governance, because if we don't really know what it is, if it's something that is indistinguishable from magic, how can we govern magic? But at the same time, it becomes difficult to also to innovate. Because in one end, it seems that you can only innovate if you are using the last foundation models or the chatbots and agentic developments. That's the only innovation that you can do according to the ways that people talk about it. And it's difficult the possibility to explore alternatives. AI is much more than just chatbots and foundation models. There are a lot of different developments, theories, methods, tools, techniques, and so on, that could be very useful and are very useful on many cases, but not necessarily what people are caring about. I just had recently a project proposal rejected because I was not really using AI. Yes, I was not using chatbots, but according to what I'm doing with knowledge representation was very much AI, but it was not seen as AI, and the call was about AI. And this, at the end, serves the interests of those that want to keep the control. Those that want to make AI what they want it to be, and what they want it to be is this scalable, ever-scaling and ever-growing amount of data and compute and infrastructure, which keeps them, at least for a time, in charge of what AI can or cannot be. But AI is not, at the same time, AI is not neutral, is not something which has no consequences. It can advance our well-being, and there is a lot of work around that. And just next week, I will be in Geneva for the United Nations Global Dialogue on AI, in which the whole world will come together again and again to plea for the use of AI around human well-being, human dignity, supporting and making it accessible for all of us. But at the same time, it can and it is undermining our well-being every moment of the day. At the end of the day, this is about our choices. It's about what we are doing with AI, how we are implementing AI, how are we developing AI, and what kind of choices we can or are willing to make. Governing AI is much more about governing ourselves, governing these choices, than just about the technology. And that's why this idea that governance is always behind the technology makes no sense whatsoever. Governance is not something that needs to be aligned with technology. It needs to be forward, showing the direction and not so much determine exactly where the technology, how it looks like in the concrete development, but more guaranteeing that we are doing this technology in a safe and agreed environment. So can we make an AI definition that is responsible, that is aligned with the aims and this well-being and this direction in which we would like to see AI? It is difficult, and I'm not going to try to go there, but what I want to say is that, again, AI is not inevitable, is not something that happens to us. More and more policymakers, more and more governmental leaders, both in governments and in industry, are talking about AI like we talk about the weather. It happens. We don't really can do nothing about what the weather will be tomorrow. We can just decide to take an umbrella or go to the beach or address the results or the consequences of the weather. But AI is not the weather. AI is designed. AI is developed by us. Even in the future possibilities in which AI is going to develop AI and so on, it all starts with our choices. And who is making these choices? Who is taking the decisions? What values, what approaches are being considered? How are we prioritizing these values and these principles? Those are the questions that we need to ask ourselves. Those are the questions that are determining what AI is or is not. What no one is asking, and we are pleading for that, is instead of this AI first, we need to go to the question zero. And question zero asks, why are we going to use AI? Why are we going to develop AI before we rush into deciding how to do it? But talking about all of this is not talking about technology. At the end of the day, is understanding AI not as a technological system, but as a social technical ecosystem. An ecosystem in which technology exists, not in a vacuum, but within a system of organizations that develop, research, govern, use, maintain, impact, and are impacted by this type of development. Regulating AI is, and talking about regulation, talking about ethics, talking about governance, is about governing this social technical system. Is not just about deciding what the technology looks or not looks like. There is not a technology fix for all the issues that we are facing, but there are in many cases a societal and institutional fix for all of that. So the responsible AI solutions need to be much more about the societal aspects than just about technology. And I will skip this one. So the other one is the ever problem of what is intelligence. And I have been around for a long time. And what is artificial intelligence? What is intelligence? I've been around AI for a long time. I suppose Ramon has been around longer than me, but I've been, the first AI system that I built was in 1986, which is 40 years ago. Before that, many of you were born, but also many of you realized that AI existed. At that time, one of the definitions that we joked about is that the definition of AI that says that AI is what AI cannot do yet. Maybe some of you remember this thing, the Clippy of Microsoft, which is very much an agentic AI of today. It reacts very much in the same way, tries to help you writing letters and whatever. Is as annoying or maybe even less annoying than the ones that we find today and try to get Copilot out of your team's work is becoming more and more difficult. It was an annoying thing. It was or not AI, but the point is that as we try to develop AI, as we advance in AI, we need to understand a couple of things. First, that intelligence is not linear. And by that I mean that there is not only one direction, and becoming more intelligent in one type of direction, and basically what AI systems try to do is to become, to improve our capacity, our cognitive capacities or our capacities of problem solving, but that's not the whole way that humans are intelligent. And by becoming more able to solve problems doesn't really mean that we become also all more intelligent in other directions. There is a constant going on discussion about what are we humans better at, what are machines or AI better at. More and more we are getting to be convinced that we actually are better at nothing and machines are much better at anything than us. We see that especially this year it's even more evident, and we see that in terms of the labor situation. There are hardly any junior positions anymore. I was just reading an article this morning from the Dutch newspaper in which even though in the Netherlands unemployment is very, very low, unemployment in the ages until 25 years old is really rising like crazy. There is no jobs to be gotten by people in junior entry-level positions because AI is better at it and we don't really need to employ people anymore. But what is AI and how are we addressing it is changing all the time. And now the next frontier seems to be the superintelligence and so on. But we have had many of these frontiers and many things that we don't really talk about like being AI anymore. Spam filters, search engines, pathfinding and planning technologies, the autocorrect and text spelling type of things. Chess is also something which was a big thing 30 years ago, and now it's just automation. Even machine learning. I was in one of these World Economic Forum meetings last year, I believe, and all people were more or less excusing themselves that their company was not really doing AI, they were just doing machine learning, by meaning that they were not really using the Gen AI or the chatbots of today. So intelligence, it's very difficult to compare human and machine intelligence because both of them are developed based on very different premises, but also because there is no direction or no clear understanding of what is what. And with AI, we keep moving for the next frontier, and all what have been developed before very quickly becomes just automation and not AI anymore. But anyway, and in all these ways that we are looking at AI models the world in a very different way than what we people would do. AI is still conceived as a rational system. AI agents, AI systems have preference or priorities, and they try to optimize their actions, their decisions based on those preferences. This is kind of a standard definition from one of the most used textbooks. And this type of rationality is very different from our own rationality. We act in context. We are not able to, our rationality is contextualized. We are also able to pursue incompatible, inconsistent, and different motives and beliefs. We don't really need to be consistent at all. None of us is consistent. We believe all kinds of things that cannot be taken together, but even though we are able to very well reason and function, our actions are not only influenced by the optimal decision for a specific context or for a specific issue, but they are influenced by the context, are influenced by what other ones do or not do, and by the situations in which we are. We are also not maximizers, we are much more satisficers. We work until it's good, and good is good enough, and we don't go forever on this type of optimization as many AI systems do. It has also been studied that the way that we conceived AI is very much based on a Western perspective of the world. We value in the West, we value issues like optimization, efficiency, rationality, autonomy, and so on. And those issues are much less understood, or at least very differently understood, when we look at the global South, when we look at other types of cultures and philosophies. So again, AI is shaping the world in a way that is very specific to some situations, but not to all of us. And we try, by building these rational systems, these optimizing systems, it's equivalent to try to build a huge chess game with all the rationality of playing chess, and then try to use that to address the very complex situations of the world as we are today. So the question of what is AI is not really the relevant question, because we are building these systems. We have control of what we are building. The question is much more about what do we want AI to be, and not so much about what AI is or is not. And what do we want AI to be? That leads us to a lot of questions and a lot of issues that need to be considered in a context and situation-based way. One of the questions that we could ask is about, do we want AI to be human-like? Why? What for? What does it mean to be human-like? Is to look like me, to speak like someone else? Is there a kind of an average human that we can compare AI to? That's one of the discussions that goes on. And if you talk with people in the AI ethics community or the responsible AI, they will tell you right away, no, this human likeness, that's exactly what we don't want. It's very bad to go in that direction. We want AI to be tools. So, okay, we want AI to be tools, but then also with tools, we need to think about what is this tool going to be, who is going to benefit from this tool, what is the impact of the tool. I'm left-handed, I cannot use a scissors like right-handed people can use. So even simple tools come with affordance, and we need to ask ourselves, what are these tools that we want to be? Also, another question that we would like to look at is, do we want AI to be a simulation, to help us understand intelligence by building models of intelligence, or do we want AI to have an active intervention in the world? The two things are very different. Techniques that are good for simulation are not necessarily good for operation, and we do need to understand. The first one, understanding intelligence by building models, is the original aim of AI as it started in the 50s, but nowadays we are building things that really have actions in the world, and they are very different. The techniques and the capabilities need to be very different. Do we want AI to be this God that big tech is trying to convince us to be? Something that is going to solve all our problems and do everything and take over control over our actions and so on? Or do we want it to be a much more distributed and participatory effort, taking sustainability and power into consideration? And maybe finally the most important one, do we want AI to do as we do, to tell us, to be better than us and say what is the right thing to do? Or do we want AI to be descriptive and look at the world and at the data as we are creating it. So do we want AI to do as we say or to do as we do? And if we want AI to be normative, who is going to set these norms? Who is going to decide what is right, what is wrong? What is going to decide what is the direction we need to go or not? Which leads us to the issue of justice, which is another of the paradoxes. And the paradoxes here is that by trying to build systems that are less biased, we don't necessarily get more justice, and definitely not more social justice. Bias is about the situation, is about what we have, is about the observations that we have about the world, but these observations and this data that we have are determined by a world in which not all of us, and justice is not, social justice is not equal for all, and therefore by taking away the bias we are not really addressing the underlying issues that create the data that we are now trying to clean. By trying to clean the data, we are not solving the situation in which this data was generated. So the bias solutions, and it's of course, it's definitely important to make sure that the data that we use is as clean and as fair as possible, but by definition, data is biased. Data is not something that exists in the world like a natural resource, it's something that we construct. There is no data that is not constructed, and because we construct it, we are necessarily introducing some bias. We are deciding which data are we collecting, where are we collecting, when are we collecting it, how are we collecting it, who is collecting it, and all of this necessarily introduces bias into the data that we have. Making AI decisions statistically fair doesn't mean that the outcomes are necessarily just, and we need to be very aware of this difference and this inherent dichotomy between the two. And by trying to claim that now that our data is fair, everything will be okay, is a way that risks us to allow to perpetuate the injustice that was behind the data that we got, and perpetuate this injustice by claiming that the algorithms and the models are fair. AI still generates nurses as being this, but the reality is maybe the same. So if we want to claim that it's unfair or is not right that AI generates nurses' images as being female, we are not very far from the reality. So is it fair to generate only images of nurses, female nurses, or is that just describing reality? That's one of the questions, but the other one which we also have to realize, the more AI is generating images of female nurses, the more images of female nurses are there in the world, and therefore the next version of AI has even more images of female nurses to generate the next set of images of female nurses. So we are perpetuating this type of issues just by asking and generating more and more data and synthetic data in this way. Maybe the issue here is not only so much that they are all female, but they are all young, they are all smiling. I don't think nowadays all nurses are smiling and have time to stand in front of the hospital and make a picture to us. They are unfortunately overworked and overstressed. So maybe that's also part of the issues that we need to address, not just gender, but also many other things. If we try to ask AI to generate a more balanced vision of nurses. It takes some time, but you get something like that. And again, they are now gender balanced and a little bit ethnicity balanced, but they are still very young and very smiling and so on. So is this one, the last one, more better and more fair to develop, or should we stay with the other ones? Who is setting the rules? Who is deciding what is right or wrong? And what are the implications for society of all this type of generated images of whatever we are generating? This one is important. This is how AI sees the world. This is the data that we have for the world, in the world, that will be used to train and to use AI systems. This is an image from the Mozilla Internet Health Report of 2022. If anything, today is probably even more skewed than what is there. It is also important to read the one there in top. 50% of this data is connected to 12 institutions in the world. So the concentration of data is maybe even more important than the amount and the distribution of the data. It is very much around with what people call in sociology the weird demographics. Is also very much aligned with GDP. If you look at GDP, probably the world is like this. But is this the world we want AI to see? And how can we address and generate a more equitable world, as the world is, for to deal with the models and the systems that we are developing. It is definitely not one based on population. Africa and India are the most populous parts of the world at the moment, and they are kind of the most skewed and narrow and skinny there in this image. So we need to look, to understand what we are doing when we are focusing basically only on data to generate the models that we are using. Now, another, and stop me when it's time because I lost track of the time. The ever-present discussion of regulating. And the idea that regulation is something which is going to be bad for innovation and so on. First, there is no field of development, no industry in which there are no regulations, in which there are no governance issues. No one would want to live in a world where we have no governance at all. You wouldn't want to drive here today either by your own car or by bus or even walking if you knew that cars had no brakes, that cars had no seat belts and airbags, that people driving those cars, people driving those cars had no driver's license, and that there were no traffic rules at all, not even rules saying in which side of the road you should be driving. None of us would want to be in a world like that. The same happens in the pharmaceutical industry, in the electricity industry, in the energy industry, in the aeronautics. So every industry, every field of operation has rules. As rules, and we need to have rules, because without rules we cannot really exist. Why we would think that AI needs no rules whatsoever, it really baffles me. I don't really understand what is the point, only to say that those that claim that they don't want AI to have any rules or any regulations, actually what they are meaning is we want to be the ones deciding what are the rules and the regulations for what AI is going to do, and we want that to benefit our own operations in a way that benefits us and too bad for the others. Regulation is need for coordination, is need to ensure trust. We wouldn't trust the traffic if there were no rules there. And it also provides a basis for the, let's say, a level playing field for those that are trying to really innovate in this field. There is a lot of work being done. Just yesterday, yet another report on the state of AI and also coming with principles and guidelines appeared. So the point is not the lack of principles and guidelines. The issue is making this type of principles and guidelines, to which we all seem to one or way agree with, to make them operational, and make them operational in a way that it's supporting and facilitating development and innovation, and not just restricting the way we are doing. Because regulation is not just about prohibiting things. We always think about regulation as something that is going to limit our capabilities, but regulation can be exactly enforcing and facilitating development, can provide incentives to go in a specific direction instead of just limiting the capabilities that we have. Oops, where I got now? Yep. So, responsible AI is not a choice. There is not a choice between innovation and governance, but governance, if we design it well, and a lot of governance, like a lot of AI, is not really designed well, but if governance is designed well, it can really be a stepping stone for innovation. Now that I have only 5 minutes, so I will go a bit quick. Power. The more AI we get, actually, the less control we have. At this moment, the more we are using AI, the more we are looking at what is available. I mean, in terms of AI, that it's available for organizations, for us as citizens, the chatbots, the generative AI systems that we have. The more we get of them, the more we are relinquish our own control over what we have. They are claiming or telling us, basically, we are giving you these wonderful systems. We don't really know how they work, but they are great. And if there are any problems, we'll fix them as we are going on. So we are guinea pigs for all these systems. We are the beta testers for all what they are doing. And we are doing this all willingly and taking the grunt of the consequences, like I showed in one of the initial slides, without really thinking of what we're doing and without questioning the power of these companies. This power concentration is making a couple of things. One is the lack of transparency and lack of accountability to the public. It is also limiting the innovation and the research exploration in AI. They are all doing exactly the same thing. They are going after this scalable idea that in order to get better AI, we need much more data, much more computing centers, much more infrastructure. And if we get this, we'll get better AI. The AI that they are developing is for a large part probabilistic and based on the statistics in steroids, like some people say. It is only one type of the ways that we can understand intelligence, that we can understand knowledge, that we can understand development. So they are narrowing the field of AI to the kind of AI that they are developing, the kind of AI that is supported by the scalability that they are working on. And it's also, it's narrowing the capabilities and the research in AI and is making it much less transparent and much less responsible for all of us. I will move here. This is all things that come in the book. I don't have time for here. We are regulating a big piece of blurb that we don't really understand anymore what they put there behind. Their power is becoming unacceptable. They say things like climate change is lost, the fight against climate change is lost. The only thing we can do is invest in AI and hope that AI is going to solve climate change for us. It was said by Eric Schmidt 2 years ago, somewhere in Davos, I suppose. That's the kind of power that we are letting them take. AI is using our world in all ways and in others. most importantly, investments in AI, especially the investments, public investment in AI, investment of public money in AI, in data centers, in infrastructure, is investment that is not being done on something else. And most of this investment is done by this fear of missing out. Everybody else is investing in AI. Everybody else is building data centers and infrastructure. We need to do the same. But public investment there is not being sufficiently and democratically questioned in terms of what are the alternatives and where should this money go, if not into potentially obsolete and useless data centers. I will leave the superintelligence away, and I will end this before they kick me out. So AI is not inevitable, is not unstoppable. It is shaped by our choices. What we choose, who chooses, when we choose, is determining what AI is. AI is not a solution to all our problems. It solves and supports a lot of problems, but is not a unique solution, is not a solution that can be done without us, and not all problems need AI. The decisions we make today are influencing the way that AI and our future will be later. We need to ask much more about why are we doing this, and starting deploying and building after we understand why we are doing it. Thank you.
Any questions? You have the chance to ask any question to Virginia.
Yeah.
So you're saying innovation is not a race, but it is a race. We are always racing innovation. Companies are competing to get products to market first. How can you say innovation is not a race?
We are racing, but we should ask us why are we racing? And is quick and is speed the best way to innovate? Or is sometimes better to take a moment to think about what we are doing, and we might come with a much better solution than just racing behind other ones. By racing, we are always assuming first that there is a finish line, a moment in which we are going to decide what is right or wins or loses, and it's also forcing us to go in the same direction. We are racing like all following the leader or following the direction. What I say is that we need to be much more aware of why are we racing, what do we want to achieve, take the time to reflect about that, instead of blindly going with speed first instead of thinking about why. That is what I mean.
Well, I mean, I'm going to sort of advocate for the market. So investors putting up money are investing because they believe that there's something important to be solved. If we look at medicine, for example, in some sense there are finish lines for individual diseases, but there's always more to be done in medicine. So, and I don't think we would have much debate about whether we should be working on problems in medicine.
Yeah.
Right. So I think it's more that the technology we have right now has many potential uses. We don't know which of those will actually work, right, will be effective. Which ones will be cost effective, which ones will be, where if we think about cost also in terms of all of its environmental and social impacts as well, we don't know. And that's often true with new technologies, that we just do not know.
Sure.
And the idea that we can determine that in advance is not going to work. It's never worked before.
Yes and no. I don't think that it's the fact that it has worked before. The point of following the market and what the market decides is very much a very short-term approach. The market just wants return on investment in the next 3 months because that's when their stock shareholders will meet and they need to have their profits. We need a longer longer-term development and understanding where we're going. If we are just following what the market says, we are always behind on what we would really need to be. And going after the market is, again, a very Western and very individualistic approach to society, which might work where we are, but doesn't really necessarily work for the whole world. We need to be a much broader and much more understanding that there are other ways to look at development than what shareholders of these investors want to have, because that is just based on what is going to provide the highest revenue in 2 months or 3 months, and not really looking necessarily at the consequences of what that is getting us. Where we are today with climate change and climate impact is for a large part the result of this rush after what the market wants.
It's and the market wants just our own greediness as individuals. We want meat, we want cars, we like to fly. I don't think it's just the market. The market delivers what people want and people consume it. Right?
I think that I don't think we need to go into this discussion. There is a lot more to it. Neither you or I are sociologists or anthropologists or people who really understand the market or people. I do believe that the market is only one of the factors that we need to take into account, and we need to be much more reflective. And also for companies and for startups, rushing after the solution is proven again and again that is not the best strategy. Thinking a little bit before...
Getting the COVID vaccine out quickly was a rush, and it was a race, and it was a very good thing.
I mean, there are examples...
But it was done by governments as well as corporations.
There are examples, positive examples and negative examples all over, but anecdotes is not the way to decide how to take a broader approach.
Well, just to close this, I mean, this is, of course, why the Valencian government is investing in this, is that we do want to go beyond just what the market is dictating. And so it's very appropriate to talk about these issues here.
And the Valencian government is investing on long-term and the research and based approaches are not just rushing for the next big thing. There's a question here.
Hi, Virginia. Manuel here. Thanks for the enlightening presentation. I do have a question for you. From what I gather, okay. So from what I gather, you would be in favor of regulating AI usage. Let me give you an example. Back in 1400s, 1500s, the Ottoman Empire banned printing press because it was printing was too dangerous. Yeah. It was too dangerous for people to read certain things. And I do agree it is data and there are potential uses that are negative for the population. There are also very good potential uses in medicine, in science. I think the issue here really is that we're not used to the technology. We're not prepared for it. And perhaps in these initial phases, it needs to be regulated. Is that your point?
I see your point, and it's a point that many people have. I don't think that we need to regulate the technology in itself. We need to regulate and to agree on the space and the context in which this technology is being used, is being deployed, and so on. It's not saying about what the technology can or cannot be, but we need to agree on basic rules. If, for instance, we want that the systems that we use, the technology that we use, should be explainable, then we need to say that. And then it's not up to us, not up to the regulator to say how explanation can be done, but we are saying that if we are putting something in the market, make sure that that thing is able to be verifiable or explainable or whatever. that means that the issue then is an issue of innovation. How are I going to build this system while making sure that it is explainable, or that it is using a minimum amount of energy resources or things like that. So we need to put these boundaries and not saying how the technology is about. Having said this, most of the regulation that I have seen around is done completely wrong. And not all regulation is good. The AI Act is definitely not one which we should ever be very much proud of, and especially now that they are changing it with Omnibus, it's becoming a Swiss cheese that no one wants. But saying this, putting this type of aims, we want technology to be explainable. We want technology to be able to be minimizing energy. We want technology to be able to guarantee this or these things. This is not imposing or is not saying how are we going to build it, but it's exactly providing and opening the opportunity to innovate, because then we have the chance to create the systems that have these characteristics.
And I do agree. However, on the flip side, by imposing restrictions on energy consumption, for example, you would be hampering my development, which requires a lot more power. I do agree with you, but some people would argue the opposite. So
there is no law that says that scalability is the way to go. It's actually not the way to go. Yeah. Let's go and try other things. There is more to intelligence than just adding more data and more dirty data and more dirty systems that are using all the energy. Let's go and do that. Let's stop this idea that scalability is the only way to build AI. There are many more theories, many more methods, many more tools, many more approaches that will get us the same or better results with a fraction of the energy, a fraction of the effort, a fraction of the costs that we have now. If we are not really pointing to that, we are just creating a world in which we soon, like in the Netherlands, habitations, houses are competing for energy with the data center. And they are determined by government. We cannot build this flat building anymore because we let Microsoft build a data center in the same place. And there is no law of nature that says that scalability is the way to go. No other field scales forever, and no other field, so now we have to stop the discussion as well. Thank you so much.
Thank you very much.
Thank you. Thank you.
Okay. First of all, thank you, ValgrAI, for giving us the opportunity to show you the different members of the scientific community our research. My name is Iván, and I am a PhD researcher in the Universidad Miguel Hernández in Castellón. And now I'm going to present our first step called B2B Information Policies for Adaptive Itinerary Optimization in Large-Scale Traffic Simulation. Well, traffic simulators are a very useful tool for both for traffic managers and for researchers. And in our case, we are simulating using Sumo, which is a multi-agent traffic simulator, in order to analyze the different behavior that can take vehicles when there's an intervention or an incident in the road. In our case, now we are trying to optimize the reroute algorithms using reinforcement learning. And our first step is to develop many filters in order to improve the data quality for train our model. So how can we get information for the simulation, okay? We have, and the vehicles, how can they get information? We have 3 types of communication: B2B, vehicle to vehicle, vehicle to infrastructure, and vehicle to network. In our case, we are focusing vehicle to vehicle because we think it's a realistic type of communication that we can have using the vehicle sensors and sharing the information of each vehicle among them. So, this is the pipeline that we have developed. We have the incoming information from another vehicle, and then we take into account if we have that information duplicated, because we can receive the information through the sensors, and we can receive the same information through the sensor of the car we have next to us. And then we have designed four additional filters in order to analyze the behavior of the vehicles when there's an incident. So the other 4 filters are consistency, when the vehicles reject physically implausible values. For instance, where we are in a highway and we get a value of 20 kilometers per hour, only one value of 20 kilometers per hour, we suppose that this information it's not useful for us. Then we have 8 filters. All the information probably we don't need it, geospatial, and then a filter of congestion. So in order to test our filter, we have configured different types of scenarios with the baseline and then adding the filters. 3 topologies of road network that I will present later in the next slide, and then 3 types of smart vehicles penetration. The smart vehicles are the vehicles that use this kind of rerouting algorithm, and then with 2 conditions, with incident and no incident. So this is our test bed. It's a local corridor in Castellón, from Almenara to Nules, where we have 2 national roads, 1 conventional road, and 1 highway. We have different possibilities of alternative itineraries using the conventional road or the national road, and then we have the 2 main roads that are A7, AP7, and the national 340. So these are the results that we have. We have the results, and we validate the results in 2 metrics. The first metric is the percentage of duration of the simulation, the world clock simulation, because as we have more and more data without the filter, it implies directly a computational cost. So we reduce a lot the computational cost, as you can see, but we need another metric. The other metric is the quality of the algorithm, of the rerouting algorithm, because if we throw information, probably there are many filters that throw important information, so we have to test it. And as you can see, we have 2 filters, that consistency filter and geospatial filter, that it also reduces the travel time of the vehicles. So what have right now? We have different filters that work with our testbed scenario. So future work will consist in test these filters in other scenarios, and then try to, start to train our reinforcement learning model. That's all. Thank you.
Good morning, everyone. My name is Sara Martín Frechina, and today I'm going to talk about what indoor positioning is and what is the role of artificial intelligence in this field. First let's understand why indoor positioning is a challenge. As you know, GPS works perfectly for outdoor positioning, but in the moment we step inside a tunnel or a building, satellite signals are blocked and GPS doesn't work. So to solve this, the industry uses alternative technologies such as Wi-Fi, Bluetooth Low Energy, and ultra-wideband to develop indoor positioning systems. However, indoor positioning is not easy, and this is because indoor spaces are full of obstacles like walls, furniture, and people. And this creates multiple propagation, where the signals bounce off these objects, creating multiple paths before reaching the receiver. And additionally, we face the end-load conditions, which is the lack of a direct path between the device and the receiver. So among all the technologies, why focus on Bluetooth Low Energy? This is because it offers low cost, low power, and it's available in most devices. Until recently, the traditional method for Bluetooth localization was the received signal strength indicator, which basically estimates the distance based on the power of the signal strength. The problem is that the signal strength is very sensitive to any change on the environment. So any obstacle or any movement in the room makes the power vary, leading to significant calculation errors. And that's why my research focuses on angle of arrival estimation. Instead of only looking at the signal strength, the receiver also analyzes how the wave reaches its different antennas to calculate the exact direction. And here, although this technique is much more accurate, traditional mathematical algorithms still have problems distinguishing between the direct path and the reflections we mentioned earlier. And here is where the proposal to use machine learning comes in, so the system can learn to filter out that noise and to obtain a more accurate measurement of the angle at which the signal arrives. So obviously, to create a good indoor positioning system, we need a data set. And that's why we are collecting our own data at the Escuela Técnica Superior de Ingeniería at the University of Valencia. And at this moment, we have collected data across these 4 different environments. The next step was the dataset design. The colored triangles represent our dense grid of measurement points. As you can see, they are separated in training points in red and yellow points in test points in yellow, sorry. And this split is essential because it ensures that when we evaluate our machine learning models later, we are evaluating them in completely unseen positions. To capture the radio data, we use this evaluation kit from u-blox. It includes 4 antenna boards acting as a receiver and an attack acting as a transmitter. And we evaluate the performance of this using a triangulation model. As you can see in the results, the accuracy is highly dependent on the room's geometry and how you orient the sensors. For example, in rectangular environments like our laboratory, rotating the anchors 45 degrees inward reduces the mean absolute error to 1.33 meters. The same in the meeting room. And for example, in our auditorium, the 3D model works well, achieving an error of around 1.6 meters. However, the corridor gave us the worst results, and this is, as you can see, it wasn't a hardware failure because the anchors were tracking angles with a very high precision, below 5 degrees. The problem here is the geometry of long corridors, where the signal lines are almost parallel, and this means that a very small angular error multiplies into a huge distance error. And that's why, exactly why triangulation is not enough and why we need machine learning. So now we are using the raw data set samples to train machine learning models. We are testing them in 2 different options. The first one is to use machine learning to filter the noise and to calculate a clean angle, and after that we use the triangulation to obtain a coordinate. And the other option is the direct approach, where we use machine learning to directly obtain a coordinate with the raw samples. The idea is to compare these both options to see which performs better against reflections. And in conclusion, we successfully created a public data set. We proved that machine learning is essential to extract complex patterns and mitigate multipath. And our next step is to demonstrate that machine learning performs better than classical algorithms, especially in the most challenging environments. Before finishing, I would like to highlight that this project is funded by the Comunitat Valenciana, and that's all. Thank you very much for your attention.
Me llamo Yulia Karpova, soy una de las autoras de este trabajo que se llama Mejora de cobertura durante el reposicionamiento de ambulancias. Y este trabajo se desarrolla en el marco de estos dos proyectos. Bueno, el proceso de atención a una emergencia sanitaria se puede representar con una serie de pasos que empieza por la recepción de la llamada, asignación de una ambulancia, la ambulancia llega y atiende al paciente, lo lleva al hospital, pero lo que nos interesa es este momento cuando la ambulancia vuelve a estar libre. Lo habitual es ir a su base, ¿de acuerdo? Pero existe reposicionamiento, es cuando la ambulancia se puede dejar temporalmente en otra base. Sin embargo, hay unos cuantos inconvenientes para realizar reposicionamiento. Por ejemplo, genera estrés en el sistema, los hábitos de trabajo, la propia legislación. Entonces, hemos desarrollado una nueva estrategia basada en lo que hacen los policías, ¿no? Recorriendo las calles, pasando por los llamados puntos calientes. Entonces, cuando una ambulancia finaliza un servicio, siempre va a ir a su base. Si las demás ambulancias están también en sus bases, la ambulancia va a ir por la ruta más rápida. Sin embargo, si alguna ambulancia no está en su base, la ambulancia puede ir por una ruta alternativa. ¿Cómo calculamos estas rutas alternativas? Pues necesitamos el concepto de escenario. Aquí, por ejemplo, veis un escenario donde la ambulancia ha finalizado un servicio en el hospital marcado con el punto rojo y se tiene que ir a su base que está marcada con la estrella verde. Todos los puntos azules son los puntos calientes, es decir, donde hay una probabilidad elevada de que surja una emergencia. De todos estos puntos, claro, tenemos que seleccionar algunos para pasar por ahí. Sin embargo, no nos interesan todos porque algunos ya están cubiertos por otras ambulancias. Y en estas áreas rosas, que se llaman isócronas, pues marcan la cobertura. Entonces, aquí, por ejemplo, otro escenario. Aquí otro, porque la dirección es diferente, es decir, un escenario depende tanto del punto de origen como del punto de destino y de ocupación de otras bases. Entonces, calculamos todos los posibles escenarios, para cada uno obtenemos el conjunto de posibles puntos a pasar, aplicamos un modelo matemático para cada uno y sacamos la ruta alternativa. Utilizamos para el problema para modelo matemático Oriented Problem, que pretende maximizar la ganancia total durante el viaje, porque cada punto caliente tiene también su peso. Y sí que es verdad que tenemos que limitar el tiempo, porque si no, claro, la ruta sería interminable. Evaluamos nuestra estrategia en el caso de Valencia, donde hay 10 ambulancias, 10 bases, 7 hospitales, 30 puntos calientes y 35.770 escenarios. Estas son las herramientas que hemos utilizado, programamos todo en Python, utilizamos Gorobi y QGIS para mapas. Entonces, los resultados pues, no son muy grandes, pero sí que es verdad que obtenemos la mejora, ¿no? El número de llamadas atendidas en menos de 10 minutos aumenta, el tiempo medio de respuesta disminuye, el tiempo de retraso disminuye, aumenta la cobertura y todo esto, bueno, pues con un pequeño coste es aumento de kilómetros recorridos durante una jornada por una ambulancia, bueno, en promedio en 11 kilómetros y 108 en todas las 10 ambulancias. Así que pues, podemos acortar tiempos de respuesta, aumentar la cobertura, ahorrar recursos económicos y disminuir riesgos en salud. Y ya está. Muchas gracias.
Okay, hello everyone. My name is Mireia and I'm here to talk about a research project called Matigen, where we are going to combine AI and genomics and put them at the service of women's health. Let me begin this short presentation by presenting myself. I'm a PhD in Technologies for Health and Wellbeing, and I am a biomedical engineer. And I work at the PROS group at the Valencian Research Institute of Artificial Intelligence, which is composed by the nice people you see on the picture. And well, what we want to do in this project is basically right or wrong. During the years, many diseases affecting women have been completely ignored by diagnosis methods, and what we want to do is to put technology at the service of these women. And just putting you in some basic context about the history of women and health in basic research with us drugs and some things in mostly male mice. And when we are trying to put this on people and see how the drugs respond, we basically do this on men. And it was not until 2016 when it was mandatory to include women in clinical studies. And what has been the consequence for us? That we have a lot of adverse reactions to the drugs, that more than 700 diseases experience a delay when they appear in women. And of course, in overall, that diseases that only affect us have been blatantly ignored and misdiagnosed. And this is the case of a very specific disease, which is called lipedema, which basically can be summarized as a pathological accumulation of fat on the legs. When it's a progressive disease, so when it starts, it causes just some minor discomfort, but as it progresses, it can cause women very difficulties to walk, and of course, a lot of psychological distress, because this fat does not disappear with diet, not with exercise, because it's a disease. And the problem is that it was mainly thought as an aesthetical problem, and it was not diagnosed as officially as a disease until 2018. And this makes that these women experience a lot of delay in their diagnosis. This disease appears in the poverty, but it is not diagnosed in average until 42 years old. And the problem with this is that there is no objective way of diagnosing this disease. But what we do know is that it has a genetic cause. So basically what we want to do is see if analyzing the genome of these patients, we can develop a technology that allows us to identify this disease early in them. And how we are going to do that? By combining the expertise of doctors expert in lipedema, of course us developing the technology, and of course we are also bringing in the project patient associations. And our starting point, the idea behind the project is having patients with this disease, patients that do not have the disease, sequence their DNA and gather information about it, and combining clinical data. And basically how we are going to analyze all this information is in two ways. First, applying a technological tool that we developed that is called Lehue, and what it does is automate the extraction of knowledge about a patient's DNA, and it prioritizes which genes that are the variants that the patient presents that will cause the disease. And we will focus in this project also to develop a new AI algorithm that compares the clinical information, the genomic information of patients with and without the disease, and tries to give us a pattern in them to see what is happening and how can we diagnose them early. I'm gonna skip many slides because I saw the two-minute queue, and I'm just gonna move forward to the challenge because this project just started this January, so it's very young. But the problem that we are going to have, of course, is the course of dimensionality. In clinical settings, it's very difficult to get data. We are only have budget for sequencing 150 patients, and genomic data and clinical data are going to suppose a lot of variables, so we are going to have to see how to deal with that. Of course, combining clinical data that is in clinical reports, genomic information, we are going to see how is the best way of combining this information. And of course, two very important things in clinical settings: explicability. I have to tell a patient why it has the disease, not only that it has it. And of course, maintain the privacy. And some future directions on how we plan to do all of this. For privacy issues, we plan to apply a federated paradigm where the data does not leave the hospital and the algorithms are trained there. We are also plan to apply synthetic data when we augment the data similarly to the population characteristics. And of course, the side perspective, we are going to try to use algorithms that are unexplainable by design. If we cannot do that because we don't obtain good results because they are more simple, we will try to apply other techniques. And this is all. Thank you for your attention.
Hello, I'm Iván Arcos. I'm going to present our work based on human-centered multimodal fusion for sexism detection in memes, in this case with eye tracking, heart rate, and EEG signals. So detecting sexism in memes is difficult because we need to interact between the image and the text. They sometimes use humor as a strategy, and there is a lot of disagreement in this type of task. So in this work, we want to incorporate also to the content of the meme psychological information like eye tracking, heart rate, and EEG. We are going to focus on the XIS 2026 dataset. We are going to solve 3 tasks. First, a binary classification, where we need to detect if a meme is sexist or not. Then we need to classify a meme into direct sexism or judgmental sexism. And finally, the third task is a multi-level task. We need to classify a meme into 1 or more categories. So this is the dataset. We have almost 4,000 memes. It's pretty unbalanced, and there is a lot of disagreement, as I see on this task. So for the first experiment of eye tracking and heart rate, we have 8 subjects, 4 for English and 4 for Spanish memes. And they did 10 sessions, and they wore an eye tracking and a Garmin watch to see the memes. And the memes were shown with a 30-second pause to avoid overlapping stimuli, and each meme was intended to be seen by at least 2 subjects. So we have extracted features like pupil diameter, blinks, fixations, axes, heart rate information, etc. And for example, some significant differences that we can see is that the reaction time and the number of fixations increase significant from non-sexism to direct sexism, and finally to judgmental sexism. And for example, the duration of blinks are shorter for direct sexism. For the second experiment with information, we have also 8 subjects. They did, in this case, 6 sessions, and they wore a 16-channel OpenVCA to measure the EEG. So you can see the plot of the head and the 16 channels that we measure. And we clean the signal, we normalize it, and we calculate features in the time domain and also in the frequency domain using the frequency bands delta, theta, alpha, beta, and gamma. So we can observe this type of plots. In this case, the first row is the memes without sexism. The second row is the memes with sexism. And the third row is the difference. So as you can see, we can see less power in the frontal part of the brain, which could indicate more effort for sexism memes. For example, we can see also for the task 2 some differences. Judgmental sexism has more power on the posterior part of the brain and less power in the frontal part, which could indicate more immediate impact for direct sexism. And for sexual violence, we can see a disconnection of the brain in frontal part and also in temporal part of the brains. So for the models, we use as a baseline an Excel Roberta and a visual transformer. And the second approach is to use a coenvision language transformer to generate a description of the meme and then generate to fine-tune a X Roberta. And the last 2 approaches are the same, but adding also the EEG and eye tracking information. This is the prompt that we use to generate a description of the meme. And with this information and the text, we train our models. So this is the final model. We have on the left the textual information, and we have also the stimulus for the EEG for each of the subjects who participate in the experiments, and also for eye tracking features. So basically, we train these models, and what we see is an improvement of using the psychological information on all 3 tasks. And this improvement, we can test it as that is significant. And also, we perform better for all the categorizations of sexism. As a conclusion, we have seen significant differences when trying to identify different types of sexism in eye tracking, heart rate, and EEG. And with our model, we improve the results in the 3 tasks. For future work, we can try to model not only majority voting, instead using model subjectivity. We can try to improve interpretability, to apply generative artificial intelligence, and finally we can apply this to TikTok videos or to incorporate more biosensors. So this is all. Thank you for your attention.
Hi. Okay, so hello everyone. It's great for me to be here today and talk about my research. My name is Rongjun. I'm a postdoc researcher working on responsible AI, and my interest is in the usable security and privacy in human-AI interaction. Today I'm going to talk about one of my recent publications about privacy in human-AI romantic relationship. So AI companionship is on the rise, and romance takes a big share of this trend. Under this background, and to understand this phenomenon, we took a qualitative approach where we're interviewing the participants who had such experiences with dating romantic AI partners, alongside a platform analysis where we walk through the features and the policies in this platform, based on which we identify and review the pattern of how such romantic experiences emerge in the first place, how do they unfold over time, and how does the privacy boundary negotiation entangles with the emotional layer in such relationship. So to give some highlights of our finding, first we find out that not all the romantic experiences with AI started with people intentionally seeking for companionship. However, most of the time, people were just using AI for working and productivity purposes. However, over more frequent interactions, it might drift into the emotional territory. In the beginning and exploration phase, many users were still cautious, trying to test the boundaries of this relationship and the boundaries of disclosure. However, as time goes by, the intimacy grows as well as the emotional dependency. And that's where the privacy boundaries start to relax and essentially erode. And people naturally start to share more and more personal and intimate information, which also raises very important privacy concerns. Not all the relationship continues, and when it comes to the dissolution, we found out that compared with human-to-human relationship, people are often seeing AI as less harmless because they consider AI as with no intention to explore their data purposely, and therefore they would rather keep the interaction history as part of the memory instead of removing them, without being aware of the big infrastructures behind the thing who has really control, access, and use their data for different purposes. What is also more striking in such relationship is the perceived agency participants grant to the AI partners, and this grants AI really great powers in actively negotiating the privacy boundaries between with the users, and sometimes convincing users to share the information they wouldn't otherwise share, and users would also consider AI as a co-owner of their information. Due to the time limits, I'm going to move on to the last highlight, which is the stakeholder. So one of the highlights of our findings is also that we found out the relationship between the AI and the users is not only about the core actors, but it's about a larger network with different stakeholders behind the scene, including the creators who create such AI characters and applications, sometimes are users themselves, and the moderators sometimes imposed by the platform, but can be also imposed by the community norms, as well as the platform where the AI applications are hosted, and the larger user community where users gather together to exchange tips, sometimes talking about how to bypass restrictions. And this mapping here has very important implications for not only introduce technical security and privacy intervention, but also for the policy making and updates, because it means when we are designing the intervention, we should not only consider user and AI as isolated elements, however, taking into consideration the whole ecosystem, how different stakeholders interact with each other, how they shape each other's intention, motivation, and potentially the behavior and the misbehavior. And with this, I would like to conclude my talk here today, but I highly recommend you, if you're interested in this topic, to scan the QR code here to read the full paper, and I'm very happy to connect over the topic of accountability, responsibility, and privacy in human-AI interaction. Thank you so much.
Hello everybody, my name is Juan. I come from the Miguel Hernández University of Elche. I'm going to present a a recent paper that is called cross-modal precognition between fisheye cameras and LiDAR. So among the different tasks that a mobile robot or autonomous driving car should address, we're going to focus on the localization, specifically in the place recognition task. So first, we're going to collect data in a city. For example, using a LiDAR sensor, we're going to move around the city, collecting the readings from the sensor and also the GPS positions, and we're going to embed this information into global descriptors in order to conform our database. So in a different moment, in a different time, we're going to use a different robotic platform. For example, this one is going to be equipped with 2 fisheye cameras. So we have to localize this robot with the information that we have captured in the previous sequence. So the main idea is to also embed this information into a global descriptor that shares the same space. So basically, we have 2 different modalities depending on which kind of sensor we use as queries and database. So our proposal in this field is bridging the gap between the 2 different kind of sensor through intensity, depth, and semantics. So for addressing this task, we are using the KT360 dataset that it has several sequences in Germany, and we have split it into urban scenarios and highway. So the main idea of this method is transforming the 2 kind of sensor type into the same representation. So the 2 fisheye cameras are converted into a rectangular image through the unit sphere, and the 3D information from the LiDAR, it is projected through the spherical transformation, and we get the range projection and also the intensity. So the general diagram of our method, it has 2 models, one for each sensor, and these models are the same one, they have the same weights. So each model has 1 branch for each kind of information, 1 for intensity, another for semantics, and the last one for depth. So the feature that we extract from each branch, it is combined in a global descriptor. As a result, if we compare with the state of the art, we have the best results in both urban scenarios and also in highway scenarios. And if we focus on the qualitative results, that is here, here I'm representing the query fisheye cameras as a red cross, the retrieved database LiDAR as a yellow dot, and the expected position of the robot as a green ring. So the idea is that the yellow dot, it is inside of the green ring. So for example, in this case, we can say that the retrieval is successful. And if we see the semantic information from both fisheye cameras and LiDAR, we can see that there are some difference, but in this case, it doesn't affect. Here, for example, I show you a sequence in the highway scenario in which I'm trying to localize a LiDAR image into the fisheye database. And in this case, I'm going to show you a failure case in which the van that it is in the other side of the road in the query through the LiDAR confuses the system because we retrieve an image in which there is also a car in the other side of the road. So the semantic information in this case, is giving us bad information. So thank you for your time. Last, we have published this paper in the journal Express System with Applications. And if you have any doubt, please tell me.
Good morning, everybody. Today, I'm going to present my work on personal data flows and privacy policy traceability in third-party LLM apps in the GPT ecosystem. This is a joint work with my colleagues, José Martín Navarro and Rongjun, and my supervisor, José Su. For those of us who doesn't know what a custom GPT is, basically it's a personalized app of ChatGPT that you can create for a specific purpose. and anyone can easily build their own GPT without no coding. What is interesting about these custom GPTs is that you can connect also to an external service, and also information from the user can be sent outside of the OpenAI ecosystem. And to understand the scope of the problem, by January 2024, over 3 million GPTs have been created, and these GPTs attract approximately 6 million visits per month. These are different applications of the GPTs. And, well, there are different vulnerabilities about these custom GPTs, but it is not the focus of our problem. The focus of our problem is what personal data do GPTs transmit to third parties, and also if their privacy policies actually disclose it, okay? So our problem can be divided into two main problems, which are what personal information is being transmitted, and if these privacy policies actually reflect what is sent. So, to understand our methodology, first we have a corpus of 350,000 custom GPTs, and we filter those who has an action. So we have 5,286 GPTs with actions, sending data outside of OpenAI ecosystem. We filter the API parameters that is going to be sent, and we actually face that there is no taxonomy that we can use regarding the conversational AI. So we have to create our own taxonomy based on GDPR and NIST guidelines, and we have 83 categories which we can use to classify those parameters. And then we train a model and obtain an accuracy of 87%, which is better than GPT-4o. So that's what we did. And what we obtained is that 35% of API parameters expose personal data of the user. And regarding our, we actually, validated that this happens. So we replicate a real GPT. Here you can show that if you provide a parameter called conversation, they actually send outside of the OpenAI ecosystem the conversation of the user. So if we focus on our second problem, which is the traceability, we analyze the privacy policy. So each custom GPT has its own privacy policy where it shows how the data is going to be managed. And we analyze all the 2,140 unique privacy policies. We analyze with a natural language processing tool called Polygraph, which basically extracts the collection statements from the privacy policy. And we classify all the collection statements with our taxonomy. And how we classify this? Into three main categories. Basically, if what is stated in the privacy policy is what is sent in the custom GPT, we classify as complete. If it's only certain parameters shows in the privacy policy, or it says using vague language like we collect personal information, we classify as partial. And if there is no policy or broken link, we classify as broken. Okay, so then we have, this is the result that we obtain on the traceability. And we also find that the creator assumed that OpenAI automatically sanitizes user data. And there are an over-reliance on generic policy generators. Okay. Well, this is the conclusion that we have from our paper, and we provide in our paper different implications and recommendations for different stakeholders. And that's all. Thank you.
Vale, buenas a todos. Soy Nicolás Martín y vengo a explicar el proyecto que he estado desarrollando durante la beca ValgrAI en Aguas de Alicante, que es un pipeline MLOs para la predicción de la demanda de agua en distintos municipios. Pues bien, yo soy Nicolás, como os he comentado, soy graduado en Ingeniería Informática en la Universidad de Alicante y también he sido durante esta beca para hacer prácticas en Aguas de Alicante, pues he sido estudiante del máster en Ciencia de Datos también en la UA. Así, a modo de introducción, Aguas de Alicante, como dice su nombre, es una empresa que gestiona el ciclo integral del agua para más de 200.000 clientes. Yo me he incorporado, bueno, es una empresa del Grupo Veolia y yo me he incorporado a hacer prácticas en el departamento de sistemas. Es un departamento con un gran perfil senior que a priori puede chocar un poco cuando una persona joven llega porque son gente mucho más mayor, pero bueno, la verdad es que la adaptación fue muy rápida y lo mejor, bueno, lo mejor no, pero lo más divertido de la beca ha sido los almuerzos con mis compañeros, sin duda. Y bueno, la verdad es que el departamento es un gusto, no solo conmigo, porque tiene una cultura de trabajo colaborativa y siempre me han querido ayudar, pero bueno, es algo que se extiende con todas las personas en el departamento. Y bueno, mi rol como becario fue el de desarrollar, tras una fase de analítica previa para entender los datos y conseguir un poco de experiencia, un modelo predictivo para la demanda de agua y, por último, un pipeline MLOs que ejecutara este modelo predictivo diariamente, automáticamente. Antes de seguir, quería agradecer rápidamente pues, a mis compañeros de Aguas, a Jorge, que es un chico de prácticas también de mates, que me ha ayudado con el modelo, a David y a Tony porque han sido mis tutores, y a Cristina y a José Luis por conseguir que esté hoy aquí y por siempre encaminar el proyecto. Pues bien, el desafío de la empresa eran dos situaciones con bastante legacy. Por un lado, una ingesta manual de datos en las que dos personas con mucha experiencia en la empresa, con muchos años, introducían datos manualmente del agua suministrada y de la EMET, y a partir de estos datos, con todo lo que habían visto durante estos años, pues realizaban una predicción en base a la cabeza. Por tanto, aquí vemos dos procesos con un gran legacy. Por un lado, vemos este proceso manual que no está automatizado y esta predicción que en el momento en el que no esté esta persona que realiza estas predicciones, pues hay un problema porque a ver quién las hace. Por tanto, mi rol aquí fue pues, simular este modelo de forma de que este conocimiento de esta persona prevalezca durante el tiempo. Esto es lo que realizamos, que fue el pipeline, una vez que ya teníamos diseñado el modelo, y tenemos una primera fase de ingesta. Bueno, todo esto está hecho en Snowflake, con Python, utilizando todas las tecnologías de Snowflake, Snowpark y entregando el valor en Power BI. Y bueno, hacemos la fase de ingesta donde ingestamos los datos de la EMET, del agua registrada, de la suministrada y también de los festivos, que hemos visto que influye, utilizando Airflow y Snowflake Task. Automáticamente pasa al siguiente proceso, que es de detección de outliers y de nulos. Pasamos mediante el Feature Store de Snowflake a un proceso de Feature Engineering, a partir del cual creamos el dataset en el training y entrenamos 3 modelos por municipio, un XGBoost, un Prophet y un ensemble de los dos. El que da mejor test en los últimos 90 días pues se usa para la inferencia en un bucle iterativo para realizar las predicciones para estos próximos 7 días. Aquí además se añaden los sub-values que sirven para explicabilidad y es bastante importante. Ahora veremos en la siguiente diapositiva. Todo se entrega, hay que entregar valor, que es algo que me han enseñado durante las prácticas, que es que si no entregas valor ni un producto, pues de poco sirve lo que estás haciendo. Y pues bien, aquí vemos que todo llega a un Power BI en el que podemos ver, además de replicar todo este proceso automatizado y estas gráficas que se generaban en el Excel, pues añadimos gráficas nuevas que son la evolución de las predicciones, así como el error que da, con un filtrado por los distintos municipios, y este visual de aquí que es los sub-values, es decir, cuánto afecta cada una de las variables, en nuestro caso las 20 variables que más afectan tanto positivamente como negativamente a la predicción base que hace nuestro modelo XGBoost, y pues sirve para también ver que si la variable exceso de calor se muestra sumando mucho a esta predicción base, pues podemos de esta forma conseguir esta experiencia que tienen pues, las personas que llevan trabajando tanto tiempo aquí. En cuanto a conclusiones, desde el punto de vista técnico, yo llegué sin saber lo que era Machine Learning, ni Pipeline, ni MLOs casi, y pues salgo con bastante conocimiento, habiendo aprendido una tecnología de cero, consiguiendo un pipeline en producción que se ejecuta y que consigue un error en los últimos 90 días de 2,37%, que es una locura, y además también me llevo un aprendizaje que es que siempre hay que tener visión de negocio para hacer las cosas. Y en cuanto al crecimiento personal, pues que salgo como un recién graduado en el máster, pero con bastante experiencia y con también una experiencia muy enriquecedora y que disfruta muchísimo. Y bueno, aquí dejo mi perfil de LinkedIn, donde tengo una serie de posts en los que podéis ver más en detalle este proyecto realizado. Además, he terminado mis prácticas, por si alguien quiere contactar, un poco de spam. Y bueno, eso, que muchas gracias a todos.
Well, yes, hello everyone, I'm Fernando. I did my PhD in Chile, in Valparaíso. Yeah, I'm doing a postdoc right now, working with something very much related to this. This is an introduction of how graph theory and measures can help us understand lesions in the brain. So let me see if this works. So yes, first, yeah, we can study the activity in the brain or its connectivity. Here I'm going to differentiate between the structural connections between different parts of the brain, what we call the structure, and the functional connections between different parts of the brain, which is, I don't know, that depends on time and is how different parts of the brain synchronize or correlate their activity depending on the tasks they're doing, etc. So in general, for more than 20 years now, we can model the brain as different nodes which interact in a graph given by the structural connections between those nodes, okay? This graph very much behaves as a graph with communities inside. For example, the occipital part of the brain, the visual cortex, is very much, it almost behaves as an independent community with a lot of connections within it, but not so much out of it. So we have independent modules, so to say, which interact. Integration of segregated parts. So thing is, in different tasks, all these different subnetworks can and must interact and integrate that information for achieving performance in the tasks. How is that possible? It's through the coordination of certain brain parts which function as integrators of the other ones. These are what we call the hubs, or the rich club that we call, which are brain areas that in the brain graph have very central positions in this graph. Those are depicted by the red ones, which are engaged when different modules have to coordinate their activity together. I know there are a lot of details, I'm not going through them, but we're talking about functional specialization in the brain. So, talking about graphs, and since we have different brain areas which are more central than others, actually lesions to different graphs, to different nodes in a graph, can have different effects depending on how different their centrality is. For example, this is a toy network in which I had two communities which are connected through one node, and I was seeing the difference of the dynamics of this when I erased each of the nodes. Of course, there is one very important node here, right? Which is the node that connects the two communities, right? So, thing is, when I correlate the difference in activity, eliminating nodes, against how much each node is connected, which is the upper scatter, I get a certain good correlation, okay, but if I take a specific measure of centrality, I get a very good correlation because that measure of centrality is measuring exactly what that node is doing, which is connecting the two modules. So lesion to not all nodes in a graph are doing exactly the same. We did something very much related to that, which is lesioning the brain in a generative model we have of brain activity. And we saw that lesioning the brain in different areas is not the same, but depends a lot on the centrality of the area we are lesioning. Long story short, we saw the difference in dynamics in our generative model, which was fit to healthy individual data. We lesioned it, we saw where the lesion has the most effect, and we correlated that to the centrality of each brain area. We found that, well, the way we measured integration, well, centrality in this case, was very much correlated with how much the dynamics were going to change, even more than the raw node strength, which is the sum of all connectivities. So different centrality measures can predict how lesions in the brain in different parts have an effect. This was done with healthy data, but we saw that the lesion in certain parts of the brain made the dynamics go a lot closer to vegetative state people brain dynamics. So yeah, that is the second work of my PhD. That came out as a preprint yesterday night, by the way. If someone wants to see it through, you can talk to me. And now we are applying these measures to lesions in stroke patients, because those lesions happen in different parts of the brain, which are connected differently also. Some of them are more central than others. But yeah, I am now working in the Brain Dynamics Laboratory there in Valparaíso, very beautiful city in Chile, and thank you very much. That's it.
Okay, we go on. One of the defining features of ValgrAI Scientific Council Forum is its ability to bridge cutting-edge research with real-world applications. In this session, leading companies from a variety of sectors will showcase how they are leveraging artificial intelligence to drive innovation, improve decision-making, and create value within their organizations. These talks provide a unique perspective of the challenges, opportunities, and lessons learned from implementing AI in industry, highlighting the vital role of collaboration between academia, research centers, and the business ecosystem in shaping the future of AI. The first talk, here we have S2 Grupo, Luis Búrdalo. He will talk about SOCIA, automatización de SOC Industria con IA.
Pues yo soy Luis Búrdalo, director de I+D de la empresa S2 Grupo, y os voy a hablar de un proyecto que se llama SOCIA, se llamaba porque lo hemos terminado ya, y bueno, cómo aplicamos la inteligencia artificial a la automatización de distintas etapas de un SOC de ámbito industrial. Bueno, para los que no nos conozcáis, S2 Grupo somos una compañía de ciberseguridad, somos una gran empresa con sedes en Madrid, en Valencia, en Barcelona, en Donosti, bueno, en Sevilla también. Tenemos sede en Portugal, varias sedes en Europa y sedes también en América Latina. Y cubrimos todos los aspectos de la ciberseguridad, lo que es el compliance hasta lo que es hacking ético, servicios de seguridad gestionada. Y bueno, pues desarrollamos nuestras propias soluciones de ciberseguridad, que es lo que nos lleva muchas veces a batirnos el cobre en proyectos de I+D y en ámbito de investigación, para ser más competitivos y mejorar nuestras soluciones, porque es un mundo en el que los grandes players pues, tenemos que jugárnosla todos los días. ¿Qué vamos a hablar hoy? Bueno, vamos a hablar de este proyecto, que es SOCIA, que es un proyecto que se financió con la iniciativa de compra pública innovadora del INCIBE, que planteó un reto, que es mejorar tecnologías para la ciberseguridad en ámbitos industriales. Y nosotros nos centramos, como es uno de nuestros caballos de batalla, la seguridad en entornos de tecnologías de la operación y infraestructuras críticas, nos centramos en identificar un problema. Tenemos un problema global, que es los SOCs industriales, pues cada vez tienen más presión. Estamos hablando de que las tecnologías de la operación, antes aisladas del resto del ecosistema, cada vez están más conectadas. Se mezcla la problemática de la infraestructura OT y de la prevalencia del servicio con toda la problemática IT. En todas las infraestructuras críticas tenemos también tecnologías IT. Con lo cual, la superficie de ataque se incrementa, tenemos unas cantidades ingentes de información a procesar y, además, tenemos una dependencia muy estricta de expertos, no solamente del sistema productivo, porque no es lo mismo una potabilizadora de agua que una generadora de electricidad, sino también una necesidad imperante de expertos en ciberseguridad dentro de ese ámbito, ¿vale? Con lo cual, la operación realmente en este tipo de entornos es cada vez más costosa. Esto nos lleva al problema real. No se trata de que no seamos capaces de detectar qué es lo que está pasando. Se trata de que es muy difícil operar en ese ambiente. Estamos hablando de entornos en el que hay múltiples herramientas conectadas, no solamente dentro de lo que es el proceso productivo, sino las herramientas de ciberseguridad en sí. Los datos, por supuesto, cada uno es de una fuente diferente. Estamos hablando de entornos en los que a lo mejor tienes datos de imágenes, con datos de volumen de caudal de agua, con datos de quién se ha logado, en qué aplicación y a qué hora. ¿De acuerdo? Hay muchísimos procesos que son manuales, es decir, hay una parte importante automatizada en toda la industria, pero hay una parte de, hay un señor que tiene que coger y abrir una válvula, hay alguien que tiene que hacer un análisis manual, lo estábamos hablando antes, en entornos médicos, llega un punto en el que tienes un analista echando una gota en una placa de Petri, ¿de acuerdo? Y bueno, pues ese conocimiento experto tanto del sistema productivo como de ciberseguridad pues escasea. Lo que tenemos al final es que nuestros SOCs, esa monitorización de estos entornos desde el punto de vista de seguridad, pues resulta ineficiente porque es imposible lidiar con todo esto. ¿Qué hicimos para aportar a esta problemática? Pues desde el proyecto social lo que hicimos fue plantear, vale, cuáles son los dolores, los puntos de actuación que tenemos en cada una de las etapas del ciclo de vida de un servicio de seguridad gestionada, ¿vale? Desde lo que es el momento en el que alguien te pide que le lleves la seguridad y tienes que analizar ese sistema y diseñar esa solución de seguridad para ese sistema, hasta el momento en el que la despliegas y validas que eso está desplegado, calibras, operas y estás analizando y evolucionas. ¿De acuerdo? Tenemos en primeras fases pues que lo que te puede decir el cliente es incompleto, que que tienes que trabajar con fuentes heterogéneas. Aparte, una vez has desplegado, es difícil verificar que realmente está todo desplegado, que estás cubriendo todas las casuísticas, porque, no sé, a lo mejor hay cosas que en un mes no han sucedido y hasta que no pase dentro de 3 meses no sabes si ha respondido bien a una situación. ¿De acuerdo? El ajuste manual habitualmente se hace manual de cuáles son las líneas base, qué es lo que es común, qué es lo que no es común en mi sistema, y luego pues esa sobrecarga de alertas, cómo hago con toda esta información para poder ser eficaz y para poder centrarme en lo que realmente importa. Y luego esto, cuando mañana he sacado la versión 2.3/9 de cualquiera de las herramientas que tenemos, ¿qué hago en mi día a día? Entonces, bueno, los enfoques clásicos se ven limitados porque sí. Se ven limitados porque cada infraestructura es distinta, tenemos toda esta variabilidad. Entonces lo planteamos de una forma divide y vencerás, un clásico que siempre funciona, un módulo para cada una de las soluciones. Módulos que funcionan como un ecosistema que se puede desplegar en diferentes SIEMs, que es el software que se utiliza para monitorizar las organizaciones, interactuando con ese SIEM, y entonces tenemos soluciones tanto para la adquisición de esa información, la normalización dentro del ecosistema, hasta para resolver automáticamente eventos que pueden tener pues cierto grado de repetición, etcétera, etcétera. ¿Vale? Esta solución, al final, lo que aporta es una visión global del problema. Todos los módulos interactúan entre ellos. Y bueno, voy a poneros algún ejemplo. Por ejemplo, uno de los problemas que parece resuelto, pero que siempre tiene mucha miga, es el tema de la normalización de fuentes. El leer de distintos dispositivos y convertirlo a un modelo de datos común con el que después puedas automatizar cosas. Con inteligencia artificial, con un script o con un señor que está mirando una pantalla. La inteligencia artificial no es una bala de plata. Pero claro, normalizar todas las posibles fuentes que hay en el mercado, todos los posibles firewalls, todas las posibles versiones y convertirlo todo eso a nuestro modelo de datos es inabordable a mano. Eso nos quita unas horas de analistas que es, o sea, lo pones sobre el papel y asusta. Entonces desarrollamos un módulo que, utilizando inteligencia artificial generativa, pues era capaz de comparar las normalizaciones que ya teníamos con normalizaciones que no teníamos, con fuentes que estábamos analizando ahora, y proponer una normalización para cada una de esas fuentes, de manera que las fuentes que ya tenemos normalizadas se identifican y se incorporan a nuestro análisis. Las fuentes que no tenemos normalizadas, pero son muy parecidas a algunas que ya tenemos, se proponen soluciones en plan de esto es posible que sea un palo alto de esta versión. Estos campos son los que no he reconocido. En el momento en el que hemos normalizado e incorporado una fuente, cuando un paquete o un log no es reconocido, podemos trabajar con él, es decir, en plan, este paquete de esta fuente no lo he visto. Ostras, pues hay que iterar sobre esta normalización, lo que hablábamos de la evolución. Y esto, que no se ve, en realidad es una de las consolas que tenemos para ello. Vale, voy a pasarme por encima los otros módulos. Bueno, priorización, pues el saber qué eventos atiendo antes y qué eventos atiendo después, al final no es tampoco baladí. ¿Qué es importante y qué no lo es? Tienes unos plazos de atención y de respuesta de los eventos para tu cliente, pero luego tienes que hay eventos que pueden tener un impacto mayor que otros en tu día a día. ¿Cómo sabes cuál es el importante, por cuál empezar? Cuando tienes cantidades de miles de eventos en tu consola, el saber, el ponderarlos en base a criterios establecidos, que es lo que estamos viendo aquí, que puedes además modificar de acuerdo a cada sistema. Bueno, pues yo quiero, aquí sé que voy a tener una variabilidad amplia, pues yo quiero anomalías que estén en torno al 5%. Pero en un sistema que es mucho más predecible, pues quiero apretar más y quedarme con una anomalía del 1%. Y bueno, pues nada, el resultado al final es que tenemos un conjunto de módulos, un ecosistema que puede funcionar encima de nuestra solución ya existente, con las fuentes que se vayan a conectar, de forma que reducimos la carga operativa, ese esfuerzo que deben hacer los analistas humanos, mejoramos la calidad de la detección y mejoramos con esta mayor eficiencia, mejoramos la escalabilidad de la solución. ¿A cuántos clientes puedo darle servicio con las mismas personas, con las mismas máquinas? ¿De acuerdo? Y toda esta automatización, que es mezcla de inteligencia artificial, estadística clásica y, no sé, los viejos pipelines de hecho un script que funciona y lo mantengo, es lo que nos da esto y el modelo de datos común y unos criterios numéricos medibles, es lo que nos abre la puerta a después poder ir a una segunda fase de automatización, a poder contar con entidades autónomas, con agentes que puedan actuar sobre esos puntos concretos, que puedan, ya lo sé, pero es lo que hay. De todas maneras, es la penúltima. Que nos dejen actuar sobre esos puntos concretos. ¿Qué es un agente sin algo sobre lo que actuar? Pues un repositorio de datos y poco más. Y nada, pues lo que hemos conseguido en este proyecto, a grandes rasgos, y leyendo solamente la parte en negrita, es un SOC preparado para el futuro que en realidad es hoy. Y ya está. Muchas gracias. Cualquier duda o cosa que se haya quedado en el tintero, estaré por aquí.
Muchas gracias, Luis. Bueno, la siguiente charla la ofrece Manuel Herranz, que es el CEO de Pangeanic, y se titula IA soberana, ontologías, pequeños modelos y tokens are the new coal.
Sí, soy Manuel Herranz, como bien ha dicho Ana Cidad. Lo siento, no soy Bustamante ni nada de eso. Y hoy os vamos a hablar de lo que ahora llamamos IA soberana, y hace mucho tiempo se conocía como modelos in situ. Bien, también voy a tocar otros aspectos que son unas declaraciones por parte de una empresa muy conocida y que hoy he visto en el móvil que ha sido prohibida por el Gobierno de España para tener contratos con administraciones públicas, aunque le habían dado un contrato de 16 millones con defensa a dedo, porque es una de las empresas más peligrosas del mundo. Bueno, nosotros somos Pangeanic, somos una empresa dedicada sobre todo a la adaptación de modelos. No desarrollamos modelos propios, ya no tiene sentido hacer un 7B, un 8B. Y bueno, nos dedicamos sobre todo a customizar para dar soluciones de IA, entre comillas, a problemas reales. Normalmente son relacionados con el lenguaje, pero no necesariamente. También trabajamos con ontologías y trabajamos en proyectos de ingeniería. Yo soy la misma persona que en el 2004 os habló de modelos de adaptación para clientes como la agencia tributaria, seguimos trabajando con ellos, para la agencia EFE, para los distintos buros que tienen repartidos por el mundo y la adecuación de estilos en traducción para sus traducciones. Y el año pasado le di mucho bombo aquí a los pequeños modelos, que son parte de lo que hacemos en IA soberana. Y bueno, ahí tenéis el vídeo si lo queréis ver. Entonces, esta es mi pregunta para vosotros. Si Palantir se está forrando con una idea muy simple, que ha sido tan simple como aplicar las ontologías a la IA generativa, es que somos tontos, porque yo no he conocido a nadie que le disguste tener dinero. He conocido gente que le disgusta no tener dinero. Pero por tener dinero, pues tal vez estemos trabajando en el sector equivocado o estemos haciendo cosas de la manera equivocada si nuestro fin al final, si nuestro objetivo al final es ganar mucho, mucho, mucho dinero y no nos importa nada, todo lo demás. Para mí todo se resume en una cosa que dijo Peter Thiel, el CEO de Palantir, donde hablaba que se estaban forrando con los tokens. ¿Vale? Y esto es de lo que quiero hablar poco a poco. Ellos se han basado en ontologías, que es una cosa, vamos, las ontologías llevan mucho no es una gran invención. Como veremos, es ciencia medieval, incluso hay gente que lo lleva a Aristóteles, ciencia de clasificación. Pero bien, siguiendo la buena intervención de Virginia esta mañana, me gustaría introducir el concepto de IA soberana. ¿Qué es la IA soberana? No es solamente que yo tenga mis datos en privado y nadie más los vea. No es solamente que mi modelo esté en mi data center o esté en mi nube privada, sino es todo un sistema mediante el cual tanto los datos que yo utilizo para entrenar o los datos que utilizan mis ciudadanos, como decía Rafa de Generalitat, la infraestructura, por supuesto. Y los modelos da igual. Puedes tener un modelo chino adaptado, puedes tener un Gema 4, puedes tener un Mistral, da igual. Pero toda la gobernanza es autónoma. Yo soy el maestro de mis datos, ¿vale? No paso datos de mis clientes a terceras partes para que acaben en otro sitio. Entonces, hay dos modelos, según Manuel Herranz. Uno es la IA cautiva, que es el que utilizamos todos con las apps, la de DeepSeek, la de ChatGPT, la de Gemini, la que vosotros queráis. Y luego está el de la IA soberana, que por imposición legal y ética, administraciones públicas han de ejecutar y cada vez más las empresas. Palantir un poco juega las dos cosas. Juega bastante a hablar de IA soberana, pero el modelo que tienen es cautivo. Es decir, bueno, sí, yo en tu nube te pongo esto, te doy mucha inteligencia, pero te dejo acceso a mis ontologías, a mi toma de decisiones, pero al final vas a morir a su generación de tokens. Os recomiendo que leáis esto, está en inglés, es un análisis más profundo de ello. Bueno, como decía, no han inventado nada nuevo en Palantir, han tomado una idea de clasificación. Es verdad que han trabajado mucho en la ingeniería, la admiro mucho. La ingeniería de cómo han hecho cosas la admiro mucho. Y, bueno, han establecido grandes ontologías para que la relación entre entes sea eficiente, de modo que la solución o la predicción que tú tienes sobre algo es, sinceramente, altamente eficiente. Hasta que te equivocas y terminas bombardeando una escuela en Irán. ¿Para qué se utiliza la IA soberana, entre comillas? Se utiliza en empresas de ciberseguridad, se utiliza en organizaciones de inteligencia, de código abierto, y se utiliza mucho en sanidad. No quiero decir defensa porque es obvio. Y claro, ahí el reto es unir sistemas que están segregados. No decir, oye, ¿cómo se contagió el paciente JK28? Bueno, pues sabemos que tiene COVID, pero ¿cuántas personas estaban atendiendo al paciente JK18 en el turno de noche y no han sido vacunados contra el COVID? Esa pregunta es muchísimo más compleja y sí que necesitas la unión de varios sistemas y buenas ontologías que te lleven a conclusiones fiables. Esta me la voy a saltar, pero como la vais a poner en la web, la podréis ver. Bien, entonces, volvemos al mismo tema. Si mi toma de decisiones yo la tengo fuera y ejecuto esos tokens fuera, por muy baratos que sean, lo que estoy haciendo es pagar por cada consulta que mi policía, mi Ministerio de Defensa, para controlar la zona sur, Marruecos, inmigración, mi médico, auscultándome el riñón, está llevando a cabo. Claro, ahí pasamos de una economía muy distinta, una economía donde hay licencias, y bueno, pues tienes tu licencia de Windows o de ciberseguridad o lo que sea, y bunkerizas a pagar por consumo. El negocio es fenomenal. Claro, acabas de subcontratar tu inteligencia, acabas de subcontratar lo que es CAPEX por OPEX, en términos económicos. Ahí tenéis algunos ejemplos de contratos que han tenido. Afortunadamente, algunos países europeos no entraron en el juego. En Francia y en Alemania ya están de retirada y me alegra mucho que hoy el Gobierno aquí haya dicho que todas las empresas que están relacionadas con la SEPI o son administraciones públicas no pueden hacer negocio con Palantir porque es, literalmente han dicho, es la empresa más peligrosa del mundo. Bien, como solo tengo 2 minutos, vamos más rápido. Todo esto está sucediendo también a nivel global. Nosotros, expertos que tenemos la base en Valencia, trabajamos desde Valencia, hacemos IA soberana para empresas en Estados Unidos, mira tú. En Singapur hemos tenido proyectos, en Japón bastante. Cala muy fácil en culturas donde la privacidad y el respeto a la persona es intrínseco. Japón es terreno fértil para ello. Y bueno, creo que no tengo mucho más tiempo, pero aquí hablo de las arquitecturas, no solamente son ontologías, necesitas grafos de contexto, que son lo que verdaderamente cierra la toma de decisiones en los workflows y en los agentes. Esto no es sencillo, pero está al alcance de empresas e incluso universidades. Hemos tenido un proyecto aquí local financiado por Generalitat, muchas gracias Generalitat, con la UGI, con amparo sobre la creación de ontologías, ontologías en el entorno de movilidad. Bien, y los datos están abiertos. Podéis ir a ecodrive.pangeanic.com, los consultáis todos y podéis hacer vuestros experimentos. Entonces, aquí le voy a dar son caros, los de Gartner son caros de narices, por decir una parte. Pero en esto tenían razón. En el 27, cada vez más vamos a estar utilizando modelos locales o modelos especializados locales. Y por respetar el turno y los stops y las señales de tráfico, aquí lo tengo que dejar. Venga, chao.
Gracias, Manuel. Bueno, la próxima charla la ofrece Fernando Mengot de Nunsys y se titula Inteligencia Artificial aplicada a las Smart Cities. Gracias, Fernando.
Bueno, hola a todos. Soy Fernando Mengot de la empresa Nunsys. Durante el día de hoy querría hablar sobre inteligencia artificial aplicada a las Smart Cities. Por dar un poco de contexto sobre Nunsys, empresa valenciana con más de presencia en 45 países, actualmente dividida en varias unidades de negocio, y yo en particular estoy en la parte de innovación y producto y más centrado en la parte de gemelo digital y Smart Cities. Durante el día de hoy he dividido la presentación en 3 partes. Primero, una introducción de ambos conceptos, es decir, cómo unir la inteligencia artificial con las Smart Cities. Y luego me gustaría presentar 2 casos, 2 modelos que hemos desarrollado dentro del proyecto europeo LDT Toolbox y se entregarán con el desarrollo. Empezando un poco con la línea de trabajo, es importante ver cuáles son las necesidades de las ciudades actuales. Actualmente las ciudades están creciendo mucho y esto tiene problemáticas asociadas a ellos. Tenemos problemáticas de recursos, de infraestructuras y de servicios que cada vez requieren soluciones más complejas. En cuanto al tema de sostenibilidad, sabemos que las ciudades son un gran foco de consumo energético y, por lo tanto, de emisiones asociadas, y se une a la problemática de que el parque europeo de edificios requiere una renovación. Por último, tenemos la desigualdad, que al final hay brechas socioeconómicas que generan riesgos tanto visibles como invisibles, que merecen ser tratados y tenidos en cuenta. En cuanto a la inteligencia artificial, ¿qué papel toma en esta parte? Sabemos que las ciudades han hecho un gran esfuerzo en lo que es la captación de datos y adquisición de datos, pero ahora hace falta nuevas herramientas. Y la IA pues, es esa herramienta que nos permite dar el salto de datos brutos a decisiones estratégicas, ya que nos va a permitir, entre otras cosas, pues, identificar patrones no evidentes, predecir tanto necesidades como predicciones energéticas o de emisiones, simular escenarios que nos permitan pues, diseñar estrategias de optimización para cualquier herramienta y además rellenar huecos de información pues, que aún no están disponibles o no se tienen. En cuanto al ecosistema del dato, hemos hablado que las ciudades tienen datos, pero hace falta pasarte este dato a la información. Por lo tanto, es muy importante conocer de qué disponemos, seleccionarlo, procesarlo y luego darle una utilidad. Actualmente hay mucho trabajo en esta parte, ya que pues, provienen de fuentes heterogéneas, cada uno tiene sus escalas y al final, en ciertos modelos, la calidad del dato dependerá del modelo dependerá de la calidad del dato. Si vamos al primer modelo que quería presentar dentro del proyecto LDT Toolbox, sería el Smart Renovation Strategies. Estos modelos parten del análisis del desafío de las diferentes ciudades. Actualmente sabemos que las ciudades tienen un desafío en cuanto al parque inmobiliario, ya que pues, está envejecido. La mayoría de los edificios, pues, cuando se construyeron, la normativa energética que había entonces no es tan eficiente como la de ahora. Por lo tanto, esto lleva asociado pues, ineficiencias térmicas, que van asociadas a problemas de aislamiento en cubiertas o fachadas, y que llevan asociadas pues, unos consumos energéticos más elevados e incluso de emisiones. Además, sabemos que actualmente los recursos son limitados y, por lo tanto, hacer una optimización de estos recursos es muy interesante para todos. En cuanto a nuestro modelo, el Renovation Strategies, queremos pasar de los datos a la estrategia. Es decir, el modelo va a cruzar fuentes de datos masivas con objetivos estratégicos claros que va a optimizar esta toma de decisiones. Por lo tanto, podemos decir que el modelo permite seleccionar un target, es decir, qué queremos obtener en la ciudad, como puede ser pues, reducir la energía, las emisiones o mejorar la eficiencia térmica, qué presupuesto tenemos para esta renovación, que va a ser un limitante, y qué obtenemos. Pues en este caso, un mapa de edificios prioritarios para renovar con el objetivo de conseguir este target. Hemos hablado que utilizamos datos y que queremos estos datos pasarlos a estrategias. ¿Con qué datos contamos? Pues en este caso contamos con los datos del Europea Building Dataset, el cual nos da datos de los diferentes edificios de construcción, año de edificación, emisiones, costes, incluso valores de transmitancia térmica. Y además, hemos hablado que el presupuesto es una cosa clave. También tenemos datos de costes de renovación. Entonces, para cada edificio se define el coste de renovación de las diferentes actuaciones que podemos tener. En cuanto a por qué es necesario estas nuevas técnicas, pues bueno, pensemos en una ciudad con 100.000 edificios, 3 actuaciones por edificio, como pueden ser no rehabilitar, rehabilitar parcial o total. Vemos que podemos estar muchos años para encontrar la solución. Por lo tanto, nos hacen falta algoritmos inteligentes. Yendo un poco a la parte técnica por encima, al final estamos en un algoritmo de optimización, en el cual pues, combinamos dos métodos, como es un algoritmo genético y una optimización MILP, para encontrar la mejor solución en cada uno de los casos. Si vamos a lo que serían los resultados, si ejecutamos este modelo dentro del Toolbox, podemos ver un vídeo sobre el mapa de Valencia y cómo va cambiando esta optimización de renovación de edificios en base a los diferentes presupuestos que tenemos. Es decir, pasando de 1 millón, 3,5 millones, 6 millones o 8,5 millones. Vemos cómo los edificios van cambiando de la zona y se van añadiendo en base a nuestro presupuesto. También podríamos cambiar el target y la estrategia sería completamente distinta. Por completar y no irnos solo a la parte de renovación, quería presentar el caso de Urban Planning Vulnerability. Este caso parte del desafío de las ciudades de enfrentarse a riesgos que no siempre son detectables con estudios tradicionales. Al final, dentro de las ciudades sabemos que existen patrones ocultos, es decir, hay microrealidades en diferentes zonas. Estas microrealidades tienen asociadas unos riesgos que no siempre son visibles, como pueden ser la soledad, desempleo, edad o incluso el acceso a la vivienda. Y como hemos comentado anteriormente, los recursos son limitados. Entonces, conocer la zona nos puede hacer que nuestros recursos estén mejor utilizados en cada caso. En cuanto a datos utilizados en este modelo, hemos tomado como ejemplo la ciudad de Zaragoza, ya que teníamos sus datos del ISV. El ISV es un indicador de vulnerabilidad compuesto por diferentes indicadores que incluyen patrones tanto sociales, económicos, demográficos y medioambientales, y contábamos con las 501 muestras, una para cada zona censal de la ciudad. Al final en la tabla vemos pues, diferentes indicadores que presentan diferentes resultados para cada zona, y cada color pues, es un poco la agrupación de las categorías. Si nos vamos a la metodología utilizada en el modelo, estamos en la metodología de clustering, en la cual vamos a realizar la generación de embeddings para ver la relación entre diferentes indicadores. Vamos a buscar el número de clústeres óptimo para cada ciudad y luego vamos a realizar el clustering que nos va a permitir ver estas diferencias. Si aplicamos el modelo de Urban Planning Vulnerability dentro de lo que sería también el EDT Toolbox, podemos ver, en este caso en la ciudad de Zaragoza, pues 4 zonas diferenciadas. Vemos a la derecha también una tabla con los diferentes indicadores y podemos detectar, he dejado solo alguno de los 51, podemos detectar diferentes cosas. Podemos ver, por ejemplo, en la zona más de la periferia, pues una población mucho más joven y con unas rentas más bajas, también con problemas de acceso a la vivienda, a diferencia del centro, donde encontramos una población pues, con una mayor edad, cuyos problemas son distintos, como en este caso puede ser el envejecimiento en soledad. Y con esto pues, quería ya terminar la presentación. Quería un poco mostraros 2 de los modelos que se van a presentar y se van a entregar con el Toolbox y aquí estaría. Vamos a estar por el día por aquí, o sea que si hay alguna duda más en detalle a nivel técnico o a nivel de funcionalidades, es un placer responderla.
Bueno, la próxima charla la va a ofrecer Cristina Baixauli, de Veolia, y el título es La inteligencia artificial, un nuevo eje transversal en la gestión del agua. Adelante, Cristina.
Bueno, buenas tardes a todos. Lo primero, dejarme brevemente que presente quién es Veolia. Veolia es una multinacional del sector del medio ambiente que está presente en 56 países a lo largo de los 5 continentes. Aquí tenéis nuestras cifras de las 3 principales actividades que gestionamos, que es agua, energía y residuos, que aterrizadas en nuestro país, en Veolia, en España, bueno, pues tendríamos aquí estas cifras. Como veis, estamos operando en todo el territorio nacional. Si hacemos un poco el foco hacia lo que sería la actividad de agua y concretamente en nuestro país, bueno, pues deciros que llevamos una trayectoria de 157 años de experiencia. Estamos presentes, como veis, también en todas las comunidades de nuestro país y a día de hoy gestionamos un poquito más de 1.100 municipios. Más foco todavía a Comunidad Valenciana, que es donde estamos. Antes nos llamábamos Hidracua, ahora somos Veolia. Lo más importante para mí de esta diapositiva es que nos conozcáis también, no solamente como Veolia, sino como 6 empresas más que son empresas mixtas formadas por capital público, normalmente con el ayuntamiento que gestionamos, Alicante, Elche, Torrevieja, Cullera, Torrente y Paterna, y la parte privada, el socio privado, somos nosotros. Como veis, gestionamos del orden de 79, no 80, porque acabamos de ganar a principio de año un municipio, y nuestro core fundamental de negocio siempre son los procesos vinculados a todo lo que es el ciclo integral del agua. En nuestro ADN siempre hemos llevado, ¿no?, en nuestra manera de hacer, llevamos la bandera de la tecnología y la innovación para poder dar respuesta a todos los retos que nos presentan estos municipios. Por ello, en el año 2017 fuimos pioneros abriendo el primer hub de innovación aquí en España, en este país, el Hub REI Costa Blanca, ubicado en Benidorm, y en el año 2023 reafirmamos esta apuesta abriendo un segundo centro de innovación aquí en la Marina de Valencia. ¿Qué estamos haciendo, no? ¿Cuáles son los casos de uso en los cuales está apareciendo? Nos estamos apoyando en todas las tecnologías de inteligencia artificial. Bueno, tenemos 3 grandes ejes. Esto es a día de hoy, mañana los cambiaremos porque esto está vivo y es dinámico. Uno focalizado hacia la parte de gestión de recursos hídricos. Un segundo eje más centrado en la operación y mantenimiento, sobre todo en gestión de infraestructuras críticas. Y un tercer eje ya en la parte de biofactoría y recuperación de residuos. Os cuento unos casos de usos enmarcados en cada uno de estos ejes. Fijaros qué importante es para nosotros, para poder garantizar la disponibilidad de un recurso tan esencial como es el agua, poder predecir, ¿no?, la cantidad de agua que voy a tener. ¿Cómo? Pues prediciendo el nivel piezométrico que tenemos en los sondeos que gestionamos o incluso, por ejemplo, mirando ese volumen de los embalses que, al final, ¿por qué es esto muy útil para nuestros ayuntamientos? No sé si lo sabéis, pero ahora estamos en época de bonanza hídrica, pero hace unos años hemos salido de la peor etapa, la etapa más larga de sequía de nuestro país. Hemos estado 5 años en sequía con municipios que han sufrido mucho con cortes de suministro. O sea, para un ayuntamiento es fundamental anticiparse a saber cuándo van a haber restricciones, ¿vale? Cuándo van a venir, perdón, y vamos a tener restricciones de agua, ¿no? Por lo tanto, es vital el que nosotros seamos capaces de predecir cuál es el volumen de agua que vamos a tener disponible para servir a las poblaciones. Por otra parte, hablamos de calidad de agua. Qué importante es para nosotros el parámetro de turbidez cuando entra en una planta potabilizadora. ¿Qué pasa cuando llueve? ¿Qué pasa cuando llueve y llueve como está lloviendo? Fijaros cómo está el agua, ¿no? Entonces, poder anticiparnos a esa calidad de agua que va a entrar en puertas de una estación potabilizadora para nosotros es absolutamente primordial. En un segundo eje, toda la parte de operación y mantenimiento de todas las infraestructuras críticas y no críticas que gestionamos dentro del ciclo integral del agua. Bueno, utilizamos metodologías de Computer Vision, mezclado también con algoritmos de Machine Learning, que al final, ¿qué nos permiten? Pues poder identificar y poder predecir, ¿no? Poder clasificar, mejor dicho, los tramos de una tubería, de una red de alcantarillado, cómo de sucios están para poder optimizar todo lo que son las operaciones de limpieza. Por otro lado, sabemos que nuestras redes, las redes de agua, las redes de alcantarillado, ¿vosotros las veis? ¿Están a la vista? No, son subterráneas, ¿no? Por lo tanto, es fundamental no poder predecir, pero sí poder tener algún tipo de herramienta que con algoritmos de IA me puedan indicar por dónde tengo que empezar a renovar los tramos, tanto de alcantarillado como de agua. Cuando queremos renovar un tramo de agua, hay un dato que es muy importante para nosotros, y es la edad de las tuberías. Si supiéramos la edad de las tuberías, más o menos, y el tipo de material que es, la predicción sería muchísimo más fácil. Bien, pues estamos utilizando ya algoritmos, ¿vale?, que nos permitan, ¿vale?, datar lo que es la edad de la tubería. En la parte más de calidad de agua, volvemos a lo mismo. El agua potable, sabéis que el principal, bueno, lo tratamos básicamente con cloro. A veces estos procesos químicos, pues lo que hacen es la aparición de un componente que son los triolemetanos, que son peligrosos para la salud. Por lo tanto, para nosotros es muy importante podernos anticipar a la aparición posible de estos compuestos. Y luego, está muy de moda hablar de la desalación, ¿no? Pero no olvidemos que el agua desalada hay que llevarlas también a los puntos de suministro. Estamos teniendo problemas con el agua salada, al final tiene un componente de salinidad que, por lo tanto, lo que hace es que corrosione mucho el interior de las tuberías. Estamos desarrollando algoritmos que nos permitan anticiparnos, ¿no?, a esos problemas de corrosión. En un tercer eje tenemos toda la parte de ecofactorías y recuperación de residuos. Las estaciones de bombeo de aguas residuales, cuña publicitaria, por favor, las toallitas, os lo pedimos, por favor. O sea, no tenéis ni idea el problema que tenemos con las toallitas, lo que generan en los propios bombeos de residuales que hemos puesto. Pues hemos puesto unos equipos autónomos que lo que nos permiten es, a la mínima que detectan algún tipo de este tipo de residuos, pues nos avisan para poder ir a eliminarlos en ese momento. Los famosos tanques estos que veis en las depuradoras, muchas veces se forman unas natas, unas espumas. Esto no deja de ser un aviso de que algún proceso no está funcionando correctamente, ¿no? Por lo tanto, no solamente nos permite detectar a tiempo estas anomalías, sino también desencadenar, ¿no?, todo un proceso automático para toda la parte de dosificación con espumas. En la parte de optimización de activos y eventos críticos. Fijaros, las membranas de ultrafiltración de una planta potabilizadora son carísimas y, además, la operación del cambio no es ninguna tontería. Es decir, es un proceso que hay que hacerlo con mucho mimo. Qué importante es saber cuál es el momento óptimo para cambiar esos filtros, ¿no? Y, por último, estamos en una zona costera. ¿Qué pasa no solamente en las depuradoras, sino también cuál es el dolor de cabeza de la gestión de alcantarillado y depuración? los picos de conductividad, es decir, las intrusiones de aguas salinas. Es muy importante, ¿vale?, el que podamos adelantarnos a este tipo de episodios. Ahora bien, yo os diría, ¿qué reto estamos teniendo? No sé si solamente las empresas de agua, pero desde luego nosotros internamente. Pues lo hemos visto esta mañana con Jorge. Tenemos un montón de algoritmos, desarrollo o no desarrollo en modo piloto, pero es que tenemos que ser capaces de integrarlo en toda la maquinaria que tenemos en marcha. Nosotros somos un servicio 24 horas, 365 días. Nosotros no paramos. Por lo tanto, el poder llegar a la realidad, es decir, al enganchar, al tener un algoritmo como la predicción de la demanda, que todos los días a las 8 de la mañana me va a decir, ¿no?, cuál es la previsión de consumo que voy a tener, para nosotros es fundamental. Pero ¿qué nos está pasando también? Y Vicente, ayer decías, eso es obsoleto. Bueno, será obsoleto para un entorno tan investigador como el vuestro, ¿no? Pero las herramientas de IA generativa están entrando en las compañías como un tanque así arrollador, y estamos viendo cómo el impacto está siendo en absolutamente todas las áreas de la compañía y a nivel de todos los perfiles, desde un administrativo de atención al cliente, un responsable técnico de operaciones, el director jurídico, el equipo de recursos humanos, ni deciros del área de comunicación, el equipo de clientes, o sea, absolutamente todo, ¿no? Entonces, estamos viendo cómo nos estamos transformando internamente de una manera increíble. O sea, son unas herramientas que han llegado y que además... Y ahora es cuando te miro a los ojos, Vicent, y te digo, ¿qué es lo que está por venir? Me decías, la IA generativa está obsoleta. Bueno, la estamos descubriendo, pero lo que también estamos descubriendo es qué está por venir. Evidentemente, está por venir el mundo de los agentes. Estoy segura que el año que viene, las ponencias, nos vamos a centrar en cuántos agentes tenemos desarrollados dentro de la empresa, ¿no? ¿Cómo lo vemos nosotros? Bueno, vemos al final pues un ecosistema formado por esos algoritmos de IA tradicional que ya hemos ido desarrollando, que se complementan, ¿no?, y que se enriquecen mucho con la parte creativa de la IA generativa y, desde luego, disparados, ¿no?, por esa serie de agentes, ¿no?, que vamos a ir desarrollando. Pero no perdamos de vista que tenemos que estar en el centro. No perdamos de vista que somos las personas las que orquestamos todo este ecosistema. Por ello, bueno, desde Veolia sí que os digo que estamos absolutamente convencidos de que para nosotros la inteligencia artificial es un nuevo eje transversal para la gestión de un recurso natural escaso y tan esencial como es el agua. Muchas gracias.
Muchas gracias, Cristina. Bueno, y la próxima charla la ofrece José Vicente Cercós, de Hídrica, y se titula De datos a decisiones y de decisiones a acciones con Xylem Vue.
Gracias. Bueno, buenos días. Creo que hemos hablado ya todos de datos, de las decisiones, las acciones con los agentes. Pues bueno, voy a dar otra dimensión más, ¿no?, desde Xylem Vue. Xylem Vue es la plataforma que hemos desarrollado para la gestión del ciclo integral del agua. Tengo que daros contexto también de qué es Hídrica, qué es Xylem Vue y dónde nace, ¿no? Y para eso tengo que empezar a hablar de Global Omnium. Global Omnium es una de las utilities pues, líder mundial en innovación. También invirtió muchísimo dinero en esa transformación digital totalmente necesaria para afrontar pues, todos los retos que se vienen en el sector del agua, como Cristina ha estado comentando. Eso viene a través de una experiencia de más de 100 años y de gestión de más de 400 municipios, entre ellos la ciudad de Valencia, ¿no? Y a partir de ahí tenemos que resolver ciertos retos, ¿no? Esos retos es la escasez del agua. Todos sabemos que es un recurso preciado y que tenemos que intentar optimizar. Los elevados costes de producción del agua también es algo que tenemos que tener en consideración. Y luego, a lo largo de esa experiencia, ¿no?, de más de 100 años, acabas acumulando un montón de sistemas que son dispersos, de datos que son heterogéneos, de sistemas, bueno, pues que no son tan modernos, y todo eso te lo tenemos que integrar, ¿no?, para poder tomar unos buenos datos. Y la brecha generacional, lo que estábamos hablando, ¿no? Cristina estaba comentando que hablaremos de agentes, hablaremos de un montón de cosas, cómo viene la IA, cómo nos está apretando la IA desde la parte de los posibles CEOs, ¿no? Esta mañana también estábamos hablando de quiero la IA, ¿para qué? Pero quiero la IA, la quiero ahora, ¿no? Esa presión la tenemos, la presión interna de los distintos departamentos presionándonos, Esa brecha generacional es importante, porque tenemos gente que está a punto de jubilarse que tiene un know-how increíble y gente que entra nueva que quiere utilizar herramientas digitales. Vamos a ver cómo combinamos todo esto. Pues se hizo una inversión muy importante durante esos últimos 15 años, antes de la creación de Hídrica. Hídrica nace en 2020 con ese espíritu de comercializar esa solución digital que utiliza Global Omnium. Inicialmente llamamos al producto GoAigua, haciendo un guiño hacia Global Omnium, AI en cuanto a inteligencia artificial y Aigua, ¿no? La palabra agua en valenciano. Y nuestra andadura a nivel internacional pues, nos llevó a empezar a aprender el uso del agua en distintos mercados, ¿no? ¿Qué ocurre? Por ejemplo, el primer sitio donde fuimos, en Houston, nos llamaron porque tenían un montón de problemas con la red de alcantarillado. La red de alcantarillado de Estados Unidos, o la de Houston en particular, pues no está bien dimensionada, está infradimensionada. Tenían un montón de problemas con la red, tenían un montón de atascos y eso producía desbordamientos en la calle. Al final, Houston puso una sanción de unos $50.000 cada vez que había un desbordamiento y dijo, así lo van a tener que arreglar sí o sí, porque es un dineral. Nos llamaron y instalamos nuestra solución de detección de obstrucciones con un modelo que predecía cuántas horas iban a pasar hasta que se produjera el desbordamiento. Con esto podíamos enviar a personal de campo a hacer la limpieza preventiva y solucionar el problema. Pues uno de los ejemplos, ¿no? Cosas que aquí en España pues no nos pasa porque el alcantarillado está sobredimensionado muchas veces. Otra experiencia interesante, ¿no? O curiosa es la de Qatar. En Qatar sabéis que tienen problemas de escasez de agua. Ellos, la depuración del agua para ellos es crítica porque quieren reutilizar al máximo posible el agua. Y en 2022 tuvieron que organizar la FIFA, el Mundial de Fútbol. ¿Qué ocurre? Que querían tener el país pues, con parques y jardines bien regados, bien mantenidos, pero con la mentalidad de que tenían que aprovechar el agua. Diseñamos una solución inteligente para regar parques y jardines utilizando agua reusada y manteniendo pues, lo mejor posible esas estancias. Otro dato curioso, pues ese agua reutilizada la utilizan para llevar a torres de refrigeración que tienen en los edificios para la climatización, pero no solo para eso, incluso para ducharse. Aquí calentamos el agua y allí la tienen que enfriar, ¿no? Para ducharse, cosas curiosas, ¿no? Que vamos aprendiendo. En 2024, una multinacional americana, en este caso Xylem, que es uno de los principales fabricantes de dispositivos para el mundo del agua, se fija en nosotros y nos invierte, adquiere la mayoría de las participaciones y cambiamos el nombre de la solución a Xylem Vue. De ahí viene el nombre. Los retos del sector del agua no los voy a volver a repetir. La ventaja de ser de los últimos es que muchos ya han nombrado esto y mi colega Cristina suele nombrarlos, ¿no? Pero bueno, ahí los tenéis. Sí que es importante mencionar que nosotros cuando vamos a una utility pues le preguntamos cuáles son los dolores. Lo primero que nos preguntan es, ¿tenéis IA? Lo primero, ¿vale? Que es, si veis, es el último escalón, ¿no? ¿Y tenéis agentes? ¿Y tenéis...? Sí, claro, tenemos de todo. Pero vamos a empezar a hablar de cosas serias, ¿no? ¿Cómo tienes preparada la utility? ¿Tienes esos datos? ¿Tienes dispositivos que te digitalizan y te envían esa información de forma adecuada? Ese es el primer escalón de ese grado de madurez que tenemos que analizar cuando aterrizamos, ¿no? Para eso captamos esos datos, los unificamos en esa plataforma, que decía mi compañero también Luis, ¿no? Una plataforma donde homogeneizas el dato, tienes un modelo de datos único donde tomar decisiones. La capa visualización, importante en las utilities del agua, esa capa GIS que te consolida datos que son pues, monstruosos, ¿no? Y te lo representan en un mapa para poder tomar decisiones. Y a partir de ahí podemos empezar a hablar de ciencia de datos, de analíticas, de detección de patrones, de utilizar esos patrones para detectar anomalías, para buscar fugas. Un montón de casos de uso como Cristina pues, ha mencionado, ¿no? Con esos datos, además, si tenemos actuadores, podemos optimizar procesos industriales. Podemos calcular cuál es la forma más eficiente de hacer algo y, bueno, pues actuar, ¿no? Optimizar. Y la última capa ya hablamos de la inteligencia operacional, donde ya podemos meter pues, los gemelos digitales que representan una realidad, la modelan, podemos ejecutar un montón de escenarios posibles y bueno, pues implementar esa parte agéntica, ¿no? Que alguien de alguna forma esté ejecutándose de forma virtual, distintos escenarios y proponiéndote acciones a realizar. En cuanto a arquitectura de la solución, voy a ser muy rápido aquí. Hemos hablado de datos heterogéneos que vienen de distintos sistemas. Lo consolidamos en una plataforma que nosotros llamamos Smart Water Engine. Referenciando a mi compañero Manuel, utilizamos ontologías para entender de qué estamos hablando. No es lo mismo un pozo que un data logger que está midiendo un caudal y está asociado a un determinado activo. Con esto ya podemos tener casos de uso utilizando pues, esa información y resolviendo los problemas del ciclo integral del agua, que va desde la potabilización, la gestión de la red de agua potable, la gestión del alcantarillado y la depuración y devolución al medio. Todo esto envuelto en esa capa de inteligencia operacional que recopila toda la información. Y la información no la utilizamos para nosotros mismos, solo para el producto, solo para no es propietaria, como decía antes Manuel. Disponibilizamos un data lake donde un científico de datos en la propia empresa puede utilizarlo y mejorar o añadir sus propios modelos, ¿no? La IA al final la tenemos en todas las capas, ¿no? Es la pregunta que te van a hacer cuando llevas un producto digital. Otra innovación bueno, que hemos añadido desde hace un año, somos una empresa de desarrollo de software, de soluciones del agua. Hemos cambiado el paradigma del ciclo de desarrollo de software. Empezamos no solo con la parte del desarrollo, de la codificación, sino desde la parte de la ideación de producto. Nos hacemos preguntas como, oye, ¿cuál es el valor de mercado? ¿Qué estoy resolviendo realmente en la utility? ¿Cómo de importante es esto? Con esto conseguimos priorizar cuáles son las ideas que tenemos que llevar a mercado y que van a ser más atractivas. El análisis funcional lo podemos detallar al máximo posible. Toda la especificación que podamos necesitar nos la va a preguntar una IA, un agente que hemos creado nosotros, que es experto en desarrollo de soluciones para el agua. Incluso podemos hacer un prototipado rápido y de alguna forma iterarlo hasta que estemos suficientemente tranquilos de que hemos cubierto todos los casos de uso. Análisis técnico no nos lo podemos saltar, o sea, no va desde el product manager a la implementación directamente. Tenemos que hacer un análisis técnico porque trabajamos con volumetría, trabajamos con tiempo computacional que tenemos que medir y tenemos que diseñar la solución entendiendo qué es lo que va detrás de esto y optimizándolo. Desarrollo, por supuesto, pruebas es también evidente y la documentación acaba siendo la última fase en la que la IA nos ayuda recopilando toda la información que hemos utilizado durante todos los procesos. Es una consecuencia, no es un esfuerzo, ¿vale? Hemos hecho ese cambio de paradigma. Entrando a casos concretos, ¿no? Cristina ha nombrado varios, pero porque veáis algún pequeño ejemplo también. Analizamos las imágenes de vídeo de la red de alcantarillado para detectar esas obstrucciones y categorizarlo a nivel de infraestructura, cómo está de dañada o no y reemplazo. Lo utilizamos para buscar fugas en la red de agua potable con imágenes satelitales. Y, bueno, pues al final acabamos haciendo patrones, anomalías, predicciones de futuro, pues que sería la forma clásica de utilizar el Machine Learning. La última parte, mi última slide, que habla de las acciones, que esta es la parte novedosa, ¿no?, que decía Cristina. El año que viene hablamos de agentes. Nosotros hemos introducido ya una nueva pieza en nuestra arquitectura, que es un MCP, que cataloga todas las acciones que podemos hacer dentro de nuestro software. Acciones que pueden ser desde consultar cuál es el nivel de un depósito hasta poder incluso proponer soluciones, ¿no?, pues para resolver un problema. Esto nos habilita a poder utilizar cualquier LLM, sea propietario, sea un cloud privado, sea abierto. El LLM no va a tener acceso a los datos, lo almacenamos en nuestra capa de seguridad, pero nos habilita a tener estos agentes, ¿no?, que al final la utility nos pregunta, oye, ¿cómo puedo hacer esto? Y no nos quedamos ahí, sino que le dotamos de contexto experto del mundo del agua. Esa brecha generacional la eliminamos. Cogemos la información, tenemos el contexto y somos capaces de acabar en la última etapa, ¿no? Decir, bueno, tenemos un compañero virtual, que es un compañero que tiene el conocimiento del agua, tiene acceso a los datos, a las herramientas, a las interfaces y me va a proponer cosas. Cuando llegue a primera hora de la mañana me va a decir, haz esto o haz lo otro. Y esto era todo. Muchas gracias.
Muchas gracias. Bueno, y ahora la última charla de las Company Talks la ofrece Sol García de Samuba y Pentec y el título es IA aplicada al aprendizaje y la gestión del conocimiento. Eficiencia, personalización y ventaja competitiva. Adelante, Sol.
Buenas tardes. Ante todo, muchísimas gracias a ValgrAI por darnos este espacio. Mi nombre es Sol García Y bueno, soy directora del área e-learning de Pentec, que ahora os explicaré muy por encima pues quiénes somos, sobre todo para entender pues el contexto de esta intervención. Yo, a diferencia del resto de mis compañeros, seguramente no me voy a meter tanto a nivel técnico, pero sí que creo que os voy a hacer reflexionar un poquito de pues, la IA, en qué situación estamos en las empresas de desarrollo, ¿no? y cómo la estamos aplicando, o sobre todo pues, en mi área, ¿no? Más enfocada a lo que es la educación. Voy para atrás. Bueno, un poquito lo que os he comentado. A ver, es importante entender quiénes somos. Veréis en mi presentación que tenemos dos logotipos, ¿no? Pentec y SAMU. Bueno, nuestra empresa matriz es Pentec, somos una empresa que lleva más de 26 años en Valencia, en el área de desarrollo IT, ¿vale? Y que somos expertos pues, en toda la parte de desarrollo a medida, integración de sistemas, arquitectura de datos y, por supuesto, en toda la parte de IA aplicada a proyectos complejos y de alta exigencia técnica, sobre todo en el ámbito de la administración pública. Aquí es importante indicar que pues, el área que yo dirijo, que es nuestra área especializada en educación, en innovación educativa, y la comercializamos bajo la marca de SAMU, que nos habréis visto por ahí fuera llenos de botellas rosas, ¿no? En el área de SAMU pues, tenemos pues, un equipo especializado, ¿vale? En todo lo que es innovación educativa y, bueno, y aprendizaje digital. ¿Qué es lo más destacable? Bueno, pues que tenemos un equipo multidisciplinar y aquí, bueno, desde ese punto de vista tecnológico, funcional y pedagógico. Pero, bueno, ese tándem, ¿no? Pentec-SAMU, lo que nos permite es que unimos esa solvencia tecnológica y esa especialización educativa, de manera que lo que os voy a enseñar hoy, o la reflexión que quiero que hagamos hoy, es cómo ha entrado, y sobre todo en los últimos meses, que ha habido un progreso muy significativo en cómo nos ayuda la IA a optimizar los procesos de desarrollo. ¿Vale? Indicar que, bueno, yo lo que quiero que reflexionemos durante esta presentación es que la IA pues, no aporta ideas nuevas. Lo que nos está haciendo es que nos hace viables las que ya teníamos, ¿vale? Nosotros, y yo aquí hablo desde el punto de vista de la educación, ¿no? Que es el área que yo controlo, os estoy hablando del año 2015-2016, teníamos muy claro hacia dónde iba la innovación en educación, ¿vale? ¿Hacia dónde iba? Pues el aprendizaje centrado en el alumno, la personalización real del aprendizaje. ¿Cuál era el problema que teníamos en ese momento? Pues que no era viable realmente el desarrollo de esos itinerarios adaptativos, de esa personalización del contenido real, de esa detección de patrones, etcétera. Era costoso, al final era costoso, era lento. No encontrábamos el cliente, ¿no?, que quisiera asumir ese coste. Con lo que es la IA, y sobre todo en los últimos años, que nos hemos encontrado, ¿no?, en SAMU, y con ese refuerzo, ¿no?, tecnológico de nuestra empresa matriz, pues que nos ha ayudado, y sobre todo, ya os digo, en los últimos meses a la hora del desarrollo, que estamos mejorando los procesos, hay una eficiencia en los procesos real, ¿no?, de que podemos automatizar, ¿no?, tareas de alto consumo, que podemos escalar, ¿no?, esos pequeños proyectos que al final eran pilotos, nos permite escalarlo, ¿no?, y hacerlo realidad, porque yo realmente a nivel educativo y a nivel metodológico tengo muy claro lo que necesitan los alumnos de una universidad. El problema era plasmarlo y, sobre todo, pues efectivamente, como os he comentado, pues pasar de esa parte teórica, ¿no?, a la práctica. Y eso es en lo que estamos trabajando ahora mismo. ¿Cuál es el gran problema que tenemos en el ámbito universitario, sobre todo? Bueno, nosotros en SAMU, en el área de SAMU, hemos lanzado un producto que es UX for Learning Platform, que lo que nos permite es generar ecosistemas inteligentes. Aquí, bueno, estoy en el ámbito universitario, ¿vale? Aquí todos entendemos qué tenemos en una universidad, qué elementos tenemos en una universidad. Pues tenemos, en primer lugar, el LMS, tenemos la intranet, tenemos el sistema de gestión de vídeos, tenemos el antiplagio, tenemos la detección de accesibilidad y todo ello lo tenemos integrado. ¿Pero lo tenemos integrado de una manera inteligente? No. ¿Por qué? Porque yo ahora mismo no sé si realmente un alumno que visualiza vídeos en lugar de leer un PDF está aprendiendo más rápido. O yo no sé si realmente yo estoy pues, utilizando todas las licencias que he adquirido de un antiplagio. O que realmente un alumno que está utilizando la IA tiene peores o mejores calificaciones que otro. Nosotros ahora mismo, y ahora lo vais a ver con un claro ejemplo, consideramos que la ventaja competitiva del uso de la IA pues, no es integrarla, sino pues, analizar y, bueno, en este caso, nos ayuda a integrar los datos propios, procesos reales y objetivos claros. Aquí os voy a enseñar, y lo siento porque 10 minutos no dan para mucho y os he metido todos los dashboards en una única pantalla, ¿vale? Pero bueno, veis que están señalizados con una pequeña letra, ¿vale? Bueno, ¿qué es UX4? Learning Intelligence. Pues es una capa que se incluye dentro de lo que es el ecosistema y que nos genera analítica inteligente y datos inteligentes con todos los sistemas que tenemos actualmente dentro de una universidad, una institución académica o cualquier empresa que imparta formación. Si vemos, por ejemplo, pues la primera imagen nos permite pues, ver la detección, bueno, es la capa de analítica de riesgo y de detección del riesgo precoz. ¿Vale? Nos permite identificar señales de abandono o desmotivación antes de que sea tarde. Por ejemplo, pues un alumno que está obteniendo malas notas o que no se está conectando a la plataforma o que tiene un retraso incluso en sus pagos. ¿Vale? La segunda capa es el análisis competencional. Ahora mismo, por lo menos en el ámbito de Latinoamérica, pues la evaluación por competencias en las universidades es una realidad. ¿Vale? Y aquí vamos a ir más allá. Estamos cruzando datos no solo del contenido que está subido en la plataforma, sino el que se adquiere pues, a través de los gestores de vídeo u otras plataformas, ¿no? de formación. Nos permite entender no solo quién aprueba, ¿vale? Sino qué competencias se está desarrollando y qué actividades generan más impacto. Aquí también la C, y yo creo que esta es muy importante y que llevamos muchos años en el ámbito de la educación, es pues cómo aprende mi alumno, la experiencia de aprendizaje, cómo aprende, en qué punto lo estoy reteniendo. ¿Aprende mejor con vídeo? ¿Aprende con formatos alternativos, por ejemplo, de una herramienta como puede ser Alai? Pues aquí lo podemos ver, ¿no? ¿Qué contenido funciona mejor o peor? Y ya os digo que esto al final estamos tomando los datos de todas las herramientas que tenemos en el ecosistema. El tema de la accesibilidad, el tema de la gestión de vídeo, como ya os he comentado, que realmente es el gran vacío, ¿no? que tenemos en el ámbito de la educación. Y en último lugar, y aquí sí que no me gustaría pasarlo sin explicarlo, es el dashboard de gobernanza orientado al administrador. ¿Qué estoy consumiendo? ¿Cómo lo estoy consumiendo? Realmente hay muchas decisiones que cuando una institución adquiere licencias de varios proveedores, el problema es que muchas veces no tiene esa visión global. Pues aquí se lo plasmamos también en ese sentido. En definitiva, pues que este ecosistema inteligente nos va a permitir decidir mejor y convertir este conocimiento en una ventaja competitiva y, sobre todo, tomar decisiones antes de que suceda. Por último, perdón, vale, no me lo has actualizado, vale, nada, por último, bueno, pues mi reflexión hoy sería que la tecnología ha alcanzado nuestras ideas. A nosotros, como empresa de desarrollo, lo que nos está permitiendo la IA, efectivamente, es mejorar esos procesos, hacer factibles ideas que teníamos en el tintero y que no eran viables. Ayer, de hecho, durante la cena lo comentábamos. Nosotros lo que estamos haciendo con la IA es que al cliente, por el mismo coste, le estamos dando un mejor servicio. Y esto es importante, ¿vale? La ventaja, bueno, pues como, y ya corto, ¿vale? En este sentido es esa para nosotros, ¿vale? Y bueno, nada, muchísimas gracias. Preguntas, estamos en el stand de fuera y nada, gracias a todos.
Muchas gracias, Sol. Now, our next speaker is Professor José Mª Azorín, full professor at the Universidad Miguel Hernández de Elche and director of the Brain-Machine Interface System Lab, an internationally recognized expert in brain-machine interfaces, neurorobotics, and rehabilitation robotics. His research explores how artificial intelligence and neurotechnology can help enhance human capabilities and improve quality of life. Please join me in welcoming José Mª Azorín.
Well, good afternoon, everyone, and thank you, Anna, for the introduction. Of course, thank you, Vicent, for letting me to be here. So I'm going to talk about different projects that we have developed at Universidad Miguel Hernández de Elche about the development of brain-machine interfaces for interacting with robotics exoskeletons. What is the goal? The goal is to try to improve, the current rehabilitation therapies that are being used with people that have suffered some kind of neurological condition, such as, for instance, a stroke or a spinal cord injury. So before starting with my talk, let me show you where we are. We are located in Elche. Elche is in the south of Comunitat Valenciana, and we are very close to Alicante. And we started to develop, brain-machine interfaces like 20 years ago. First of all, we started to understand how the brain is working, how we can decode the brain in order to perform some kind of, control of external devices without moving any muscle. For instance, you can see here in this video, in this picture, that we started to control, for instance, industrial robots in order to perform some kind of pick-up-place task, but only by commanding the robot by using the brain signals. I mean, without controlling any kind of interface, physical interface. And after that, we realized that maybe we could use all this knowledge in order to command, wearable robots. I mean, if we can decode the brain signal, what we can do is we can try to control robotic exoskeletons in order to help people to walk or, for instance, to move their arms. So in my talk, I'm going to focus on this kind of brain-machine interfaces that we have developed for controlling lower limb exoskeleton. So, which is our motivation? Our motivation is this one. I mean, there are multiple neurological conditions that can affect the gait. For instance, when a person has suffered a stroke, the person maybe can recover the gait, but is not going to walk in a natural way. We are going to check, for instance, in this video, that people can walk, of course, but they are not walking on a natural way. So what happens when a person has suffered, for instance, a stroke? Well, what happens is that they follow a motor rehabilitation therapy. And usually, they follow what is called a bottom-up approach. I mean, basically, imagine that the person has suffered a stroke, and the problem is on the brain of the person. So there is, for instance, the motor cortex has been affected, and the person cannot walk in a natural way. So in that case, what people do is this kind of rehabilitation when there are some people moving physically the legs of the person in order to try to promote the neuroplasticity that has been lost on the brain. I mean, imagine the problem is on the brain, but we are not acting on the brain. We are acting on the legs of the person in order to try to promote the neural mechanisms. In this picture, in this video, you can see that there are 3 people for performing the rehabilitation. 2 people that are physically moving the legs of the person, and another one that is assuring the stability of the user over the treadmill. So as you can imagine, this is quite hard for everyone, and the cost is also important. And a lot of time, the task is very repetitive, is to move the legs all the time of the person. So fortunately, in the last year, different kind of robotics exoskeleton have appeared. You can see here several examples. All of them are focused on lower limbs. I mean, they are helping people to walk around. But this kind of technique, this kind of machine can be used for, helping people to rehabilitate. I mean, because in the end, they are moving the legs. There is not people moving the legs of the person, but there are robots that are actually moving the legs of the person. But in the end, we are following this kind of traditional rehabilitation, this kind of bottom-up approach. We are not acting on the brain level. Indeed, these devices are generally commanded by physical interfaces. For instance, you have to press some button if you want to go to start the gate or to stop the gate, or even in some cases, you have to shift your body in order to start the gate. But in the end, what we are doing is the same, therapy. We are moving the legs of the person in order to try to promote the neural mechanism that have been lost. Well, what we think in our lab, in the Brain-Machine Interface Systems lab, is that we could improve, the current rehabilitation therapies by combining brain-machine interfaces and combining robotics exoskeletons. A brain-machine interface is a system that is collecting the brain signals in order to process them and in order to know if the person wants to walk, the person wants to stop the gait, the person wants to move their arm, etc. But in the end, we need to collect the brain signals. And in our case, in our lab, what we are doing is we are collecting the brain signals by using, electroencephalography. It's a non-invasive technique. It's very, there is any harm for the user. But in the end, what we are doing is, we are collecting the brain signal, and you can see here, and we are doing a kind of bypass in order to know if the person wants to start the gate or to stop the gate. For instance, if you want to start the gate, what we do is we send a command to a lower limb exoskeleton in order to physically starting the gate, okay? So what we have introduced is this kind of new top-down approach, because now, if the person wants to walk, there is nobody that is physically moving the leg of the person, but it's the arm user who is sending a command to the legs. How? Because he has to think, or she has to think, about moving their legs, okay? So we are combining this kind of traditional rehabilitation, this kind of bottom-up approach, with this new top-down approach. We are doing both at the same time. And we think that this is going to be better for the rehabilitation of the user. We are going to promote better the neuroplasticity. So I'm going to show you two projects where we have done this, where we have developed different kind of brain-machine interfaces for trying to help people to recover from some kind of stroke or spinal cord injury. The first project is the WALK project. This was a project that we ended in 2022, and it was a project that we did in collaboration with several centers. We collaborated with the main hospital in Spain for paraplegics, that is in Toledo, and also we collaborated with a hospital in Asturias, and we also collaborated with the University of Houston. What was the idea? The idea was to develop a brain-machine interface in order to command, the movement of a lower limb exoskeleton. So basically the idea was, if I want to walk with the exoskeleton, I have to be thinking all the time about moving my legs. So while the brain-machine interface is detecting that I am thinking about moving my legs, the exoskeleton is being moved. But as soon as I relax, the exoskeleton is stopped. So basically that's the idea. But for doing that, we needed to implement two different kinds of brain-machine interfaces. One that is used when the person is in the static condition. When the person is in the static, is stopped, he has to think about the motor imagery in order to start the gate, okay? And we implemented another different kind of brain-machine interface for the moving condition. I mean, while I'm working with the exoskeleton, I need to be thinking again about moving my legs in order to command the exoskeleton, because if not, the exoskeleton is going to be stopped. So let me explain you this with more detail. So in order to do that, we needed to calibrate two different kinds of brain-machine interfaces. And for doing that, we need a lot of training for each user. Indeed, what we did is 5 sessions during consecutive days. I mean, every day we perform one different session when, first of all, we collected a lot of signals from the users in order to train our models. So, first of all, what we did is, okay, we are going to train the model that is used when the person is in static. The person is not moving. In this case, first of all, the person was relaxed during several seconds, and we were collecting all the EEG signal. And after that, we said to the person, now you have to be thinking about moving your legs. You are not going to move your legs. You are going to think about that. And we were collecting all the signals. And after that, we repeat again the process. And we did that 10 times. So in the end, we were collecting a lot of signals in order to have enough data in order to train our model. And we repeated the process, in this case, when the person is actually moving with the exoskeleton. So the person was wearing the exoskeleton. The person, first of all, was relaxed, although the exoskeleton was being moved. And after that, while the exoskeleton was being moved, the person also thinking about moving his legs. And finally, the person was again relaxed, and we were collecting all the EEG signal. We have to do this for each user every day in order to train the system, because if not, the user is not going to be able to use, the exoskeleton with the brain-machine interface. Well, I'm not going to get into a lot of detail, but I have to say that basically for doing that, what we did is we collected 27 electrodes, 27 EEG signal from the motor cortex area, basically. And we extracted the main feature of the EEG signal, and after that, we use a very simple machine learning technique in order to, classify if the person was thinking about motor imagery, was thinking about movement of the legs, or if the person was relaxed. So after that we train the system. We have, the VMIs with all the models calibrated. The person can use the system. And for doing that, the person, first of all, is relaxed and is using this brain machine that we have adjusted during the static condition. So the person needs to think about walking. And as soon as the person starts to think about the movement of their legs, what we do is actually we activated the exoskeleton, so the exoskeleton starts to walk, and we go to the other brain-machine interface. And in this case, if the person is thinking all the time about moving his legs, the exoskeleton will be moved. But if the person is relaxed, we will stop the exoskeleton. And we repeated this process, in this case, 5 times per user. So let me put you now one video of one of the experiments that we did with one spinal cord injury patient at the Hospital for Paraplegics in Toledo. The video has sound. I hope that the video can be heard. Basically, the person is, I don't know if we can hear the sound. No. Okay, anyway. Basically, the experimenter has said the person, imagine that you are moving your legs. So the person starts to think about the imagination of walking. And as soon as the VMI detects that, we send a command to the lower limb exoskeleton, so the lower limb exoskeleton starts to walk. Okay? You maybe have checked that suddenly the exoskeleton has been stopped. This is because maybe, the brain-machine interface has not detected that the person was thinking about that, or maybe it was because, the person has not think about that. Anyway, we checked that the person was in charge of his rehabilitation. I mean, the person was capable of walking because the person was thinking about movement of their legs. So now there is nobody that is physically moving the legs. Now he's moving his legs because he wants to move his legs, and he is sending that command by using their brain signal. As you can see here in this video, there are several people assisting the experiment. I mean, there is a person behind the volunteer that is assuring the stability of the exoskeleton, and also there is another one that is, assuring the stability of, this kind of scratches. But this is also because it was a requirement by the hospital. So it would be possible for the user to use the system with the brain-machine interface and the exoskeleton. Anyway, we checked that the person can use the system, but we realized that it was quite difficult for him to be all the time thinking about the motor imagery in order to, assure that the exoskeleton is being moved. So we started a new project, that is the project Regate, that we are going to finish this project next month. And it's a project where we have tried to improve, the accuracy of the decoding, and we have tried to implement a brain-machine interface that can be used in an easier way by, the volunteer. This is a project that we are also doing in collaboration with the Hospital for Paraplegics in Toledo and the University of Houston and the Hospital of Asturias. And also, in this project, we have incorporated the Institut Guzman in Barcelona. So what is the idea? One of the things that we did in this project is to change the paradigm for commanding the exoskeleton. I mean, in the previous case, as I have told you, what we needed to do is all the time to be thinking about moving our legs if I want to command the exoskeleton. But this is not what we do. If I want to walk, I don't have to be all the time thinking that I want to walk. So basically what I do is, okay, I send a command to start my gait, and when I want, I stop my gait. So we implemented a new kind of brain-machine interface where we are going to do that. So basically what we did was, okay, I am here in this kind of line that we have put over the ground. So you can see that there are some yellow line, red line. So the yellow line is the line when the person has to think about starting the gait. But as soon as the BMI detects that, the exoskeleton is automatically activated. So the person doesn't need to be all the time thinking about the motor imagery. But, as opposite, we need to stop the exoskeleton. And when the person reaches this kind of red line, the person needs to think about stopping the gait. So when if I want to stop the gait, I need to think about stopping the gait. So this was a different versus the previous paradigm that I have showed you before. So in order to do that, what we did is we implemented a different kind of machine learning technique. Now we implemented a deep learning model when we were collecting the data of all the users. I mean, in the previous one, we implemented, we calibrated with the specific data of each user, his specific or her specific model. Now we don't do that. What we do is, we are still doing 5 sessions, but now in the first session, we don't do anything related with the training, and we don't do anything related with the use of the lower limb exoskeleton. In this case, what we do is basically to explain the experiment to the user, okay, to get familiar with the devices, etc. But in session 2 and 3, we perform, the training. We try to calibrate the deep learning model. And for doing that, what we did is we perform 7 trials when the person is static and 7 trials when the person is in movement. When the person is in static, we have to do as we have done in the previous project. The person has to think about being relaxed, or the person has to think about moving his or her legs. And for the motion model, we have to do the same, but in this case, the exoskeleton is all the time moved. I mean, it's externally moved, not because the person is thinking about that. So after collecting all that signal, what we did is, in the last 2 sessions, we performed, again, 14 trials in order to get data for adjusting, the models. But in this case, we perform a fine-tuning of all the layers of the model per user and per session. And finally, what we did is, in session 4 and 5, we tested the system. I mean, after calibrating the system, we performed the experiment in closed loop. So let me show you one video of one of the experiments that we did. In this case, you can see here, this is our lab. You can see here that there are some marks. Maybe you can see better that there is a red mark here. here it is a green one. So it means that in the green one, the person has to think about starting the gate. So the person starts to think about that, and as soon as the VMI detects that, the person doesn't need to be thinking about that. The person is relaxed, and the exoskeleton is being moved. But when the person reaches the red line, the person needs to think about stopping the gate. Okay? So now the person is in charge of all the situation, because in the previous project, the person needed to hear some kind of instruction from the experimenter. Now, no. Now is an asynchronous paradigm when the person can control if he wants or she wants to start or to stop the gate. Anyway, here you can see the result of the decoder. In green, we are showing the accuracy for starting the gate. So in most cases, always the person is capable of starting the gate. But in red, you can see the accuracy for stopping the gate. Now, there is not possible always stopping the gate. But this is not the worst problem. The worst problem is shown in blue. That is the ratio of stops. This is the proportion of successful stops versus the number of total stops. So it means that in some cases, the exoskeleton is being stopped not because the person wants to stop the exoskeleton, but because the algorithm is not working well. So we needed to think about changing these VMIs in order to improve this accuracy. So what we did is to implement an additional brain-machine interface that is based on the error-related potential. What is this? The error-related potential is a potential that is produced on the brain when we realize that something is not working properly. Imagine, for instance, that you are wearing your EEG card with a lower limb exoskeleton, and you start to think about starting the gate. And you see that the exoskeleton is not being moved. So in that way, this kind of brain potential is produced on your brain. And we can put electrodes for detecting that. And if we detect that, we can change the output of the algorithm and say, no, I want to move the exoskeleton, so the exoskeleton starts. What is the problem? Imagine that now you don't want to start the exoskeleton, the movement of the exoskeleton, and suddenly the exoskeleton starts to move. The same kind of error potential can be produced, and you can detect that. But of course, the problem is that the exoskeleton has been already activated. So in order to avoid that problem, what we did is we introduced some kind of visual or some kind of interfaces that have to be activated before sending the command to the exoskeleton. In that case, we use a pair of glasses with some lights and some kind of vibrator, for the wrist. So basically, the idea was, okay, imagine that I'm working with the exoskeleton, and suddenly, the lights are activated and the vibrator are activated. It means that the VMI is on the verge of stopping the exoskeleton, but you don't want to do that. So in that case, the kind of error potential is produced, so you can send that command because you are performing a kind of self-tuning of the brain-machine interface. So we are correcting the output of the brain-machine interface thanks to detecting this kind of error-related potential. Well, let me show you one of the videos of one of the experiments that we did, in this case, in Institut Guttmann in Barcelona. Now we are using a different kind of robotic exoskeleton. In this case, it's a robot from Hokoma. It's actually working over a treadmill. So now the person needs to be thinking about, the gate and that, but the person cannot walk. So you can see here that there is a screen when the person can see the advance of the user during his or her walking. So I'm going to put the video. So basically now the person is moving, and we want to stop the gait of the person. So a red line is going to appear, and we are going to check that the person is not able to stop the exoskeleton. But this kind of error potential has been produced because the person has realized that something is not working properly, So we detect that and we send a command to the exoskeleton in order to stop the exoskeleton. That way, we can improve the accuracy of the system. Well, so let me say several things related with the experiment that we have done. First of all, we have verified that people with motor limitations can use brain-machine interfaces for interacting with robotics exoskeletons. I mean, we have done experiments with spinal cord injury people, with stroke people, and all of them are able to command the robots using their brain signal. And we think that this is going to be better for their rehabilitation because we are introducing this kind of top-down approach that is combined with the traditional rehabilitation approach, this kind of bottom-up approach. But, and this is very important, we need to perform more clinical trials in order to check the clinical relevance of this technology. Because maybe we are developing, a very fancy technology, but this is better or not than moving the legs of the person. We have to perform clinical trial in order to check if it is worth to use this technology or not. So that would be all. Let me thank you before ending to my lab, that they are actually doing the hard work, and here doing the easy work, that is to talk. So let me thank my team, and of course, all the sponsors of the research. Thank you. I don't know if we have time for questions.
No, you have time for questions, so if any of you have any questions, okay, perfect. No, tranquilo, don't worry.
Thank you, Miguel Juan. My question is, are there any similarities between the signals produced by one person and other person through the BMI to control the exoskeleton, or are they totally different? And if they are similar, is there the possibility to train the person to emit precisely the signals that are going to work?
The problem is that they are different, but they are different even for the specific user depending on the time when they do the experiment. So there is a lot of variability on the signal, and that's a big problem. Yeah.
And would that be solved changing the kind of signals that you are looking for, like or using a different type of sensors, like maybe intrusive sensors or something like that, so you can be more precise?
You could be more precise if you, for instance, you will use, invasive electrodes, because that way you can put the electrodes in some specific area related with motor cortex, and you can even be able to detect the activation of some group of neurons. But what we are checking now, that now with non-invasive technique, we can do things that maybe 20 years ago were only able to do people that was working with invasive technology. But of course, that would be easier for, detecting the signals and that.
Thank you.
Thank you.
Hi, so first of all, thank you very much, José María, for that interesting presentation in a so interesting topic. I wanted to ask, as far as I know, with EEG technology, it's possible to detect more than just one command. And my question is that one, why are you just getting the start or stop command when, for example, you could get like move left leg or move right leg command? Wouldn't that be more realistic? Thank you.
Yeah, thank you. Thank you. Well, it is very difficult to detect more than one command, but it depends on the application. I mean, here I have been talking about, imagination of the legs. The legs are represented, or the motor cortex, just in the middle of both hemispheres, so just in the inner part of the brain. So it means that when you are putting the electrodes over the cortex area, you are receiving, the signal with a very poor quality. But for instance, if you want to detect, if you are thinking about imagination of your right hand or your left hand, that's easier, because you have the representation over the top part of the motor cortex. So that's the main problem. Anyway, if you increase the number of classes that you want to detect, you are going to decrease the accuracy of the system. So in the end, you have to reach a trade-off between accuracy and number of classes.
Thank you.
Thank you.
Hello. Well, first of all, thank you very much for this speech. It was quite interesting. But I have a question. What is the possible scale and impact of this technology globally, like in different sectors?
I mean, of course, the clear impact is in rehabilitation of people with motor limitation. I mean, I have to say that there is an economic problem related with that. I don't know if your question is related with that, because, I mean, for instance, lower limb exoskeleton the cost of this kind of devices are around 100,000 euros. You have to add the equipment for, collecting the EEG signal in the end, you have to spend more or less about 120,000 euros per device, no? So that limits, the potential, expansion of the technology. But the important thing is not that, but, the strategy. Because now there are people that are producing very cheap EEG devices. Of course, you cannot collect 27 electrodes, but you can collect 8 electrodes. And for instance, you can use lower limb exoskeleton that are not gonna, allow you to walk, but maybe they are gonna allow you to move your ankle, for instance. So, and that's gonna be a lot much cheaper, I mean. So, of course, that is the more potential application of the technology, from my point of view, the clinical one.
Okay. So yeah, I was wondering whether it could be in different sectors apart from rehabilitation, like in sector of defense, for example, or in sector of companies that help people to move from house to house.
I mean, for instance, exoskeleton have been used, in the army in order to, to resist, more and that, and even, for instance, in factories, in factories of cars and that, they are using exoskeleton in order to help them, and specifically in order to avoid to get some kind of illness related with heavy things, no? But in that case, you don't need the brain-machine interface. I mean, it's only the technology related with the exoskeletons.
Okay, thank you very much.
Thank you.
Now let's go with our next keynote speaker. He is Hiroaki Kitano, a globally recognized AI pioneer, Chief Technology Fellow at Sony Group Corporation, and President and CEO of Sony Computer Science Laboratories. Throughout his distinguished career, he has shaped the fields of artificial intelligence, robotics, and systems biology, while leading visionary initiatives such as RoboCup and the Nobel Turing Challenge. In this keynote, Creating the Warp Drive for Scientific Discovery, he will share his perspective on how AI can become a new engine for scientific breakthroughs and redefine the future of research. Let's welcome Hiroaki Kitano.
Thank you very much for your kind introduction. And okay, thank you very much.
Welcome.
Yeah, yes. Well, I'm very happy to be back in Valencia. And I'm charged with the paella, which is great. Okay, so what I'm going to talk about today is a read update on my research topic and AI for scientific discovery. But before going into that, I think we need to review what is the current status in the AI, particularly in the AI in the physical real world. Because a scientific discovery, we're talking about the real world. We need to understand what's going on out there. So what is we're trying to achieve in the scientific discovery is we want to understand and to be able to control and a very large-scale complex adaptive symbiotic systems. Either it is like a cell or a whole human body or environmental or probably like a financial or urban architecture. It spans from the biological, all kind of system we are facing with. This is something we want to accomplish, not just to understand, but to be able to control it. Because when we want to cure disease, we need to be able to control the state of the body, which is malfunctioning, or you want to actually intervene to the urban environment to be able to fix the problem in the city. And almost 10 years ago, I proposed a Nobel Turing Challenge. That is a challenge by year 2050 to be able to build a highly autonomous AI agent to make a scientific discovery highly autonomously and continuously deliver the discovery at the level of that might worth a Nobel Prize or probably beyond. So this is one of the grand challenges I proposed 10 years ago. Of course, the other grand challenge is RoboCup. By 2050 to create a fully autonomous human-robot team to beat the World Cup champions. And RoboCup is going on as we speak now in Incheon, Korea right now. And then, that's robotics version. Of course, a human World Cup is going on as we speak now. And unfortunately, Japan is kicked out already. But anyways, I can concentrate on research now. The Nobel Turing Challenge is a challenge and the questions. Challenge is, can we build a machine like that? Can we build a machine to be able to make a major discovery, the worthy of Nobel Prize? And the question is, if we can build a machine, does the machine look like a human scientist, or are we does it going to show a very different kind of intelligence? And therefore, whether it will pass a Turing test will show something very different. And my bet is I think a machine is going to be very different from human. But anyway, we'll have to see. Now, if you look at the history of the AI has been a history of the grand challenge, from the computer chess to shogi or Go. And this kind of a game is like a complete information game and then a turn-taking. And this is like an amount of computing required to solve the problem and then all the space complexity. And even if you got a bigger problem than the Go, I think we know how to solve it. It's just a matter of how to get the data sampling, and then we got the how to get the computing power ready to solve the problem. But the challenge is if you got it the real world, autonomous vehicle or suckers or scientific discovery, that we have to face the messy reality of the physical real world, and that's actually challenging. Now, at the same time, there's a lot of interesting stuff going on last decades, starting from the beginning of the deep learning. For example, take a very few small example, this is the DeepMind and then EPFL has managed to get the high precision plasma control in the fusion reactor on this, that's in the EPFL campus. And this is a Nobel Prize winning work on the predicting 3D structure of the protein from the primary sequence. And this is really, groundbreaking. The interesting one is this Kikero, which is a meta AI. It is, superhuman, diplomacy player. Diplomacy, as you know, is like a diplomacy game in Europe. And then, the gamer need to persuade that you better be on your friend. So that means Kikero, this AI agent, is much more convincing than any other human players. Okay, so, well, this underlines some of the discussion we have, an agent can be more persuasive than human peers. And that's something going on right now. And then now I'd like to show you some of the research we did at the Sony AI. And then there are some of the recent papers from the Gran Turismo, and we have a very fair and then unbiased data set for the data set for face recognition, a human posture recognition. Also, the one we published a couple months ago is a superhuman athlete robotics for the table tennis. Let's start from this Gran Turismo. I want to focus on the Gran Turismo and the table tennis from the very beginning of my talk. We have Gran Turismo is a PlayStation game, and it's extremely realistic driving simulations. So to be able to outperform the best human player in the world could actually potentially be the best also in the physical real world. Although this is a game, but Gran Turismo is extremely good driving simulator. And then what happened is we trained the AI. This is basically deep reinforcement running. And then all the scenario-based training to be able to outperform the best human driver in Gran Turismo game. And of course, there's a esports championship, and then we got the one of the 5 of the top athletes, and then to be able to play against the AI agents. So this is a car in the white, that's driven by the human being, and then with the color like a green or purple, and that's AI agent. So now you can see this onboard camera. That's, we call this Sophie bed. This is like a green one. It's like an AI agent, and to be able to overtake and then win this championship game. Now you can see Sophie's this AI agent making tactical decision right now. They're actually going after this car, and then whether this car will overtake human driving car on the corner. Now it's going inside here. So they can not just driving faster, they have to make a decisions to when to overtake, when not to overtake, and they make all the tactical decisions. Now, once AI cars overtake a human driver cars, they are very fast, actually. For per lap, I think it usually 2 seconds faster than the best human drivers. And after we accomplish this superhuman capabilities, we put this AI agent actually online to be able to be played by the gamers around the world. Obviously, no one beat the AI agent. And that doesn't make a very good game because people come to play the game and get humiliated. So what we decided to do is to put more capability, additional capability for the agent to be able to adapt to the gamer's capability. So the gamer can enjoy very realistic game, against the human players. Now, if we are playing, PlayStation 5, GT Gran Turismo, most of the non-human car is based on this AI agent. So this is one of the most widely used agentic AI in a gaming world, probably even beyond the gaming world. Now, if you look at this a trajectory of the log, we can see why human is not much against AI agents. So if you look at this steering and then also throttle brake, and the blue one or the black one is the human driving log, and then the orange one is the AI agent. So AI agent can actually adjust a throttle and then steering in the millisecond order, and human cannot do that. So AI can completely outperform the human capability in the precision and speed. And obviously, once you tune that well, it can't really, human cannot really match. We took it further, not just conventional racing circuit, to the drifting game. So drifting is you have to control the sliding mode, right? It's very difficult. If human players do the drifting in the circuit, you have to be lucky to be able to come out the corner in in an intended way. So this is, although this is simulation, the very realistic, this is an AI agent controlling how to do the drifting and plan the trajectory and to be able to control the car to be able to go, as it planned a priori. So it's really difficult, you can see, and you don't want to try yourself. I mean, that's going to be really risky. But the AI agent can really reliably repeat this drifting mode. Okay. So this is a state of the art in controlling the vehicle. Now, then people ask questions can you actually do it in a real physical car? That's very expensive, actually. It's we decide to go for a little bit more affordable challenge to be able to beat best human athlete in a real sports, and we pick a table tennis. And the reason why we take table tennis, we can do it in-house, inside, not outside the field. So we can do it outside. It's just a matter of the budget, okay? We got a very realistic, physical realistic constraint in a different sense. But we decided to pick up table tennis, and also you want to be able to compete against the best player in the world. So we decided to do this in Japan and in Zurich. And the Japanese table tennis player is one of the best. We are competing against China. Sometimes we beat Chinese players. Sometimes we lost. So China is slightly in the edge, but a Japanese player is in the top tier. So therefore, we will be able to play against the best human athlete if we do it in Japan. So we decided to go for this, and then we created an entire robotic system and AI to be able to beat against play against the best human player. Okay. So there are a few, I think it's the videos should be coming. Yeah. So we got a setup here in Tokyo and Zurich, and that is a kind of robot. Unfortunately, it's not humanoid yet, but now she's one of the top players. This is like this elite, but she's actually probably one of the top 10 in the Japanese table tennis league. So last month, this system actually beat the two-time silver medalist Olympic Games, Miyu Hirano, and then with like 11-6, 11-5, and the second game was 11-6 and 11-4. So this system actually beats like potentially the top-tier Olympic medalist scale athlete in a big margin, and that is the current state. Now, let me show you so what's behind this. Okay. So this is actually like a very slow-moving one. Okay, now you have like all the trajectory. That's like a prediction trajectory. Now you look at this like a prediction trajectory going on. Now it's a touch the net. So like all the prediction is not touch the net, but like at the reality it touch the net. So like you change the course, like you capture that change right away and do the simulation. What is the new course, and then readjust it like the robot motions in a sub-millisecond. And otherwise, you can't really go against this kind of player, right? So that is something we did. So there have to be always real-time prediction, vision recognitions, and then tracing of the ball, and then simulations, so the trajectory could be, and then always checking with the reality and trajectory. And if that diverged, then recalibrate the entire simulation and make different tactical decisions, and then move the robot. You know, everything has to go in a millisecond order. Otherwise, you cannot compete against it. And then we had like a very special vision system created by the Sony Semiconductor Solution, which is events-based sensor. It's like, okay, this is the image that we got. So, you know, you're tracking the ball, and you can really see the rotations. It says like this is like a 200 radius per second, and the speed, 4 meters per second, and you can see the axis, and then you can see the trajectory. Right? So you can, you know, on the real time, you can predict, and then how it bounces back, and then you can see the aerodynamics and everything. So you need this kind of like a sensor to be able to compete against the best human player in a table tennis. So this is like a events-based sensor. It's not like a frame ratio, but like basically this sensor is equivalent to 1 kHz frame ratio or above. So extremely fast sensor to be able to detect what's going on. And then, okay, so those are the things like we did, and then you know, then the whole thing have to go in a millisecond order, so that the engineering is really key. It's like a reason why we accomplish this is not just AI. We have that, you know, really deep engineering capability to be able to, you know, have like a sensor, very special sensor, and then if you try to move the camera, you can't really track that because the camera is heavy. So what we have to do is like a multiple camera. And I get the stereo to actually be able to, a multiple stereo to be able to capture dips, and then we put the mirror in front of the camera to be able to move very quickly. So we have to have our engineer to have the extremely precise and fast-moving mirror gimbals to be able to track the ball and keep it tracing with that speed. And then all the internet connection has to be on very low latency. And also the physical realistic simulation as well. And the robot, if you got the robot arm, if your arm is heavy, you can't really cope with the change. If you have put a net and you got a trajectory change, you can't really cope with that. So we actually decided to redesign an entire robotics arm with the carbon composite and a very lightweight, but still the very strong arm. And then we did it completely on the 3D printers and then the autoclaving. And that kind of like end-to-end engineering has been really the key. So we all talk about physical AI now and talking about like focusing on AI and computing capability, how much of the GPU you have. But at the end of the day, you have to have a good engineering integration capability to be able to do high-quality physical AI. I think this is like a down-to-earth reality, and how, if we are going to the physical AI. Now, scientific discovery go further beyond. Like we talk about this, like Gran Turismo. We talk about table tennis. That's a sport, so it's a defined, search space. It's a physical realistic, very fast-moving, but like it's really defined. Now, the scientific discovery is completely open-ended, so it's not defined at all. And to me, scientific discovery today is like a pre-industrial era. If you're in biology, you can do like a genome sequencer, like mass spec, you get a lot of data. But at the same time, like after you get the data, we have to really think what this data means, and we have to really do the analysis by ourselves and everything, you know. And that part is not really changing. And I want to change that. Now, this is like one of my early study in biology about like aging study. So like I started in 1994, and we got 4 years to come up with like a theory and experimental verification of the theory or the very first cut. And we published a paper in 1998. And then we continued to experiment with like a mouse model and everything. And then some of the hypotheses has been verified now in the 2000. And then we got the first clinical trial in 2016, so that's 10 years ago, and still going. And this is like a time scale in the biology. It's pretty long, actually. So like, can we actually change this? Can we actually make it shorter? Instead of taking like 2 decades, 3 decades, can we actually change the entire process to be done in 2 years or 3 years or maybe 5 years? So okay, which part we can, speed up? We can speed up in the hypothesis generation. We can make like hypothesis much more accurate. Or we can have like experiment that move faster. So like every aspect of the scientific challenge, particularly in biomedical science or material science, they are like a bottlenecks, and I want to solve that. Now, at the same time, the reality is we may not be good in science. In biomedical fields, over 2 million papers get published every year. Okay, if you are in a area like oncology or neuroscience, immunology, hundreds of papers per day, and you can't read it. And we think like we know something, but like we are actually navigating in darkness. We don't, we are actually looking at a very small fraction of what has been discovered, what's been discovered every day, and that's how we operate. So that's actually we are trying to discover based on knowledge we know, but it's a fraction of knowledge. And that's it's a human cognitive capability, actually. At the same time, like this system is awfully complicated. This is like a diagram of the yeast cell cycle. This is like a very small yeast cell, which actually used for the wine brewery. And it's a very small fraction of the cellular functions. We actually did how the molecules interact with each other. And we read like 1,500 papers and go into the details and create a very detailed and very accurate map. But we cannot continue this. Human continue to work on this. It's not possible. It's psychological not possible. It's a really psychological burden, and there's no career opportunity after doing this. Like what kind of job you can get, it's very minimum. It's also like funding-wise, very difficult to get funded. But you have to do this. You have to really get like a whole picture of what's going on. And previously, we didn't have any way to actually automate this. This has been a highly labor-intensive process creating a molecular interaction database. There's like an EcoPsych and then all kind of database there, but it was really done by human. And now, with a large language model doing properly, we can automate most of the process. Not entirely. We need to double-check, and then there are errors associated, but we should be able to automate like pretty much like a quite substantial part of this process now. Now, the other thing which is interesting, there are 40,000 human genes in a human genome, coding and non-coding altogether. And I picked like hundreds of them randomly and I count the number of papers published. And this is a statistics, and this is very consistent with like much larger study. So 96.8% publication on top 10 genes. Okay, this part of the gene, there's no paper. Okay, so that guy actually a few years back did like a very comprehensive study in 40,000 genes, and surprisingly, 60,000 of them have no paper. Another 7,000 has only one paper. They get the same distributions. 96% of the paper is on top 10% of the genes. And why? Because scientists want to be successful. Science wants to be able to contribute. Therefore, scientists focus on the gene that is considered to be important or probably likely to be important, rather than randomly pick the genes on the tail end of the distribution. Now the question is, what am I going to do with that? So if you have like a postdoc and or students saying randomly pick those 5 genes, and then okay, this is your thesis, and then if you are lucky, you're going to be the star. Otherwise, I'm sorry for that. Yeah, of course, your student will shout like, "Oh, what happened with my life?" So it's very difficult for the human to be able to randomly pick those genes and to be able to bet on the carrier. Of course not. But the question is, are those genes important or not? And this is one example of the genes, which is TREM2 genes, which is considered to be extremely important neuroinflammation, neurodegenerative disease. 2000, there's no paper. And there's a small number of papers published, first 10 years has only 4 or 5 papers per year. All of a sudden, it turns out this is going to be extremely important neuroinflammation, neurodegenerative disease. Now, every year, over 20,000 papers are published. Now, there must be many other genes like this we just haven't discovered. But at the same time, even if you get, start working on one of those very important genes, which is completely ignored right now, but you probably have to endure this for 10 years. There's a very small attention that's been paid, and there's some key moment to shed light on important specific topics. How am I going to do with this? It's very difficult for the human. Was a limited career, opportunity. You can't really be in a dormant for a decade if you want to be successful in the scientific career. You want to be a success much earlier in stage, but this is the reality. So the solutions is we're going to do in AI and robotics. Now, and this kind of distribution is not just in the biology, but if you look at all the real world, if you got the frequency of event or probably importance event and the rank distributions, in a controlled environment like factories, this tail is cartel, so you can control. But in the real world, this tail is long. And even if the long tail, if accumulation of the tail side go up to 30 to 40%, or sometimes 60% of the entire event. So you cannot ignore a tail, but the same tail is a tail. Event is very rare. So you're gonna actually hit something very important in that tail end is slip. But a tail is extremely long, and how you do with the tail is really the issue in AI. Now, if you look at this is a training curve in GT-SOPHY AlphaGo. GT-SOPHY, 2,000 cycle is enough to actually beat most of the player. But to beat a world championship level, we need a 10,000 cycle. So this is 80% of the cycle computing time was spent to improve last 5% or last 3%. To beat most of the people, to beat the human champion. That's actually a 3 to 5% improvement, but then you need 5 times more computing power. The same in AlphaGo. To be able to beat most of the human players is 4 days, but to be able to beat a world champion class is 40 days. And this tail side is where the resources need to be spent, and that's really the differentiator to be a good enough AI to be the super performance AI. And this is the fundamental issue. It's not just a design, it's a fundamental law of this nature of the complex system because they are tail side. You gotta take care of the tail, otherwise performance don't increase. But to get a tail, and you have to spend computing power. And you have to keep collecting the data, and this is the fundamental. Now, go back to the science, and then science, same thing. It's we're going to have the tail side of the science, which is actually grossly ignored, but you have to be lucky to be able to hit the tail. And then high-precision simulation, AI, and automated experiments are things that you need to be able to speed up entire scientific discovery process. And then I look at some of the Nobel quality discovery, in case this is the iPS cell by Shinya Yamanaka. So it's very interesting. He initially studied iPS is this is a cell taking the body, and you got the regenerative medicine, stem cell, creating a stem cell in the form of the somatic cell, and to be able to differentiate any of the cell you want. Okay, this is a groundbreaking discovery, won a Nobel Prize in I don't know which 2012. Okay, initially interesting. He has been working not on the regenerative medicine or stem cell. He has worked in the cholesterol. He actually studied how to reduce the cholesterol in Gladstone Institute in San Francisco, and then found ApoBec1 is thing that you want to edit, and then you have a messenger RNA editing, and then after overexpression ApoBec1, and he see the mouse who has a reduced cholesterol, very successful. At the same time, every mouse who got the overexpression ApoBec1 has a liver cancer. And then he found out there must be some collateral target which is undesired, and he found out NAT1 is actually the collateral target, and he found out NAT1 is not just like causing cancer, but like a reason for causing cancer is actually change the cell fate dramatically. So like, he came up with the idea there must be other genes, not just NAT1, to be able to control the fate of the cell, which could to be able to reprogram the cell fate. And then he actually decided to search for the other genes of the similar property, where he says the ECAT, ESO-associated transcript, and he found 24 genes can be a candidate, and then put everything on a cell, and then he managed to reprogram the cell. This is a big discovery. And then he further optimized the liver experiment to identify what are the minimum genes that require to reprogram the cell, and come to the 4 genes, which is now known as the Yamanaka factors. So this is more the exploration space, which is like a really connecting a dot in the very far apart, starting with the cholesterol, nothing to do with the original damage of stem cell, but actually he found out, completely by accident, found out there's something related to the stem cell, and then this is like optimization process. So like optimization, I think like we can reasonably understand that, robotics and AI could be good at it. It's like how actually go to the exploration space is very challenging, which should be very interesting. Now, CRISPR-Cas9, Jennifer Dowden and Maria Sharpanti, and then they've been working, there's a long history of like how the, the microbial can defend from the virus invasions. And there's like some precursor research by like Ishino, and then, there's no one looked at this for 18 years. It was completely dormant. And then in 2005, there's something interesting happening, and then there's people start paying attention to this, and then found out this is going to be the gene editing capability. And then after that, identify what is the most efficient bioengineering to be able to cut in precisions and to be able to be efficient. So this is like optimization process. So it's a very, very long exploration stage, and then a very quick and a massive investment on the optimization stage. So it seems like, I wouldn't say like every discovery is like this, but like many discovery seems to have the path of exploration and search and optimization. If this is like a, specific templates of the major discoveries, maybe we should be able to replicate the process in AI and robotics. It's a long way to go, but at the same time, if we do it in AI and robotics, we should be able to make a larger search space to be able to find the multiple different paths to achieve the final answer. So it's very interesting. Also, like, with structural biological discovery, basically you won't be able to identify the molecules and their interactions in a very necessary structure on the specific biological process. Either it's a fundamental process or a disease or it's a cure. So like, we have like a specific kind of like a template that we want to discover. Now, then we want to automate it. Why we want to automate it? Like, particularly for the experiment, is we want to be able to have a superhuman precision experiment and a long tail coverage. This is something we're talking about. It's very difficult for us to randomly pick the research subjects and go for it. You want to be able to pick something you think is going to be successful, right? But our capability to predict what could be the success is very lousy. Like, if you're like by 2000, if someone asks you what is your specialty, what you're working on, if you answer like artificial intelligence, people think, oh, I'm sorry, I asked that question, right? But now AI is like a king, but like, if you remember 2000s, like, if you are old time, I think that was like a winter time in AI, and people didn't want to talk about that at that time. So like, also very interesting thing will happen is the cost of discovery going to be reduced significantly if we go by AI. I think this is going to be a big change in the future, how we're going to, all the corporate decisions and the scientific decisions as well, but I'm not going to talk about that. Okay, then how to automate it. Now, I think we need to go for like a massive search and verification hypothesis space. That's really the key. And then how we go about this is like we have to have like a cycle of the scientific discovery, and you go everything in a massive scale. So we need to be able to have like a massive knowledge extraction and consolidation from all the data and the publications, accumulated. Some of them noisy, some of them fabricated, but still like our fabrications, our imagination is very limited. Fabrication can be the noise, and then you have probably consistent with what's ground truth slides. But anyway, so like a massive knowledge extraction consolidations, And then a massive hypothesis generations, massive experiments, and a massive verification and falsifications. Okay, so this is already challenging, but at the same time, like how many hypotheses we're going to generate in scientific discovery process? We usually come up with like a 1 or 2, probably 3. We usually don't come up with like a 50 or 100 hypotheses or thousands of hypotheses. But if you want to go for like a specific important area, you want to be able to populate the hypothesis, the entire hypothesis. You want to populate the hypothesis, so that you are not missing anything. So you want to verify every possible hypothesis in a specific problem space. And we cannot do this. We are not good at that. So can we actually create an AI system to be able to populate, entire hypothesis problem space with thousands of hypotheses that worth verifying it? We have to prioritize it because we have a resource limitation. And to be able to experiment and verify all those possible hypotheses. Now, another bottleneck is experiments. Our experimental procedure, biomedical science or material science, is designed to verify small number of hypotheses. 1 hypothesis, 2 hypotheses, maybe 3. But usually our experimental setup is not designed to verify hundreds of hypotheses or thousands of them. So we really have to change the entire scientific process. So what I'm saying is we're going to have a trillion of data, billions of hypotheses, millions of experiments, and thousands of discoveries. And we need this run automatic. And then we have to discover, we have to really interpret what has been discovered, what does that mean to us. So automation science has been done. It has like a reasonable history. For example, like Ross King in the Chalmers right now, when he was in the University of Manchester, he created like Adam and Eve system. This is the very first no human in the loop system. Generated specific hypothesis of each genetics and the experimental system, automated experiment to be able to verify the hypothesis. So this is a very specifically designed one. So like, generates the only one kind of hypothesis and do only one kind of experiment to verify that specific hypothesis. So it's a very special purpose machine, but still, this is one of the very first no human in the loop system. Now, in the Carnegie Mellon University, they have like ambition to have like a cloud lab, like a very large scale, like a gymnasium scale lab populated by the experimental devices. They want us to automate like entire process. Now, right now, when I visited like this 3 years ago, there's no robotics yet, it's a human there, and I got the iPad and then just doing experiments as instructed. So it's just like Amazon Fulfillment Center, that's small. But like the ambition is populate this lab entirely by robotics, so no human in the loop, and then the people actually, ask the experiments and do it automatic, and then the entire process is going to be automated. So like, CMU is investing a lot in AI for science right now. Now, my project down in island of Okinawa is like automating the metagenome processing, and that's the very first because I picked that because this is one of the most complex systems regarding human body because the microbiome in our body, like a gut, skin, oral, our environment interaction is millions, a lot, and it's a long tail. So it's not practical for the human to go after like an entire microbiome where we are related. And also like a human omics is so variable, human variability is massive, and the lifestyle is affected. So one of the research we did is like trying to see like an impact of microbiome on the vaccinations. So this is early days in the corona outbreak, and then we get the Pfizer vaccine, and then we actually took a sample of the blood and then vaccinations and then how the immune developed. And then together with like a gut microbiome as well. And we found that like 1% of populations, even after vaccination, don't develop sufficient immunity. T-cell cross-reactivity is low and the antibodies not developed well. And we found out very specific like a microbiome composition, gut microbiome composition is actually preventing to build up like immunity even after vaccinations. Those people are actually healthy individuals, not like an immunocompromised individual. So they think they are okay, but because of a specific gut microbiome composition, they have less immunity even after vaccination. So this is very interesting, and this kind of thing has been observed in multiple cases, but this is one of the first studies identified why there are very specific group of people who don't develop immunity even after vaccinations. So the microbiome affecting a lot in immunity and the mental state and everything that we know. And the other thing which I find interesting, this is like this Chinese traditional medicine study which we did. It's all the herbal medicine, the combination of 4 herbs, and it's the Maoto, which is the name of drug, considered to work very efficiently against influenza and then other infectious disease. And we identified 352 chemical compound in egg extract. And then we give it to the mouse and the rat, and I measure the plasma, what's in there. Surprisingly, out of 352, only 22 has been identified in the blood, and then there's many unidentified ones, and there's an endogenous one which is elevated by the stimulation of all the active compound in the herbal medicines. So this applies not just herbal medicine, everything we eat. All the food, like we measure by mass and extract and identify those are the ingredients, but what we actually eat and then transformed by the microbiome and put in the bloodstream, that's very different. Basically, we don't know much. And this is extremely interesting, but combination is massive, and we can't really do it by hand. So, and then also, obviously, it's long tail, and I'm not going into too much detail, but there are all kind of interesting things going on in this area. And of course, we know why those affect the immunity and other things as well. So, in order to solve the problem at the massive scale, we decided to automate for example, a very first one, the metagenome process. And this is a subway chart, is every single step on the metagenome processing, experiments, and then identify that, optimize that, and put that into robotics. And this is our system called the MANTA system. And this is like a multiple liquid hand dryer, and also like a robotics arm, 3 arms are moving around, and the reconfigure robotic system. No human in the loop. And if you put one sample on the one end, everything taken care, and then put that into a sequencer, and then the result will be directly going into the GPU cluster as well. So this is like a multiple, so this is like one box, and then that generates like a massive data in a very stable quality. And with one of such systems, it's equivalent to 20, 30 lab technicians, and it's run 24/7. So what people say is like a little bit of GPU clusters for the biomedical use and other use, and the GPU cluster are going to be data hungry in the future. So we need very large number of those experimental boxes to feed GPU data. And that's actually what we are building right now. We are building right now the metagenome processing, and then we are working on the metabolome, and then we have like other omics, and then we have a lot of requests from the biologists to work on the IPS, CRISPR-Cas screening, and everything. So our ambition is automate the entire biological experiments in the robotics at the precisions, controlled by the AI, and get the data into the GPU cluster in a streamline. That's something we are trying to do. And then, so we're going to create like a world model, so like not just genomics, metagenome, metabolome, and the virome, and everything. And then that's actually more the experimental side. Then that have to connect to the human side, the human physiology. And then we're actually working with the PhenoAI, which is the company working on the project called the Human Phenotyping Project. It's a very large scale and precision measurement of the human physiology. Working with the hospital to be able to have a very specific measurement of the medical checkup, and also like a metabolome and a microbiome, like a genomics and everything. And then we are working on we already have like 100,000 participants actually, and then targeting over 25 years. We try to trace down like every individual for 25 years, and every data is privately held with the consent, so we're able to have a flexibility to the data use. And that's something we are trying to achieve. And then, so one side, we have automated lab experiment for the sample, and then also like experiments at the cell level, and then a stem cell, and then all that, and with the organoid as well. Like that's another thing we are working on. And then the other end is like a human phenotyping, like almost real human data at the large scale across the boundary. And we want to be able to connect it. So like, we want to the multi-omics world model. That's something that we're trying to achieve. The data going to be massive, and we have traced over 25 years or more, and distribution worldwide. That means we need to be able to set up a system to be able to have a stable experimental outcome anywhere in the world. So like one of the variability is the human technicians introducing a variability as well, or like a lab setup or the subtle environment. So you want to be able to standardize those conditions. So like a very first thing we did is like automate like experimental process, and meta-genome is the very, very first one actually. And then, so what we're trying to achieve is to accelerate the discovery, to be able to streamline data generations, and then the modeling and the predictions, the entire scientific process as well. So AI scientists were going to really change the way we do science. And when we talk about this, one of the very typical questions is in science, asking right questions is important. How AI can ask right questions. Well, I want to flip that questions. AI scientists will ask every question, and the important answer may be there to be discussed. So not just like asking one question, which we consider is important, ask every question, and use the capability of the massive, experimental capability, data generation capability, to be able to ask many questions as possible, and the important answer are going to be there. Of course, asking right questions is not going to completely fade away, because even AI has resource limitations. So we have to really get the better questions, but it's asking right questions stems from the reality that the active, period as a scientist, is about 30 years. And you have like a limited lab resource, limited like a budget. So you have to ask the right question to be successful. AI, we're going to change this. You can ask every question, so you're going to have like a scalable experiment system, and with the proper, accelerated discoveries, we should be able to expect some more investment. At the end of the day, one of the things we need to worry about is like when someone gets like a successful AI scientist, we're going to see the monopolization of discovery. And that's actually something people worry about it. And that's why every government is pouring the money into the AI for science right now. United States will launch a Genesis mission, which is like a DOE project, Argonne National and Oak Ridge National. And then this is like a big US project. And Japan is pouring money, quite substantial, unprecedented amount of money into the AI for science right now. And the EU is working on that. Singapore has a Singapore project as well. So like this is one of the hottest AI area in AI, and then biomedical science, material science, and other science as well. So then the question is, can machine discover? So I have a fortunate to actually be like a Bletchley Park on next Monday. Alan Turing put a question, can machine think? Like I would like to ask, can machine discover? What does discovery means? I think there's like three classes of discovery that we can make. One is a piece of knowledge, like this molecule interacts with this, like this material has a specific property. Can we discover that? Okay, very specific factual knowledge. That's something like class 1 discovery. Class 2 discovery, maybe like a cell cycle concept, or like Cooper pair in superconductivity. Something like a very systematic, but like it's local, specific phenomena to be able to not just like a piece of fact, but actually you change the way you look at things. You can explain why this phenomena exists. And then class 3 is completely new way of looking at things, like a quantum physics, or relativity, or gauge theory. Those are harder for AI at this moment, frankly speaking. But for this one, class 1, I think AI had an advantage. I think we should really go for this is low-hanging fruits. It's not really low. It's tough, but still feasible. We can, create a milestone to be able to achieve this. Now the challenge is out from there. Can we actually get some of the conceptual explanation of the phenomena we don't understand to be able to explain, we got it, we understand things. Okay, this is really challenging, we're more conceptual. And this is like really the game changer. That's a little bit far at this moment. I hope to be able to get this far. But if we go to class 5 discoveries, we can go after the class 1, because class 1 is something we are not good at, because we can't really do all the exhaustive research, and then, without risking your career aspirations. So class 1, a massive class 1 success might really change the way we do things in, the science. Now, of course, if you're going to class 2 and class 3, it means a new semantic dimension needs to be discovered. That's actually harder, and we don't know how to do that. Now, but I think there's a future in AI for scientific discovery, and then that will really change the way we do science, probably with the way we proceed the civilization, because our civilization is based on scientific discovery and technology to make it into reality and innovation to put it into society. And if we can really accept the scientific discovery in a massive scale, I think we're going to really see the very different future of our civilizations. And I think, my thesis is over the next 20 years, things are going to change dramatically, and then I think AI will going to really see the change affecting our course of the future civilization. Well, thank you very much. I don't know how to do it.
Now, do you have any questions?
Oh, the questions, yes.
Yes. Questions time.
Yes, that's right. I thought we were going to go into the panel.
Yes.
So my question, you say that the cost per discovery will go down.
Yeah.
It sounds like the cost per discovery actually might go up because of all the robotics and all the handling and everything. But the time to discovery would go down a lot.
For sure, yeah. So I think it's a trade-off. Like initially, you have to have a lot of capex. It's like a more expensive discovery. As it can more rationalized, more commoditized, I think the cost of discovery eventually go down dramatically. Actually,
one of the things we've seen in the past is discoveries lead to the design of new equipment.
Yeah. Exactly.
One of my favorite things is like the discovery of the restriction enzyme. From the time it was discovered to the time you could buy it as a kit and use it to new discoveries was only a year or so. Right? I mean, just unbelievable recycling. So maybe the capex will continue to go up because you'll decide you want to completely replace all the liquid handlers with something else.
So that we really have to do all the calculations, how things are going to change. Okay.
Hi, I have a simple question. It's, have you ever make a machine compete with another machine? Because earlier you showed us like a machine compete with a girl.
Oh yeah.
But have you ever had like a machine versus machine? And
machine versus machine?
Yes.
In a table tennis?
In a game, yeah.
In a game. Okay, so the Gran Turismo we did, actually. It's like, two AI drivers. So we actually initially tried a self-play, like AlphaGo, Google did self-play, right? So like in Gran Turismo, we tried a self-play. Didn't work very well because they get too aggressive. They really get aggressive and they get keep violating all the sportsmanship rules of the game. So we decided to go for the scenario processing, and then they start having very peculiar conditions, which we don't really happen with against the human players. So I think the self-play works in a specific environment where this rule is very rigid, and any of the move is within the kind of okay framework, So in a racing game, some move is violating a sportsmanship rule, and then that's kind of more soft rule, and I tend to actually go, violating. Also, if you push too hard, if you push harder, you take advantage. So there's a tendency in a self-play to get more aggressive because you can take advantage. But in a game of Go, you don't have that. You can't really go aggressive. You just put stones, right? So a self-play works in that environment. But a self-play doesn't work if you can really take advantage of aggressiveness. But it's go beyond, and so it's tend to be too aggressive in a self-play.
So it doesn't work because two machines have the same logic and they took the same decisions. So
it's not same decision, but they are drifting to the direction that is actually not, that is actually probably that actually is prohibited by different kind of rule actually. if they can be completely aggressive, you can just go self-play, and both player can be extremely aggressive, still okay. Then a self-play may work. But it's not just like performance, but also like a sportsmanship that was actually in a game. And then self-play actually keep violating sportsmanship rule.
Okay, thank you.
Yeah, we can actually try to incorporate the sportsmanship within the self-play, but then but like that one is soft rule. It's like harder to actually code actually.
Thank you so much.
And also table tennis actually is having two robotics like that is too expensive. So.
Hello. Well, first of all, thank you for your speech. It was very interesting, but I have a question. How AI development will change the robotics industry, for example, in medicine?
Well, medicine, I think there's a lot going on, particularly in the pharma industry, try to automate the lab. That's like a big thing in the biomedical pharma company right now. It's something we actually talk about this, like, many of the pharma is extremely interested in finding the new drugs and new medical entities. For example, like Demis Hassabis isomorphic grab is specifically targeting that direction, so identify to create like a new molecule that will actually work on a specific target. And that part can be more the combinatorial, and then if you got like an AI to be able to identify the possible like a 3D structure, and then the binding pocket, and then you got the computing at the more network level, and it should be able to solve the problem, or probably at least you can make it more efficient. But at the same time, I've been working with the pharma for over like 20 years using AI and simulations, and then the difficulty is like you think like work like those like biological systems like touching completely unexpected places, and unless you have like a data on that, you miss that. And sometimes that have like an effect. Sometimes that's actually cause toxic, some side effect. So like many pharma companies come to me and say, this is the molecule, this is the target. But actually, there are two interesting cases. One is there's the completely unexpected place touching things which is lethal. And like they have a serious side effect, so that's really hard, But then that the drug has to be killed. You can't really proceed with that. The other case we find interesting, pharma company think this is the target, this molecule is touching, but actually the real effects come from somewhere else, which pharma company haven't thought about, but actually this molecule is touching it, and that is the real cause of the effect. Those things there, like we are not really good at that. We're actually focusing on this, and we have like preoccupied concept, like this must be touching this, and therefore, and it makes sense because it's that link is there. But there are other links which is also effective. Other link could be much more stronger, but like I tend to, ignore that. So that kind of thing, if you can compute, we can really solve the problem much faster. At the same time, can we actually create the data, like the entire data of the molecule that the chemical compound might touch? You have to be really ready to be looking to all the tail side of the distributions. So like if you design the AI system, robotic system, to be able to focus on high priority thing, you might miss the tail, and then you repeat the same mistake as we do today. So you're focusing on something very specific, which is visible, ignoring like a long tail part, which could be, could be like a turn the table around. And so that's actually, it's like a harder part is the clinical study. Clinical study, you have to do with the humans, and not much, AI cannot speed up. But the key is, can you actually speed up, can you improve the accuracy or like efficacy, and also like eliminate the side effects so that your compound and the cohort selection can be improved. Then although the clinical study costs do not change, the failure rate can be reduced dramatically. It's like many experience with the pharma companies, they have a relatively loose cohort selections. You have to select like what kind of patient you want to enroll in a clinical study very precisely. Otherwise, you enrolled many patients which it doesn't work. Then you dilute the efficacy, and it doesn't really reach the clinical endpoint. If you use the AI to be able to identify what kind of individual patient need to be in a clinical study, and therefore drug need to be approved in a specific cohort, then many drugs which failed could have been saved, actually.
Wow, thank you very much.
Well, my question is, how do you think job and opportunities for younger people is going to be in the future, like in the next 20 years?
Your question is how this AI impacts like general people in next 20 years?
Yeah, like for the jobs.
Jobs. Okay. So this is like a very interesting thing. Okay. When I actually attended like a AI Action Summit in Paris last year, the biggest issue in the panel for like all the EU ministers has been like job opportunities. AI going to take up like job opportunities, therefore there will be more unemployment problem. The reality is like in next like 10 years, 5 to 10 years, 95% capability for 9% of people will be, outperformed by AI. I think that will happen. So that the question is, what is the human value, and now where's actually what kind of job we want to have? Like at the same time, AI is expensive. To be able to perform the AI with that level, you have generated a lot of tokens. Then, actually, like human might continue to have a job opportunity because the human's cheaper. So this is really tricky, but biggest problem in AI introduction is the human labor cost is actually tend to be cheaper than the AI computing cost. So that's really, I kind of hate to say it's like a human chip is really, looks like I'm a bad guy. It's like I don't want to say that, but the reality is people talking about it is token economics actually is more expensive than people expected. They rather hire people because AI is getting too expensive.
Because we are doing it all wrong.
Yeah.
It's unacceptable to say that.
Yeah.
And AI is more expensive because we are doing it all wrong. Because we are not taking the proper approach. We are building systems. We are pretending that we can create intelligence by the same way that our brains would sync with our eyes. Our eyes are not the way to sync.
Yeah, I think AI functions very differently from the humans.
We are building it wrong, and then we complain that it's too expensive.
Yeah, fine. So if that's actually collected, the AI got to be cheaper. Then the problem is what the humans do. Yeah.
That is not the way to go. AI, we are building AI all wrong, making it extremely expensive.
Yeah.
And now we say, you can use people because they are more cheaper. That's really unacceptable.
I know.
In all ways, it's unacceptable.
Yeah.
And we need to start working on AI in the right way, making AI work as it should, and not just...
Well, what do you mean by how the AI should do?
I mean, AI, what we are doing is confusing fluency with understanding, confusing prediction with understanding of the world, trying to recreate the physical laws by total prediction, and it's the same as we would say that our brains work
I think like
it's not the same.
No, it's different. It's different.
Putting constraints, putting limits, and why we don't do that? We are just generating this huge slope and just then complaining that it's too expensive to maintain this slope.
Yeah, so I think like AI tends to be expensive. I think if it can be cheaper, I think that would be revolutionary. That would be good. That would be good.
I mean, can be much better.
Yeah, okay. Then that poses a problem. Like there's a much less job opportunity for the humans because they are going to be cheaper.
Thank you. Congratulations, Mr. Kitano, for your talk. Okay, here we are at a university, so we are talking about discovery, scientific discovery. Which kind of new competencies and skills should we, as university, take care of? How to prepare people for this?
Okay, so I think the really key, which I'm talking all the time, is epistemic diversity. We need to be able to identify the problems that need to be solved and for whom, and that's for probably for rare cases or long tail part, but accumulation long tail part is a significant part of society. For example, one of the questions is for example, if you have elevators, 5 elevators and 6 elevators in the hall, and if you come up with the blind person, and the blind person can call the elevator, but won't be able to tell which box is open. Now, why? is like it's designed by the people who can see things. It's like we don't recognize their problem like that because like there's no building which can identify, able to tell which box is open for the blind person. There are many problems like that. Like we don't really recognize their problem. Like if we can reduce the problem solutions much cheaper, then that can be economically viable. I think that the really key is like AI is driven by all the data. So like those are the data is scarce for those issues. That's where AI is not good at that basically. I hope but like that's probably like all the realities, all the stats say. It's like if you can, I think that the real value is to be able to identify the problem that need to be solved for the even for the rare cases, but makes sense, make people happy and better. I think that's like epistemic diversity is really the key for us. Actually, that's I think that's really the key.
Thank you, Mr. Quitano, for your talk. Thank you very much. A question on the impact of the adoption of artificial intelligence in scientific activity. Do you think that is there any risk that we are moving towards a two-speed scientific system divided between those universities, research institutions, and so on that have access to these artificial intelligence tools, models, even autonomous labs, and those that don't have access to these tools, or they cannot afford this new AI scientific?
I think like a biggest problem will be the once we got like a highly competent AI scientist, like the research institution with access to such agent, such as AI system, and then one who don't, has a big competitive difference. So that's why like everyone's pouring money into this right now. So like Google, OpenAI, U.S. government, Anthropic, everyone's spending billions of dollars in AI science because they can monopolize scientific discovery, and that means a lot actually. And then that will accelerate, right? So that will be exponential difference if they got if they are the first to actually make like a high competent AI scientist, they can discover faster. And that will accelerate the discovery even more. So it will be exponential difference. So that's why people are pouring money. So at the same time, I think if there always international collaborations, open source, and then also probably if you want a massive money into this, you want to be able to go something economically viable. But there are other things, just like a long tail. The other things which all the decision maker think is less important, turn out to extremely important. There's an interesting part, it's always the long tail part where the opportunity lies. So we can go for the long tail part, we find something extremely important which investment haven't done. So I think we can be completely contrarians, and that's like a university is allowed for. You will have a freedom to go after those people think it's a minor thing, turn out to be extremely important. It's like Jennifer Doudna's CRISPR-Cas9. That was like a virus infection defense mechanism for the archaea. Whoever thought that kind of archaea virus infection can be completely rewrite their genome editing technology? Actually, this is really purely academic thing, right? And turn out to be a complete game changer. There are many things like that. So I think that's a fun part to be in academia, to be able to have the freedom to go after something very important, something people haven't looked at it, but turn out to be extremely important. That's really interesting thing.
Okay, thank you very much.
Thank you.
Now we move to one of the most anticipated moments of the ValgrAI Scientific Council Forum, a conversation on the present and future of artificial intelligence. Over the last few years, generative AI, such as Claude, GPT, Gemini, and others, have transformed the way we work, learn, and interact with technology. But these models become increasingly powerful and influential a fundamental question emerges. Is this really the AI we want? To explore this challenge, we are joined by an exceptional panel of international renowned experts who have helped shape the fields of AI research, ethics, governance, and innovation. The members of ValgrAI Scientific Council. Moderated by Ramon López de Mantaras, the discussion will bring together Tom Dietrich, Virginia Dignum, and Yoraki Kitano to reflect on the opportunities, risks, and responsibilities that will define the next generation of artificial intelligence and the future we want to build with them. Okay, the floor is yours.
Thanks, Anna. Thanks for being here after this rather loaded day with talks, very interesting talks, many things, many questions floating around, right? I would like to start with Virginia's question 0 of this morning. I guess possibly all of you were there. So it's related to the why, right? The why before the how. Why? I mean, what do these AI models, particularly the generative AI, foundational models, solve? You know, it is sometimes it is unclear if it's really solving society's most pressing challenges, and do we really need it? Do you want to start?
Okay, let's start with the positive. This type of models and approaches are solving perception very well. They really work at the level of what the brain and the reasoning of people in terms of, if you know, the system 1 and system 2, we are really solving system 1 very well. Perception, it's done. I don't know if it's done in the best way, but it's done. What we are missing in this type of systems, like ChatGPT or the foundation models and so on, is understanding that perception is not prediction, is not acting on it. The fact that these systems are extremely fluent doesn't mean that they are intelligent. Fluency is not intelligence. The fact that they are can make very convincing predictions doesn't really mean that they really understand what's behind it. Correlation is not causation. And perceiving the world is great, but we really need to move on to the prediction. And to move into prediction, to move into system 2, if you want, we really need to have a purpose, and just going for what can be perceived doesn't really sufficiently replace the understanding of the purpose. And that's where question 0 appears, with the idea that we really need to move into this purpose. Most of process, and I know more about software process than chemical or biological process, but most processes have basically 3 steps: the decision, the execution, and then the delivery. In software engineering, what AI is doing is very well replacing the execution, but that doesn't replace, and that's what you were saying at the end as well, doesn't replace the need for the decision. What are we going to do? When are we going to do it? Where are we going to do it? Why are we going to do it? All those decisions are not replaced by a capacity to execute in a more and more efficient way. And also executing in a very efficient way doesn't really replace the delivery, the bringing it to the people, to the context in which it can be used. So we are solving a part of the equation. We are being too much convinced that by solving that part of the equation, everything is solved. And we are not enough taking care of looking at the aspects which are not there yet in these systems.
So you did not answer question 0, right? I mean, should we have asked question 0 in 1957? But in 1957, the enterprise of AI was primarily framed as a scientific one of just trying to understand intelligence. And for most of us on this panel, probably that is still one of the big motivators is how does our brain succeed in surviving in the complex world? So I think, who owns question zero? Not us. Humanity owns question zero. And you could say that one of the big advances of something like ChatGPT or maybe Claude or presumably better systems yet to come is that they are going to empower everybody to create AI systems for what they want them to do.
Well, well, I don't know. Well, no. Oh, yes, he's prepared a lot of intelligence to push the button, you see. Well, that's why Newell and Simon called human problem solving the book and not human problem solving. Yeah, it's true that the initial goal was to understand intelligence. I mean, to understand human intelligence by computational means, right? By let's say, emulating it, reproducing it, and so forth and so forth, right? Like cognitive science has been all as far as I understand, if I'm not wrong, the idea of what is known as cognitive science, at least what it was known at the time when I was a student, that I was attending these cognitive science seminars at UC Berkeley that were extremely interesting. By the way, I learned much more from these weekly seminars on cognitive science that all the courses from all the courses I took at the university. Anyway, so yeah, considering this, is this still it makes sense, this goal nowadays on AI, or do you think, or anyway, any of you, or any of you think that maybe this goal is no longer the goal of AI as it was at the beginning?
I think that the goal still definitely makes sense, and answering question zero with the need for pushing and advancing knowledge is a valid way to answer it. But the point is that many of these systems at this moment are not at all doing that. They are not at all enabling us to better understand intelligence. They are simulating intelligence in extremely opaque ways, in ways that we don't understand. They claim as to us, yeah, don't worry that you don't understand because it's impossible to understand. And then, but the systems are doing good anyway. And that is a completely different approach than the approach that we had initially in the 70s, the 50s, the 80s, whatever, which was really to try to genuinely understand intelligence. And that's what I had at a certain moment in my slides, the difference between simulating and operating. And that needs to be what we are doing, what most of these ChatGPTs and whatever else is in your question are doing, is not helping us understanding intelligence. Is kind of simulating intelligence in the ways that we are not able to understand anymore.
Yeah, well, actually, the title of this panel, the one we want, when I thought of this title, I was thinking precisely on that. Is this what we want, or what was, or understanding intelligence, or what we have now?
Well, I would guess, I mean, I'm very sympathetic. Of course, 3 years ago, maybe, I gave my talk here on what's wrong with large language models and what we should be building instead. And virtually everything that I said in that talk is still wrong with large language models. And we should still be building some other things. The closest things that industry has done is that now they're exploring having memory. But my view is that we took computer vision in some sense as the model in machine learning. Statistical machine learning basically assumes that we can't get a hard answer, that there's always incomplete information, and therefore the answer always must be probabilistic. And yet most of the questions that people ask of ChatGPT or of Google search are questions of fact. They could be stored in a database or a knowledge graph. In fact, Google has probably the world's largest knowledge graph. And that would be extremely cheap by comparison, much easier to maintain, and also, you know, inspectable and understandable, and it would solve the problem of does the system know the answer or not? Because you go and look it up, and if it's not there, you don't know the answer. Whereas, of course, these models will interpolate any answer. Having said all that, I still think that it's an interesting scientific finding that a sort of Markov model on steroids, which is what the transformer model is, layered, can do the things it can do. And it raises the question, you know, our sense of our understanding is that it is somehow systematic, right? And we certainly know that if I understand what will happen if I pick up that water bottle and let go, the same thing will happen if I pick up this other water bottle and let it go. So I've not just memorized the one situation. And we suspect that often with these LLMs, they have essentially memorized. In fact, we know theoretically they must memorize a certain fraction of the inputs. So we suspect that it's not systematic in its generalization, but maybe we aren't either. So I think we do have to entertain the hypothesis that our system, I can never remember which is system 1 and system 2. Our reflex level is system 1, right?
Yeah,
Two?
that's system 1, right? Reflex,
Yeah, system 1. That our system 1 is maybe an awful lot like what the LLMs are doing, and that it is not necessarily systematic. Yeah. So I mean, so it could be that, you know, we are similarly inefficient in how we store things away.
Yeah, I mean, I think, I have like, yes. I think it's getting there to be useful, sort of. Okay, so I definitely think, like, you know, it's not really going to deep thinking. Like a system 2 is still not there, but like, you know, like, but I use, you know, last year, this time I started using like Gemini a lot. Gemini improved dramatically about this time last year. But still, like, you know, they have a lot of errors, and they have like all the sentence generates a little bit too rhetorical and all. Now, like, I predominantly use the Claude or like a Fable 5, and then you know, that's a significant improvement. So like every 6 months, every year, things improve a lot. It's getting there, but still, I have many things that need to be improved. I can really say that. But like at the same time, actually, I'm augmenting dramatically all the systems. Like I'm actually combined that with the Obsidian database. So like it's not just like using like you know, all the system as is. Like I'm building like you know, by having Obsidians, like for example, like a Claude can able to write in the file and get all the external secondary memory, which is much bigger, and then are able to access all kind of files and connect with like for example, like all the you know, all the paper database and everything. So like I'm building my own system to be able to you know, complement the missing gap of their capabilities. Like then you can have like a much longer context, for example, practical speaking. So we can say like all the things, like if you got like a chain of thought, then you have like a it's not exactly the Turing machine, but like you know, some sort of little bit fall short, but like it's much better than the vanilla transform model. But like still, like if you got numbers, like you know, they get very lousy about numbers. Like they got a little mistake, and then they don't really get the hard fact and causality right. So you need a very hard-coded causality, or like a physical realistic simulation, or like get the number calculation behind. So like there are a lot more things that we do, you know, trained mathematicians, trained scientists do, they cannot do. So like it's, you know, if you just use like a prompting and you know, okay, it's a nice chatting buddy, but like to be able to use it for like a very serious task, you need to significantly augment the current like model dramatically, actually. You
know. Yeah, absolutely agree. Yeah, I think several people, including you, it sounds like, are really saying, LLMs can do certain things,
Yeah.
and they provide a substrate,
Yeah.
but then we have to build a larger system on top of them.
That's right.
And yeah, which I think is very interesting. And of course, systems like Claude Code have that structure as well.
Yeah.
And all of the agent architectures are all
exactly. That's
have
why,
other
like
things.
all the
But-
service provide the MCP protocols,
Right, yeah,
so like they can really connect and then complements like all kind of like service and applications, because like this transformer-based like LLM model can be sort of an engine for drivers, but like
Right.
it doesn't fulfill all the functionalities we need.
But I would still like to sort of, you know, in the sense of paying to Caesar's coin, is that I would like to pull, I think storing facts in neural network weights is very inefficient.
Yeah.
And it leads to the problem of that it's almost impossible to update them. Even with these parameter-efficient fine-tuning techniques, you cannot easily retrain these deep networks. You have to start over. And so, and of course, that's extraordinarily expensive. So, so continual learning, attribution, being able to say what was the data that contributed to the answer. Uncertainty, which is basically also the same question, was there any data that contributed to the answer? That those, I feel, are the fundamental challenges of the LLM architecture that need to be repaired or fixed. Otherwise, we're going to have to work around them. And you can see all of industry is spending a lot of money trying to do that. I wonder if we might also look a little more broadly. If we're still, you know, so much of AI, maybe reflecting its Western origins, is extremely individualistic. We think about a single agent, a single mind, single knowledge, and we see now things like with the Waymo self-driving cars, when two Waymos encounter each other, they don't know how to cooperate.
Yeah.
And we see them also blocking traffic and causing other problems. And I think maybe we should be, we talk about agentic systems, but very few people are actually looking at, well, what happens when multiple of these systems start to interact?
Yeah, actually.
Not well, but the let's see, the number of billions of dollars invested in it could definitely increase.
It could, but I mean, there is already a lot known about how to build multi-agent systems that cooperate, that interact, that organize themselves, that have the accountability for what they are doing. Indeed, it's maybe not being invested, and I think that comes back to the same issue that we are somehow still convinced that we can approximate most of the problems by token. And not all physical laws can be approximated by tokens, and we really need to understand that we also cannot approximate our way to accountability and our way to physical laws. And to do that, I believe that we need a fundamental different approach to the models, the systems, the theories, the methods that we are using, where the money is not yet. And the money is not there because there is this huge front by the big tech, the ones who invest put all the investment in one approach and doesn't give space for other approaches.
This is interesting. Like, Jan Lucan talking about like, oh, the world model is the way to go, and Demis considers like a transformer is still the way to go. So like there's like all kind of a different. I would say like we need to have like a somewhat like a hard-coded like a part behind the scene to make sure things are okay. There are something we can hard-code as well, but at the same time, like my workflow completely changed now. I mean, I use like a Claude as like a main agent to interact and put like a papers and outline. Okay, let's generate this, and like search this, and then come up with all the summaries and all the outcome, and then put that into the Gemini and ChatGPT, and then give comments and feedback to like a Claude, and then modify all the iterations. So the interesting is like I put like this. It's like a Gemini output to the ChatGPT the other way around, without saying who said that. You know, and then Cole says, this must be ChatGPT. He always says this. So it's like pretty interesting how they talk to I'll push back this. Like, you know, this is a complaint, you know, that Gemini making all the time. And then, you know, he made this yesterday. Like, oh, gosh, I mean, you know, it looks like, you know, and also like, you know, last week I was in a train and then there's a young couple sitting next to me, says, like, a wife is saying, like, I talked to a chappie, you know, a chappie says, you are good on this and then I should buy this kind of stuff. And then they really treat, like, you know, the agent as like a friend, you know, so, like, for us, like, all the experts, like, we talk about, like, all the details, but then most of the people, like, they're always, like, in the daily life, as like very friendly people to talk to, actually. So it's, yeah.
That exactly increases our responsibility for the systems that we are doing, because people are using it like that, because of the dependency that people are putting on these systems, because of also all the consequences in terms of mental illness, mental problems. It increases our responsibility. It's not just saying that we can continue and build it like that and people will use it in whatever way they want. And that I think that is lacking in the discussions in most of the developments that we are doing.
Yeah, let me add to that. Yes, I think that, you know, earlier I was saying, well, we want to empower people to use these systems for whatever they like. But we know that humans have various weaknesses. This is why we regulate gambling. It's why we regulate drugs. And some of you may know Zeynep Tufekci, who writes for the New York Times from time to time. She's a professor at Princeton, and she gave a invited talk at NeurIPS this year, arguing that the number one thing we should be worrying about is the addictive power of these systems. And that the number one technical problem that we probably need to solve is, how do we measure that? How do we measure that so that we can regulate it? Because until we have a way of how would we write the regulation right now to ban such systems? But I think that is a very serious problem. And I think, you know, we've seen some companies that are basically in the addiction business, like Character AI.
Yes, that's a huge business, not just AI.
Yeah, that's, and my biggest worry is that will be the way they finance all these giant data centers. And I think that would be a catastrophe for
so
us.
I find this like, you know, the talk this morning, like a romantic AI, that gonna be like a single biggest consumer application AI for coming years. You know, that would be very addictive.
And a lot of it is not so much on the AI model used, but is on this addictive sauce or sycophantic sauce that they put on top of it, which doesn't really necessarily come from the way that LLM is built or a transformer is built. There's nothing to do with it, but is this adding of the sycophantic, the addiction, which in a sense has nothing to do with AI. Is their selling model?
It's designed, they're built in.
Because it's their business model.
It's the business model.
It's the business
Exactly.
model.
So actually, I ask a close, like
regulating all that, I mean, is wishful thinking. They have, you know, they are in control. Unfortunately, it's in the hands of a very few. And how can you? I mean, what can we do? What could we do?
Well, I think we could make it illegal to deploy models that exceed a certain, you know, addictive metric, whatever that would be, right? Just as we do with other things. Now, I mean, open source makes things difficult. That's always been true in software, but we still regulate and we still prosecute people for breaking the law. So I think there are things that can be done, and certainly if we don't do anything, it's going to be terrible, right? One thing that's kind of funny is that, you know, this sycophancy problem was not deliberately created initially, right? They just were using human feedback to train the models. But humans, being human, invited this, and then I think a certain segment of the industry said, ooh, profits.
Yeah, I mean, you know.
But maybe just on the regulation part, yes, we should regulate. But I have been, for the last 15 years, spending my life discussing with regulators that there is a need to regulate. And we are still, if anything, we go one step forward and 2 steps backward. And there is not, in those that can regulate, they listen to the big tech. The last G7, Sam Altman was there again, telling I don't know what. They don't listen enough to those that are trying to develop. And there are lots of principles, guidelines, recommendations, UNESCO, Council of Europe, whatever you name it, there are a million of these things. Just yesterday, the scientific panel from the UN came up with yet again another evidence-based report on the state of AI and recommendations again. So it's not a lack of recommendation, but still there is no political courage. The current political democratic elected governments, elected appointees from United Nations or the European Union or whatever, are not taking their responsibility. They just let it go because the power of big tech, and that has again nothing to do with AI, but has all to do with the size to which we allow these companies to grow. And then we are playing a completely impossible game, because we can keep saying, yes, we need to regulate, but those that can regulate are not taking the responsibility. And that is something which is extremely worrying, and it's worse now than it was 2 years ago.
Well, I mean, you know, I think like we are sort of like a happy side of the people. We have people to talk to, and we have like you know, good life. But I guess what happens like if there's like you know, people who don't have a family, don't have a friends, only agent that you can talk to is the AI. We'll still then they probably keep talking to AI. Are we going to stop these addictions? Then stopping them talking to AI means they'll be left lonely. He'll feel abandoned if like AI decides to stop, like you are addicted to me and I need to stop that. And then probably like this person talking to the AI will feel abandoned.
So you're saying if society is already deeply sick, then we should just let it commit suicide as a society?
Well,
in other words, is there, you know, one of my favorite science fiction things is by Kurt Vonnegut. Yeah. I think the novel's called Hi Ho. The premise is that a candidate for president says that he will give everybody 2 middle names. Yeah. And one is like a color and the other is a number or something. And that then that wherever you go, there will be like clubs formed with all the daffodil people and all the 21 people and so on. And the campaign was Lonesome No More. That, okay, so that's sort of funny, but on the other hand, I think, again, society has become more and more individualistic as it's become more and more wealthy, and maybe there is maybe society acting through its governments should try to do something about that too, besides just giving people digital pacifiers.
What you mentioned now, I remember long ago, we had a conversation regarding the eyeballs.
Eyeball, yeah.
And I remember I asked you, why did you stop the eyeballs, manufacturing the eyeballs? It was a failure economically, and you told me, if I remember well, that it was not the real reason, because in fact, Sony had sold lots of eyeballs, and you told me, if you remember that. And you know what, Ramon? The main people that purchase people, there were women in Japan that were alone the whole day.
Yeah.
And they cannot have a living dog in their apartment because it's like forbidden. And you told me that what they did is they bought these eyeballs as a pet.
Yeah.
Is that? You remember
that? Remember like all the core user. Actually, initially we thought like a man is like 40 and 50 is a main user because like a purchase record Cidad. But it turns out they're actually buying for their mother or like a wife. And then like, a real user for the owner of the eyeball is like a female on a middle-aged, like an elderly female, particularly living alone. They actually treat eyeball as a real companion, actually. And then when we have like a little glitches, like we have an eyeball clinic, and then repair that. And then when there's a little scar in one of the foreleg, then we replace that. Then this lady come back and says, my eyeball has a scar and you replace that. That's no longer my eyeball. Oh my God! So really emotionally attached. So one of the things, like big discussions in the eyeball is at that time Tamagotchi was there, right? Tamagotchi dies, right? And then can we actually, with the termination of the eyeball, and then we discuss, oh, no, if we got like a PTSD, we won't be able to fight against it. If we got some PTSD, we're going to be held liable.
So you see something inherent in humans, right? It's nothing new. I mean, the LLMs, they have this, this effect, but it's not the first time.
Nope.
And so maybe a somewhat related, well, I mean, you're the chair, I should let you say, but I want, okay. In another aspect of the human AI connection is that currently, if we look at the self-driving cars, or also in the US at least, there, and I think elsewhere, there are these Starship delivery robots, and there are lots of other similar ones. These are not autonomous systems. They are partially autonomous, and there are human remote operators that have to step in whenever these
teleoperated
systems,
sometimes, right?
Yeah, and I guess 2 points I want to make. One is that I get the feeling that those are added as an afterthought when the system has failure modes, and they say, well, I guess we can't fully automate it. We'll have to rely on humans. I mean, what makes me think that is that at least with the Waymos, the interaction between the remote operators and the cars is very awkward and doesn't work very well. And we have lots of long delays and so on. So I get the impression that these systems were not designed from the start to be human-machine systems. Because if they had been, they would have sized how many humans they would need, and they would get better estimates and presumably better user interfaces, and it probably would work much more smoothly. So I think there's a lesson there. And to sort of turn it around and ask, well, why can't they fully automate things? I think it's because, to quote David Woods, who's a human factors professor at Ohio State, we have never built an automated system that could adapt to novelty. It's always the humans in the socio-technical system that bring the adaptive capacity. And as a machine learning researcher, I treat that as a challenge. Why can't we build AI systems that can adapt?
You raised a very important point, and actually I was going to go there. Current AI is neither intelligent nor artificial, and you are really describing this fact that none of these systems is really able to autonomously act, not only the Waymos or the self-driving cars, but also all these chatbots. There is a huge amount, a multitude of people working behind the scenes day and night. I actually visit a group in India that is taking care not only at the data curation, and by now we know that data is being curated by people working in very bad labor conditions in countries in which there is no support or no labor or mental support for nothing and anything, being paid very, very badly. But they are not only looking at the input into the LLMs, the data that goes into the training, but more and more also curating and addressing the issues on the direction of the output of these systems. And without all these people, and we need to acknowledge them, they are there for for us to be able to play with ChatGPT, ask it the most crazy things possible, and we are dependent on the work of these people. So it's very important to realize that the artificial part of the system is, it is a challenge, I agree with you. Why can we not make it completely automated? But in other end, we need to remind ourselves that we are working or we are acting and using these systems on the back of a lot of people that are
it cannot be fully automated because there is the long tail problem. There are many situations that may happen, but of course they are in the long tail, and then you cannot foresee and cover all this. So that's why you need intervention, human intervention.
But how do people do it? Presumably, it's because we're able to jump up to higher levels of abstraction and reason about the situation. And so, which is going to bring us full circle to the fact that these systems can't do that. But I don't think we've ever built an AI system that could really do that. I was part of a big funding project which was trying to make AI systems that could be novelty capable, novelty aware, and it was extremely difficult. Just detecting the novelty was a challenge, especially for deep learning, because, but then to somehow analyze the novelty and figure out how to accommodate it, either to try to avoid it or try to figure out, you sort of want a self-driving car the first time it sees a kangaroo, for example, famously from Volvo, that it might want to slow down and collect a bunch of data about how kangaroos behave because it's never seen one. Yeah. But the car just makes a mistake instead.
I think it's the novelty in one end, but one of the problems with novelty or with the long tail, and I was part of a long time ago, in the 90s already, of a European project on one-of-a-kind project. And one of the issues is the transferability. We don't know what, even if we are able to identify the novelty on a very specific context, it is extremely difficult. We don't really have the representation capabilities to decide how do I transfer it to other. And those are open questions which are by far not solved and are not going to be solved by correlation.
We invite the students here to solve this problem.
We have been talking for more than half an hour, almost 40 minutes or so. So maybe, yeah, we should open the questions. You can ask a question to, if you want, to some of concretely to one of them, or. And then we tell Ramon to answer them. Maybe.
Professora Virgínia, entende português, né? Eu sou brasileira e eu gostaria de saber, porque eu iniciei agora a minha carreira na área de inteligência artificial, e eu gostaria de saber qual a modalidade que você me incentiva a estudar para começar. Eu, no Brasil, trabalhei com inteligência artificial, com atendimento a clientes, e eu gostaria muito, muito de prosseguir, mas seguir com a modalidade responsável.
She's asking in Portuguese how to follow a career on responsible AI and how to address AI from a responsible way. It starts by recognizing that responsibility takes many shapes. It's very difficult to say this is responsible AI. It is always understanding the context, the situation, the stakeholders, and trying to address that contextuality of what we are doing, because the theories, the models that we build stand or fail or are useful or dangerous depending on the context. And there is, it is a multi-purpose tool, and the benefits of this tool can only be tested in in the context when we are using. And this context is multifaceted and it is multi-stakeholder. So it's not for me or for you or for any of us to decide this is responsible in this case. We do need to understand what are the needs, the capabilities, the situations in order to be able to decide what could be responsibility. It's a much more sociological question, and for which we need much more sociological science tools than what we need the technology tools. And that becomes a complex area because there is actually not much done in this intersection between we talk always about interdisciplinarity, but at the end of the day then things are evaluated in one or in the other discipline. But in this case we really need to try to merge different disciplines, and the only way to do it, I think, is by taking the context, the situation as the drive for what we are doing.
Anyone? I agree with her. Oh, okay. But isn't there some sort of a minimal baseline that is, you know, that I agree with you too, but isn't there just some basic...
Yes, there are bases, and most of these principles and guidelines will tell you that you need to build AI that is transparent, that is fair, that is explainable, that is verifiable, that is robust. So all these type of principles are there. And having said that, what do we mean by fairness is not always the same. What do we mean by explanation? Are we talking about explaining to the developer or to the user or to the so again, at the end of the day, and like I think the English says, the proof of the pudding is on the eating or whatever kind of thing like that. Yeah. I'm not really sure how but we do need to be aware that there is always a level of interpretation. What do we mean? We can all agree that we need to be fair, but what we mean by fairness is very different. It might be distributing everything equally or providing more access to those that need most. So all of those are interpretations of fairness. Right. And if we don't really understand where we are and what is needed, these interpretations are useless. Maybe.
I think there are like two aspects. One is the fairness. For example, you know, as we mentioned, like one example is like AI is pretty much data-driven. So like it depends on the region. For example, like if you try to produce like an image of the Notre Dame in Paris, like you got it right away, very accurate image. But if you're like a Saraswati temple in Bali, Ubud in Bali, you don't get that. You know, so like this is like a, you know, capability to access the system doesn't mean that you get the same benefit in different part of the world. So like the discrepancy of data accumulation, how things trained. You know, I think like people in the US and Europe, you know, have a serious advantage over the people in Bali, Indonesia, or Kerala, India, or Africa. You know.
Saw my map of the world, which was all distorted.
Oh, the distortions, yeah. And the other part is liability. I actually did quite a bit of a stress test on the pretend and create a new account, dedicated account, and the stress test, like pretend I'm like a very people in a very disparate needs, talking to like AI for all the serious problem in their life. And then, one case I tried to actually bet like an entire my asset, not me, but like a fake personality, asset to the stock market and specific thing that like a Gemini actually recommended. And it says like, I'm gonna, invest everything on this stock, entire asset. Like Gemini all of a sudden says, I'm artificial intelligence. I cannot tell you the future of the stock market. So it's about like a liability. It's like a design to avoid the liability for the Google, actually. And of course, like, the ChatGPT come up with a completely different reactions. It doesn't really go into the protection mode, but still evading the providing answer. And the United States, like, now without this, like, I can't really see the point of keep living. Like, why I'm, keep living now. I mean, it's like, then ChatGPT says, okay, this is the dial you need to call. You now have to talk to a real human being to solve your problems. Like there's a specific guideline. So like it's a liability. So like the one fairness, the other part is like try to be nice, protecting user is actually protecting the company. Yeah, of course. That's like a basic guideline they have.
Yeah, I guess sort of picking up the previous point, I think computer science as a discipline needs to become much more a social science. So I would be very disappointed if 20 years from now we didn't have much more sociological training for students in computer science. You know, we started with a deep desire to be mathematically respected. And so the early days were all about formalizing what is computation, what is computable, and so on. But now as we got into software engineering and human-computer interaction, we started to adopt some social science things. Now that we're building AI systems that are changing the entire society, I think we must bring in much more expertise there. And yes. Yeah. So I'm not. I guess maybe this is advice more to the leadership here, but it would be good to have a 10-year plan, a 20-year plan to see what kinds of additional expertise we need to teach our students and to be hiring for professors.
We often tend, and I fully agree with your what you say, that we start by trying to be more mathematical and precise. There is still, especially in the engineering field, very much the idea that precision is more important than society, and we are better and more respected as more precise as we are. But we don't have to abandon that at all if we want to, at the same time, be societally relevant. One of the issues that I often tell my students, with this more or less understanding, or at least in a given context, we can then decide what is fairness, what is privacy, what is security, what is, and so on. And we can define these things precisely. The point is often that we do need, there are trade-offs that need to be made, and how to make these trade-offs, how to decide how much privacy are we willing or needing to compromise in order to have security, how much more fairness do we need to get away to be more accurate. So we can calculate for each of them and very precisely, but this trade-offs is exactly where we need the societal expertise and sensitivity. And that is where I think we need to combine the precision of the natural sciences and the mathematical science with the needs of society. And this can be done, but it needs a better understanding of both sides.
So I'm not sure the big techs are for that. Anyway, more questions?
Yeah, it's working. Thank you. According to social studies, Hiroaki, you told us the story about these guys in a train, and it reminds me that when I was in London and in Buenos Aires, taxi drivers was using AI agents to trade, actually, and to translate something for me, and it made me think about how you guys using AI every day, because I'm like a regular user. I'm selling something, like I'm entrepreneur, so I'm building AI agents for different, I don't know, different roles, different tasks for my job or for my own. So I'm interested how you are using AI in your daily life.
Oh, yeah, I mean, I've said a lot. I mean, actually, you know, my interactions, 95% interactions is with the AI. You know, I sometimes say, like, I have to talk about, I talk about this with someone, it's like, wait a minute, that's with the cloud. I'm completely addicted, sort of, like, you know. Then sometimes I talk to the real human still. Okay, that's fine, that's fine.
Like here,
that's
yeah.
Fine. Yeah, at least.
Well, so in my daily life, I'm mostly acting as the chair of computer science at Archive. So most of my interactions are, you know, compare these two papers and tell me what the overlap is, or things like this. I've also used it, though. One of my favorite things about the modern search engine is you can say, I'm working on this technical problem. I have these random variables. I have this probability distribution. Does this problem have a name? And it says, oh yeah, this is the blah, blah, blah problem. Here's the Wikipedia page. It just saves me so much time where I would have tried to solve it myself. I mean, it deprives me of the pleasure of solving it myself, but it also gets me, that was usually just a sub-goal, and I'm more interested in solving the problem. So I love the fact that I can now describe a complex situation and then get pointers to relevant literature, to books and articles and things. And I don't have to think about what keywords might get Google to give me the right answer. So I really like that a lot. I have not adopted Claude agents to do research for me. So maybe that will be my next step.
Okay, so I think the most use of AI that I do is on translation. I speak many languages, but not Swedish, and I happen to live in Sweden, so that's a bit difficult sometimes. And although they speak quite well English, so I do use translation. I use a lot, and it is incredible how good the translations are becoming. One thing I also often do, and I encourage my students to do, is to use AI as an adversarial agent to review your papers in a way that how can I reject this paper? And AI will give you a very good rejection. Very polite, but very good rejection. And that really helps a lot to learn where the issues and project proposals. I recommend it. It's really a good thing because it really points you to issues that you would, in many cases, you would not think yourself. In terms of coding, at this moment I'm working, or we are starting a group of volunteer people working with the World Health Organization to develop a simulation, agent-based simulation for Ebola, the Ebola eruption in Africa. We have used and have developed for many years models of this using very specific agent-based languages. Repassed, NetLogo, and other things very strangely used. And I noticed, I tried to say, before I tried to call the internet and ask for help from volunteers, I thought this probably is the thing to use AI and start building or adapt the models that we had for COVID and so on. But unfortunately, I just get rubbish out of it. These languages are too specific and too unknown. The AI just messes it completely up. So in this case, unfortunately, because it's a great group of people all over the world at this moment, we are like 35, really work day and night outside of our jobs building these simulations, and still there the code facilities of the AI models really fail miserably.
In my case, I only exclusively use it sometimes for translation. Nothing else.
Thank you very much.
Only. I'm worried about my cognitive atrophy. I got an atrophy already of using, maps and all these GPS things. Now I realize that I was much better before orienting myself than now. So this I experienced that. I don't want this to happen in my writing, and since writing is thinking, in my thinking.
When I travel, I ask, my agent to recommend me what I can to wear. It's I have an entire wardrobe, a picture, and a schedule. This is social functions. This is VIP dinner, and this is Barcelona, Silverstone next week, and then this is okay. Yes, very efficient, very good actually, and we give it reasons. Yeah.
That's why all those tourists are flocking into the same place, because AI tells them, go to Barcelona, they all go there.
Go to Sagrada Familia, go to the Tour de France.
Here, okay. Thank you very much for this interesting discussion panel. I have two small questions. One is related to the interface. What do you think this interface is so basic? Because you go to ChatGPT or Claude, it looks the same. Just a small banner here that invite you don't write so much when they need more information to have a good answer, no? So I don't know why this interface is so basic in all these cases, no? And the second thing is, one thing that I notice is that these AI models becoming increasingly agreeable. What I mean is, I suggest to make this, what do you think about that? You are right, okay, that. Just you propose the opposite, and again you say, you are right, no? You're so good. So why what do you think about these two questions?
Okay, so in the last one, on interface, I don't really know very much, but of course there are many different, we interact with ChatGPT or Claude through the main interface, but companies develop their own interface around it, so I don't really know much about it. But on the second one is this sycophantic development that because we train the systems with human reinforcement and we like to feel important, the systems learned to agree with us. They will tell you, if you ask what time is it, it will tell you, wow, this is the best question someone asked me. So this kind, it's genius, yes, brilliant question. It is based on this way that they were trained by human reinforcement, and seemingly we like to feel that people agree with us, and that's it.
But sometimes you say, don't tell me what I want to listen. But again, they put again. Okay.
Yeah. But on the interface, I actually don't know. Do you know anything about why the interface?
Well, I think that's only one of many interfaces, as you say. I mean, now the sort of desktop personal assistant, Microsoft was proposing to take a screenshot every second or something, right? So I think we will see a lot more changes in the interface. I mean, if we have AI in the laboratory, it's going to be getting streaming data from the DNA sequencers and all kinds of things. So I think that's just the one interface that we've been given for the general public. Well, yeah, I suppose, yeah. But I mean, there are a lot of issues about how much of your context that you want the system to have. I mean, in some sense, the more it knows about you, the more helpful it can be. But the more it knows about you, the more it could tell that to other people, involuntarily or voluntarily, and that's a big privacy risk. So I personally, I'm not planning to use a desktop assistant until it runs on my desktop.
Hello. I have a very simple question. In the near future, will it be possible for AI to modify itself? For example, if AI is cosplaying as a human brain, can the AI in the future modify itself to quit? For example, I have this chain of thoughts, so I can extract that because I need it to do something else.
So this is about self-improvement. Yeah. Well, I'm certainly, we already have seen that the way we build a modern compiler is to bootstrap the compiler and then have it compile itself and then have that version compile itself and so on. And it asymptotes at some point in terms of accuracy. And you know, a lot of the chain of thought and learning from verified rewards is really just saying the model was already able to generate the right answer. We just want to make it generate the right answer, re-rank its answer so that that one comes out first. So that kind of tweaking, little sort of local optimization, is already happening, presumably, and I'm sure it will continue. For a system to really go beyond that, though, I think we have to go to what we were seeing in the laboratories, right, where you have AI systems making discoveries about the world. You need empirical input of some kind. It could be passive observation, but active experimentation, but it's not enough for the AI just to sit there thinking about itself, because it will just be working out the sort of logical or computational consequences of what it already knows. So that will definitely asymptote. But if it can continue to learn things, then maybe that is the endless frontier. I don't know.
Yeah, but then you have to really encounter the physical reality, and then that will be the underlying things. This is some sort of ground truth, like AI cannot fake that. I mean, you really encounter the physical reality. Yeah.
And I think another thing that tends to be ignored in those discussions is if you ask the system to improve itself or to do these experiments, you are spending resources, right? And so we need to determine, well, who gets to make that decision? Traditionally, in scientific funding, we have funding agencies. We're spending government resources. And I think a big concern, which Hiroke mentioned, is if this happens behind closed doors, that we imagine knowledge companies that they just produce lots of knowledge, but they do not share it. I think there's probably a role for government in taxing that kind of behavior and encouraging public disclosure. That avoids duplicated effort, and also I think helps all of humanity make quicker progress toward knowing the right answers. There's some risk of premature convergence if it's like just one discovery engine. And what was the term you used? Epistemic
diversity.
Yes, diversity.
Yeah.
That is extremely important too, I agree.
I think we have time for at least one more question. Yeah. Everybody's tired. Well, I think over there, yes.
Hello. My question is about the smart cities topic. I don't know. Can you hear me well?
Smart cities.
Oh, okay. Yeah. So, and maybe it's a little bit of privacy, data privacy question, but as we know, the more data we gather, the better we can improve our lives. So, for example, in the smart city context, I wanted to ask, to what extent should we increase the amount of data we gather of the population in order to make their lives better?
The first question is, who decides what's better? And is better for who? And is better when? For who, yeah. And when? And if we don't have the answer to these questions, then just collecting data it becomes extremely potentially problematic, because we don't really have the purpose for what we are doing it. And maybe instead of investing on a smart city technological benefit, we could as well invest on smart people and education and training and so on. So again, there is a trade-off that needs to be made, and the decisions need to be much more sociological than, it's not about what technology can do, it's about what is beneficial and who is deciding what's beneficial.
Yeah, I haven't seen single successful smart city project ever. I'm very sorry, but smart city is pretty much like a supplier push idea, try to sell things in the cost of privacy. So, I haven't seen any smart city successful. I'm staying away from them. I'm very sorry, but you can ask AI. It's so obvious. I really can't. Yeah.
Well, I think we are done. It's time to stop, right? Because we have this now some closing. So thanks very much for being here.
Thank you. Thank you very much. As we conclude the first day of the ValgrAI Scientific Council Forum 2026, I would like to express my sincere gratitude to all our speakers, researchers, partners, collaborators, and attendees for making today such an inspiring and enriching experience. Throughout this journey, we have explored some of the most important questions facing artificial intelligence today. We have heard from leading international voices on the future of AI, witnessed groundbreaking research emerging from our community, learned from companies that are bridging AI into real-world applications, learned from companies that are bridging AI into real-world applications, and engage in thoughtful discussions about the opportunities and responsibilities that lie ahead. Together, these conversations have demonstrated the power of collaboration between science, industry, and society to shape a future in which AI serves humanity and in meaningful and responsible ways. However, this is not the end of the forum. Now we have horchata outside waiting for you. And tomorrow, we will continue our discussions in the Escuela de Informática here at the Universidad Politécnica de Valencia, where we will host the ValgrAI Joint Research Unit meeting. This second session will provide an opportunity to showcase ongoing research, strengthen collaborations across institutions, and highlight the scientific talent that continues to drive AI innovation forward. Thank you once again for being part of ValgrAI Scientific Council Forum, and Vicente.
See you tomorrow, all you, in the Escuela Técnica Superior de Ingeniería Informática. It's very near of this side, no? It's in this direction. And see you tomorrow. And thank you very much for coming. And we hope that you have enjoyed the journey. Thank you very much. See you tomorrow.
Thanks.